Once again, I'm Brett Peterson. I was the last winner of the NewSpace Business Plan Competition. So today I look forward to passing off the torch to the next winner of the next round. Also today, as we kick off our event, I want to thank the Thunderbird School of Management's Executive Master of Global Management in Space Leadership, Business, and Policy for their generous sponsorship of one of our lectures today. If you'd like to become a sponsor, simply add a sponsorship to your registration for our next event. Yesterday's conversations covered a lot of ground, and we're glad you're back for another day of programming. Later on, we'll have a special Saturday Space segment, and Leo has put a link in the chat to the music video we'll be talking about, so you can watch it anytime between now and then. I think Leo has already placed that. If not, I think that's forthcoming here in a second. Otherwise, since we're jumping right in, our first conversation today will be between Tim Chrisman and John Weathersby. I'd like to introduce both of them here. I think you're pretty familiar with Tim, but for those who are just joining, I'll give his intro again. Tim is the executive director and co-founder of Foundation for the Future. A former CIA and Army intelligence officer, Tim supported the National Space Council and the Joint Staff of the Pentagon. He holds master's degrees in intelligence studies and international relations and affairs, both from American University. Mr. Chrisman is the author of the book Humanity in Space and of various articles about the expanse of our civilization in space. Tim's next mission and challenge is to make space accessible, survivable, and ultimately routine enough to be boring. John Weatherby has decades of experience building teams of experts who solve complex problems through innovative thinking and successful collaboration. Over the past 20 plus years, he's founded and managed multiple organizations, leading to the development and commercialization of technologies in the field of open source software, cybersecurity, unmanned vehicle systems, and nanotechnology and healthcare. He has succeeded in securing over $20 million in commercial and federal program funding, and has been recognized as one of the top open source influencers in the US government. He is currently focused on the commercial space industry, developing a diverse network of supply chain vendors and improving their business opportunities. Tim and John, thank you for joining us this morning. Welcome.
Thanks, Brett. Great to have you here. And excited to see who tries to unseat you as reigning champion. It's unfortunate we don't have these sort of head-to-head contests where we can do those sweet little boxing fight posters for the different leaders of the businesses. But excited to be here this morning with John. John and I have been talking on and off now for the better part of a year. He's one of the people who early on with the foundation found us and has been a fantastic source of advice and insight as we've gone along and grown. And I'm excited that with this event sort of highlighting our 1 year birthday, that we're able to bring in someone like John to open up the day and talk about Stellar Modal Transportation Association, the new organization that John is in the middle of standing up. And before I jump into any more questions, John, I want to just give you the floor for a second to see if you have any more you want to add to your intro.
First, can you hear me? Okay, comms check. Welcome to the Bat Cave. Living, working at home. My wife asked if I can put any more computers in my little office. I've obviously run out of desk space. No, I'd just like to start off by saying thank you for letting us have opportunity to speak and congratulate you and the entire staff on the phenomenal job you guys have done. You and I are doing the same thing, and tell everybody, this isn't easy. You wake up and make it up every day. So the level of just tenacity and consistency and quality in things that you guys are bringing to the table are incredible. And we're thrilled and honored to be to help in any way possible.
Yeah. No, thank you, John. Thank you. We're seeing, events like today really, they may have been started by me, and I mean, sure, you see this with what you're doing, but you may spark something, but then somebody like Lee Steinke comes in, takes over, and makes it epic and amazing. And so I don't want to talk anymore about stellar modal. I want to know what it is. Tell us more about it. You and I have talked a little bit about it, but let's jump right in.
All right. So stellar modal is Stellar Modal Transportation Association is it's a trade association. It's a 501c6. It's international, and its purpose is to do what trade associations are supposed to do, and that is how to help facilitate business opportunities. The old adage that a rising tide lifts all ships, that's what an association is supposed to do. It's different than what you're doing. You're a research-based group, and you're attacking the one set of problems, and we're looking at another. And that's one of the things that's so important to us in our relationship with y'all and everybody else that's on this event and throughout this industry, is that there are enough challenges and there's no binary way strategically to solve them. So when everybody goes at it and works collaboratively, then we can get there. And you and I have built a good collaborative relationship. We're looking at other organizations because, you know, when you get provincial, you get focused on just me and mine, and you forget that a team is not made up of quarterbacks. You know, you've got to have the pulling guards, you've got to have the receivers, you've got to have all that. And when we can build a network throughout the industry of folks that know each other and work with each other and hopefully like each other, then it's going to make this whole process a lot better and a lot more beneficial and profitable and likely successful for everyone. So we're a trade group. We started looking around when we kind of got in this space, and we were looking for a gap that wasn't filled. And the term stellar modal came up. It's a created term. As Bio said, I've been a defense contractor for 20 something years. So one of my DoD clients, we were trying to, we're working with the Port of Gulfport, Mississippi, working with Transcom, and trying to get Port of Gulfport designated as a strategic seaport. And that's where I got a deep dive into intermodal transportation. Intermodal transportation is simply shipping cargo using multiple modes of transportation. Yeah. So what in that process, I learned about how diverse it is, and the supply chain and the logistics are what keeps it going. What did Napoleon say? You know, an army marches on its stomach. Yeah. So yeah, we're doing exploration, then we'll do colonization, then we'll do commercialization, but it's the grease in the gears. Yep. It's all the people that you don't see that's going to make this thing successful. Because for every one rocket, there are 10,000 people that worked on it in some capacity, and not everybody's a rocket scientist. So, you know, you've got to look out and say, okay, where are these different pieces? Where they fit in? How do they work together? So that's what we're looking at. In a lot of ways, it's a real low tech, but it is we say that we're about the business of space commerce. Yeah. You know, at some point, it's got to go from public sector government funding to, okay, how's this making money? And that, when we get there, that's when it'll become an industry, and not just a, you know, government-based effort. Yeah. So,
no, and I think what you're talking about, like with, you know, the 10,000 components, each with their own unique manufacturing style and needs, being distinct from that rocket scientist who came up with the design for the rocket, is really on theme for this month, where we're talking about how do you look at workforce development for space, because every kid in school, when they get first talked about space to, they're thinking astronaut floating around. I've got to, be a fighter pilot, or I've got to be the smartest person in my state so I can design the next generation, insert cool tech here. But in many cases, it is that supply chain that is enabling those 1 and 2 off exceptional people to do everything else. And they are, without that, there's nothing that happens. I mean, I spent a decade in the Army. Most of it was special operations. And the vast majority of what we did was making sure all of the stuff that people think is boring is ready to go. And that's an awful lot of bag packing and cleaning stuff and working with 1,000 different suppliers to have everything ready. And that's exactly what space needs. So that's exciting that Stellar Modal Transportation Association is looking at that. And you mentioned you're a trade association, and from your description of Stellar Modal, it sounds like it's logistics focused. But what else is there to the focus that I'm not getting? And what are the objectives?
All right. So everything that we do, we try to look and say, okay, instead of just going out and being, we just don't want to. We don't want to just have group chats.
Yeah.
There are people that do that. So what we try to do is we try to identify the horizon.
Mm-hmm.
Where are we going? Where are we going in this market segment? And then back that down to the 10-meter target to say, okay, what are the few steps that we need to take right now? What are the challenges? What are the gaps? Mm. And really we try to look at, okay, what are the non-sexy gaps? Okay, yesterday I was fascinated, when Dallas and his group were doing the talk, and I'm thinking, okay, my brain's bleeding here, trying to figure out how these guys' brains work. And they're on literally another planet. And then it's like, okay, that's great, but how do we get the systems? How do we build the launch pad? How do we get it up there? And then it all goes back to transportation, at least at this stage. In my simplistic view, you're looking at the industry from a realistic perspective, you're looking at transportation elements or life support. Yeah. We haven't gotten to the point yet. Yeah, you've got some satellite business, whatever, but we haven't gotten to the mining part. We haven't gotten to the colonization part. It's science right now. It's theoretical. Yeah. Okay, that's great. We're going to have to focus on getting there and helping to realize the dream that these brilliant people are putting out there. And then from a logistics perspective, I start thinking of all the things that can go wrong because, space is not your friend. Yeah. I mean, you've been in parts of the world where everything there's trying to kill you. Space is the epitome of death itself.
Oh, yeah. No, I mean, it sounds very much like Oregon Trail. You're trying to.
I was thinking about that, but you know what? It's even before that. It's like the 1500s when people were in Europe, mm-hmm. and then they were going to a place that was over the horizon they couldn't even see. Mm-hmm. But the difference is, and I apologize for getting philosophical here, but the difference is that when they got here, they could still breathe the air. It was full of resource. They had water and everything else. When we go outside our atmosphere, we're not designed to go there. So we've got to take everything with us. And like all these smart people are saying, okay, water, we take water for granted here. Not only do we need to find it, but what else can we do with it to turn it into fuel and, reuse it and yada, yada, yada. Oh, good grief. So I'm glad they're dealing with that. We're going to focus on the simple things like how we can find more people like y'all to work with, to reach out and say, y'all need to support Foundation for the Future because Tim and his team are trying to build and maintain momentum on Capitol Hill. Dude, I don't want that job. Good on you. That's a heavy lift, but somebody's got to do it. Okay. That's y'all's. We're over, working with the small businesses and trying to help the companies that are building rockets, that are doing stuff, the mid-tier, lower tier guys.
Yeah.
How can they find workers? How can they find non-STEM workers? That was a great point that Eric with Scout brought up yesterday. You need non-STEM people. You've got to diversify. You've got to look. Okay, well, how do you recruit these people? Okay, so we need to be able to reach out to the technical schools, to the community colleges, and tell them that you don't have to be a rocket scientist to do this. We need welders. We need pipe fitters. We need electricians. We need administrative people. We just need smart people with innovation and with drive. And then, then you've got a highly skilled workforce. How do you keep them? Right now, everybody's going to pay top dollar because it's a new thing. But if I'm an environment, if I'm a company and I've got, 100, if I've got 10 highly skilled people, eventually you're going to be able to pay the same. So what can I do as an employer to keep those guys?
Right.
So one of our other elements that we're involved is healthcare, and how companies are addressing healthcare needs for their workforce. Okay, we're connecting the dots.
Yeah.
So sorry, you got me excited.
No, this is exciting. And I mean, it was talked about yesterday, and what you're just talking about with the non-STEM workforce. This is exactly what. It was so cool to see how excited Representative McCollum got earlier this year talking about this, because so she's the chairwoman of the Defense Appropriations Committee, and we were talking with her and her staff about this giant gap. We say STEM, STEAM, great, it's important, we need it, yes. What about the career and technical education fields that are at the community college level? What about them? Where do they get the support from government programs, from industry, from just publicity? And so, seeing her get so excited and then insert language into the Defense Appropriations Bill for this year, mandating that the Defense Department create a pathway for those career and technical education fields, including space, is awesome, because, working with you and then others in government is exactly what's going to happen next year, when DOD's got to come out to us and start working to figure out this plan.
And Tim, so much of it, money doesn't solve all the problems. So much of it is leadership.
Yeah.
Just helping people understand that there is a pathway.
Yeah.
You want to be in this space? Okay, then do it.
Oh, yeah.
Here's how you can apply it. And also being able to open up connections and share. That's another thing I really enjoyed about working with you guys, is that we share resources. What can we do to help put your message in front of the people we're talking about, and vice versa?
Yeah.
Like we were talking, can we say that you and I are talking about doing maybe some cybersecurity events down the road?
Right. Yeah.
Other things. Okay. Cyber, people look at cyber like it's just a terrestrial thing. Okay. Well, right now we're working with folks that are small companies that are getting hit by ransom. Okay. What if you're a company that's got millions and millions of dollars invested in a space-based project, and somebody comes in and locks down your data? You're dead.
Yeah.
Okay. Yesterday, someone was talking about their, maybe the Scout guy again, talking about how they kind of got spun up because they sent up a satellite and it just, it disappeared. Nobody knows where it is. Well, okay. That is a highly vulnerable situation. And that's something that you got to plan for now.
Mm-hmm.
The solutions there. It doesn't necessarily take something new to do it, but you've got to know where the resources are and how to apply them. And we watched these type of events and we thought, oh, that's a good point. Let us go see who we can find over here that can solve that problem, or at least provide a potential solution. and then let the market go where it will.
Yeah. No, and we've been talking with Amazon Web Services now for a while about trying to figure out how to do just that sort of talking about that, providing educational services. They're really excited to get into providing cybersecurity and cyber training for satellite operators, because of, they're also looking to operate satellites.
Sure.
And so yeah, I think the event we're talking about building is going to be pretty exciting. Maybe that'll fit into a conversations theme for the month. Maybe we just do a standalone event. Yeah, we'll have to. It's gonna be fun. But I mean, we've been talking a lot here, and I know we've only got a couple minutes before Tom comes in with the business plan competition. But who all's involved with Stellar Modal right now?
I told you that when we looked at getting in this space, we said, okay, what problem sets?
Yeah.
And then I've done this a couple of times. I built a trade association back in the early 2000s, focused on the adoption of open source within U.S. federal government. And then we did technology transfer stuff coming back from global war on terrorism. So we kind of have seen this process a couple of times. So we reached back and pulled in several of the people that we had worked with then. And we said, okay, what lessons did we learn? Go pull out the after action report. What lessons did we learn, and how can they apply now?
Yeah.
So we have someplace hard to start. So we've got like one lady named Linda Curtin. Linda was the CIO of big NASA, and she's just a wealth of information. And so, we have her on board. We've got, like I said, cybersecurity experts. One of my buddies was a counter intel guy for the FBI. He's a big cyber dude. So he looks at it from that perspective. We've got DoD program specialists. We've got exotic materials, a lot of the graphene and 2D guys, scientists and researchers. We've got international business folks. We've got a lawyer. We've got a cat herder, which is me. So, we put the team together to address the initial group. And now we're going out and we're engaging with different, like with DoD elements. What are some problems that you have that nobody wants to touch? Okay, let us go find people that can do that. And that's where we're building our membership and support from, is we're trying to make it transactional. So, we need your support, but what we really want is your participation.
Yeah, that makes sense. So I want to give a minute here. If you have anything else, Brett is ready to ask a question, it looks like. So
I wish. I'm loving this conversation, but I do know I'm trying to keep track of time for us. I know it's coming up here right on the hour. So
you're good.
Tim, if you had that last question, or otherwise, yeah, we'll. Okay, then Tim and John, thank you so much. Again, I hate to cut this off because we're just getting to the part where I was like sitting on the edge of my seat. What are the problems that nobody else wants to touch? I want to hear more about that. So that's maybe we can have some follow-up questions or something later.
Hey, thank y'all. Appreciate it. And keep doing good work. Y'all are making a big difference, and it's very much appreciated.
Thanks, John.
Thanks very much, John. Tim and John, thank you so much for the great discussion. Next up, we've got Tom Olson and the NewSpace Business Plan Competition. So Thomas Andrew Olson has been the program director for the NewSpace Business Plan Competition since 2011. And I see you're here on the camera now, Tom. So I will say welcome. Good to see you again. Good to have you here. So I just want to describe the business plan competition. I'm a personal beneficiary of it. Helped start my company. I'm a huge fan and a huge supporter of this whole endeavor. So Thomas, I'm really glad to see you here again. Over the last decade, the business plan competition has awarded over $350,000 to deserving space-related early-stage companies. And Thomas is a founder of the Center for Space Commerce and Finance, which sponsors the business plan competition. For over 3 decades, Mr. Olson has been a business systems engineer and analyst in the communications, aerospace, and publishing sectors. In addition, he spent several years in the finance services sector around cash and fund management, and he served on the original organizing committee, the Space Investment Summit, which are events that brought together interested investors and space entrepreneurs for knowledge sharing and professional networking. From 2006 to 2010, he was a regular contributor to the Space Cynics blog, fighting against the ignorance, obfuscation, and boosterism that often pervades the new space sector. Today, he serves as Director of Business Development for Avialto Limited, an early stage firm that will soon provide high altitude platforms distributing internet and mobile services to underserved areas around the world. He's also chair and founder of the not-for-profit Center for Space Commerce and Finance, the new owner of the NewSpace Business Plan Competition. He's also an all-around awesome guy. Thomas, welcome. Good to have you here today.
Okay, thanks so much for that great introduction. It's always a joy to see Brett. He's like this perpetual grin on his face. It's like he's just completely happy with his existence, and life is going really well for him. And I just wanted to ask you really quickly, how are things going with you? Because since you won the last time, how did that help you at all, if it did?
Going great. Actually, this past weekend, my other co-founder and I went up to Michigan and bought some equipment to finish setting up our pilot facility. So we're moving forward. We put in our application for the Deep Space Food Competition. So we're moving forward with that, and we're hoping to be in revenue by January 1st. That's our target. So
that's great. That is absolutely great. I'm glad we could help in our small way to get you kickstarted in that great direction.
Thanks very much.
You bet. Okay. A couple of things. They're always, we never do these things, glitch free, unfortunately. As of right now, I got two issues I need to just tell you about really quickly. One of our judges, Dave Heineck, is having trouble getting in to the Zoom call. So Layla or Lee, if you can find a way to help him, that would get in here. That would be really great. Since he's kind of involved right now. Also, I want to say that while we have four really great teams that are going to be presenting this morning, we did have a fifth scheduled, but I got word from that fifth team, which is Space Enterprises out of Perth, Australia, that there's been, I knew this, since the weekend, there's been some serious illness ravaging his household. And apparently as of this morning, he's gotten it himself, whatever it is. Hope it's not COVID, but in any event, they won't be presenting today. So we have four really great teams I'm going to introduce to you here in a minute. But first, before we start, I always try to start to say thank you. I say thank you to Foundation for the Future for sponsoring this great event and the $5,000 grand prize for the winner of the competition today. I also want to thank all our great coaches for all their assistance the last couple of weeks in working with all the finalists and in polishing their pitches and improving their chances. They all did a great job. Jason Held, Kevin Russell, Jeff Kruken, Michael Lane, and Robert Jacobson. Thank you so much. At this point, I want to very quickly, I hope we see David really soon. I want to introduce our judges who are with us today for this event. Eva Jane Lark, we'll start with her. She's a vice president and a wealth advisor with BMO Nesbitt Burns, which is one of Canada's largest full-service investment firms, and she's provided expert advice for over 25 years to her clients. But she's always had a childhood passion for seeing humanity live and thrive beyond the Earth. Hi, Eva. Lovely seeing you again. It's always a pleasure to work with you. She's been a coach, a presenter, an invited judge for the NewSpace Business Plan Competition for many years now, and I'm really so happy she was able to join us today. Dave Heineck, who we're trying to get in here now, he's having a problem. Well, there he is! Yay! Hello, hi, David. How are you?
Hi, Tom. I use Zoom every day, but go figure.
Yeah, it happens to everybody, but you're here just in time. Good for you. Thanks. Dave Heineck is actually a serial entrepreneur, a business thought leader, and a NetSuite subject matter expert. He's the founder and president of Business Fitness, a NetSuite success agency based in Milwaukee, Wisconsin. And for 2 decades, they have been helping high-growth firms. And their services range from implementing NetSuite for the first time or assisting companies in getting the most out of that software. Now, I've known Dave going on about 2 years now. We met at a space investment summit in Seattle in 2019, and I know he has the space bug, and he and I have worked together multiple times over the past 2 years as coaches for our events. And I thought it was time to turn the wheel and give Dave a shot at being a judge this time around. So I'm really looking forward to hearing your insights, Dave, on the teams you're about to see today. And finally, my good friend for many, many years, he's also been a great coach and a judge in the past, Amaresh Kalapara. He's been advising and assisting a new generation of space entrepreneurs since 2006, navigating the world of venture finance. And he also thinks that the next 5 to 10 years of space industry growth will dwarf the past 60 years history of the space economy. And I'm sure we're going to have a lot more conversations about that. He and I, and maybe all the rest of us, as time goes on here over the next few years. But there's something I didn't know about him before, or I just did pick it up. He is an Emmy-nominated VR producer, and as well as a space industry executive. He led a project at Facebook's VR company, Oculus, called Mission ISS, which is conducted in collaboration with NASA, and is a true-to-life virtual reality simulation of the International Space Station. Before that, he was a founder and managing partner of Earth to Orbit LLC, a satellite industry advisory firm that helped spearhead the launch of commercial satellites out of India. Today, he's a strategic consultant, and he's the chief revenue officer of Off-World. Amaresh, welcome. And your mic's off, but that's okay. We'll just wanted to give you a chance to say hello briefly. Hello, I'm waving at you, Amaresh. I see you. Okay. Here's you're kind of glitching in and out, but I'm sure things will clean up. Here's what we usually do. Now I'm going to break from one standard protocol we generally do most of the time when we've done these things over the years. And just as an aside, this is actually the 20th BPC event that we have done in the last 11 years. But I'm going to break with protocol just a little bit for this one because we are so far reaching. It's all in virtual world and it crosses multitudes of time zones. Normally, I would have everybody, have the finalists just present in alphabetical order by the name of their company. Today, I've decided to do things a little bit differently because we have people from people the farthest away to the people closest to us. So we're going to begin our competition today with Esper Satellite Imaging. Shoaib Iqbal is with us today. And in just a second, I'll have him share his screen and he can do his pitch. A second here. I want to do that. I want to be able to see it. There we go. Okay. Now the rules are going to be this. You'll be on a timer. Every presenting team gets a chance to do their pitch deck for 10 minutes. More than 10 minutes, I'll cut you off. And then the judges in turn get a chance to question you as they will for another 9 minutes. And then we go to the next team. And may the best team win. And good luck to all of you. And so Shoaib, if you can share your screen and put up your deck. And you got your microphone on.
Definitely. Thanks a lot, Thomas. Just making sure everyone can hear and see and hear me and see my screen.
I would normally say good morning to everyone, but I have to say a double good morning to you because it's actually Thursday morning for you. So thank you for staying up so late to make this happen. It's going to be great. Okay, so I can see your slides. I presume everyone else can. I will start the timer when you start talking.
Awesome. Thanks a lot, everyone. Today, we are presenting as Esper Satellites. We're a startup that's delivering intelligent data from space for industrial efficiency on Earth. The reason why we're tackling this specific problem of industrial efficiency is that because we've noticed that in a lot of resource-dependent industries such as agriculture and mining, they're losing productivity year over year. In mining, we've noticed around 25% year-over-year reduction in productivity and around 44% in agriculture in terms of how much harvested crops are lost. We've recognized by working closely with these industries that a lot of these problems are caused due to lack of actionable data available to them. While they do have IoT sensors on the ground telling them the movements of their trucks in mining applications, all the way to having ground controls, ground sensors for agriculture, that data still falls short in terms of what they actually need to make their day-to-day changes. So what we've come up with to help solve this problem is a data stream of our own, a data stream that can help map every single part of the field that we're imaging and basically tell us the material makeup of these pieces of land. This has manifested itself as a network of satellites capturing hyperspectral imagery of the Earth. Now, hyperspectral imagery is a technique where we capture light in hundreds of different wavelengths, and we use this data to derive the material compositions of the things that we're looking at. Now, in agriculture, we can look at material compositions of the soil, and this can give us an indication of soil fertility. And in mining, we can look at the composition of the surface of a mine, and this can tell us about the traces of minerals and where exactly they are present, helping us all the way from exploration to the actual operational efficiency of the mine itself. And this also spans into other applications in oil and gas and maritime, where we can track either gas leakages or we can track oil spills on the surface of the ocean. Now, if you dive deeper into some of these applications, agriculture specifically, we can use this data to accurately map out fertilizer requirements, because now we know exactly where what the material composition of the soil is. With this data, we can create a heat map of sorts where we can essentially map out what part of the land is missing what type of fertilizer. This can give us a lot of important metrics, along with helping us monitoring the plant health. And these all important metrics altogether can help us predict yield of the overall crop land that we're imaging. We've estimated that this can save around 40% of cost in terms of how much manpower and how much material is to be deployed on the crop itself. Since 2019, we have around $78 million worth of commitments from data analytics companies who want to use our imagery data for their own customers. We have around 6 letters of support and 7 partnerships with similar businesses. We currently have a paying contract with a mining firm where we're going to be imaging their land as an aerial test of our imaging technology before we send it up into space to map out the concentrations of different minerals on their land. And we've also raised around $132,000 from a smaller pre-seed round earlier this year. Now, speaking of data analytics companies, we are directly selling to them through one of our revenue channels, where we have a pay per square kilometer model. Essentially, all of our images have a reference point on the Earth in terms of the area that we're imaging. And per that area, we put a dollar value on top of that, and that is how we sell portions of our images to the users who want them. Now, we have 2 data streams. One that I've mentioned is direct to user, where we have analytics businesses and governments. And the other one is direct to resellers, who then resell our imagery data back to these analytics businesses and the government as well. The reason why we're doing that is essentially to diversify our reach in terms of how much revenue we can be generating from the data we're capturing. Now, the data that we capture is sent down to our server back on Earth. That's where it's processed, and then that's where we actually start selling our data. In terms of the actual pay per square kilometer model, the industry standard has all been to have a minimum order quantity on top of it. But what we're doing is we're trying to keep a tier-based pricing model to have smaller stakeholders help them have easier access to this data. We start with around $15 per square kilometer for an order size that is less than 100 square kilometers. We've seen that this works really well for much smaller farms and much smaller mining areas. And we then go up to a smaller price point per square kilometer for orders that are larger than 50 square kilometers. This is for stakeholders who are imaging millions of square kilometers every week, and they want some competitive pricing to have them run their day-to-day operations efficiently. These are some of the customers that we're working with. Space is an agriculture customer who delivers agricultural insights to farms across India and Southeast Asia. Actuary is an Australian company that delivers financial risk insights to agriculture commodity holders. Tatia Earth is using imagery data, wants to use our imagery data to map ports and map metal manufacturing sites to basically deliver indices on metal production all across the world. And Orbital EOS is one of our analytics partners we're working with in the maritime and defense sector. Looking at our unit economics, one of our satellites, along with the imaging technology that we're building, will cost around $2 million to build and deploy. The operational cost of it per year is going to be around $200,000. But in the first year of the satellite's operation, we estimate it to make around $3.3 million worth of revenue. We estimate to have around 18 satellites by 2025. This will give us around daily coverage of the entire Earth, and per satellite, we aim to have an 8-year lifetime. Looking at the agriculture and forestry markets, our beachhead markets, our TAM is around $4.12 billion, and our SAM is around $366 million, only looking at those markets within Australia. We estimate this to double by 2024. And the reason why hyperspectral sensors have not been deployed the way we're trying to build this mega constellation of them is mainly because of the size of these sensors. These sensors are still fairly bulky because we need a large aperture to capture a lot of light, because we're capturing multiple wavelengths from the data that we're collecting. Now, previously, the launch has always been the highest cost for this, but now because the sensors are getting smaller, but also with that, the launches are also getting much cheaper. That's allowing us to actually build these sensors at a much lower cost and deploy them at a much higher volume. While there are other companies that are working, that are trying to build hyperspectral constellations, Pixel and Satellogic being some of the leading ones. Pixel is a Bangalore-based company that is going to be launching their first satellite within the next year, and Satellogic has already launched some of their multispectral satellites that do have some hyperspectral capability. The reason why we stand out from them is because we're aiming for a much larger spectral range. We've talked to our customers and we realized that having that the spectral range that we're going for, which is deeper into the shortwave infrared spectrum, gives them more insights in the lands that they're imaging, especially in the agriculture and mining sector, which are the main sectors that we're going after, including forestry. So looking at our product roadmap, next week, we're doing a TRL flight demonstration test of Espresso. That's the imager that you see pictured there. That is going to be flying in mid next year on two of Espressos are going to be flying on hosted payload platforms mid next year by June 2022, and they're going to be space qualified by the end of the year. But in January 2023 onwards, we're launching something called Esperoco. That is the IP that we're generating, which is the sensor and the image optical setup along with that allows us to capture that larger spectral range. And behind all of that is us. I'm Shoaib, I'm the CEO. I've built and flown high-powered rocket payloads. I've worked as a payload engineer across 2 high-powered rocket teams and am a 3-time startup founder. Joey, our CTO, is a mechanical engineer who's previously co-founded a medtech startup. He's also a 3-time hackathon winner. And Munji, our VP of engineering, is an electrical and computer systems engineer who has a research background in autonomous systems and machine learning with drones. And currently, we're getting ready to raise a $7 million seed round to launch our Esperoco imaging payload by 2023. This will be the first installment of our imagery infrastructure and help us deliver to the $78 million worth of commitments that we currently have. And I'd love to connect with, and I'd love to tap your networks to help us accomplish this milestone. And that's been us, and thanks a lot for that.
Okay, Shway, thanks so much. You got in under the line there, and you did really, really well. Thanks. Okay, now we're going to start in. If you might want to leave your slides up just to, in case the judges have certain questions, and I want to start right away. Eva Jane, what are your comments?
Sorry, always the unmuting process, right? Okay, I guess I know of more hypospectral satellite companies than you have put in your competitions. So one thing is I think there's actually more competition, but I wonder about how localized these markets are. So you said that you're focusing on Australia. I'm in Canada, so the companies that I know are more focused on Canada. So I'm thinking about this in terms of, are there local areas that you can focus on as opposed to the whole world as a market?
We have definitely seen an uptick in a lot of the demand locally here in Australia for the type of imagery, for this type of imagery. And speaking to our customers specifically here in Australia, there is much to be desired from what is being captured globally, which is essentially why we are sort of a local solution to some of the problems that that they're having here specifically. So in terms of the orbits that we choose, in terms of the technology that we put up for the problem sets that we have here, we can specifically tailor that to a lot of our customers that are within Australia. Most of our majority of our customers at the moment, while some are in Australia, are spread across Southeast Asia and South Asia as well. So for us, it does become a challenge in terms of how we should be designing our system to serve our initial customers first, and then we can start expanding globally. So we have noticed this be a local problem in terms of what type of satellites are currently up there and what orbits they're serving, and consequently what geographical areas that they are serving. And for us, as mentioned, our customer base is in Southeast Asia, and Australia. We are trying to serve them first in terms of the orbits that we are choosing for our first launches.
And so the orbits that your satellites are going to be in are focused on the Southern Hemisphere at the moment. That's fair to say?
That's correct.
Okay, thanks.
David, what do you have?
Yeah, I too have to unmute. I'm interested in hearing about, you have a potentially huge number of customers, potential. I'd like to hear more on how you plan to get them, and how do you market yourself? How do you address, how do you get to your customers?
Yeah. So most of the customers that we're aiming for are the data analytics companies themselves. So these are the companies that know what type of data that we want to be offering and how they can actually utilize this data. So through those analytics businesses, then we're reaching out to all of these larger industry verticals that I've spoken about, whether it be oil and gas, agriculture, and mining, all of these smaller stakeholders, from all the way from farmers to miners to all refineries and the companies that are managing them. So we're using these analytics businesses as a conduit between our imagery data and the intelligence and the value that can be generated for using our imagery to these final customers. We found that to work much better than us packaging an analytics service ourselves with our own imagery data. And then going after these stakeholders in all of these different industries, because there's always different processes for different verticals, especially if you're looking at different geographical areas. So we're using these analytics businesses, who are much smaller in number compared to the amount of farmers and the mines and the oil and gas companies that we have out there. But because the number of customers becomes smaller, we are still serving that larger market because our imagery is still being used through them as a conduit to these much larger verticals. So we're using that strategy to basically go out and capture the much larger customer base in those markets. But because these analytics companies are very, again, as you know, going back to the previous point, they are quite localized. It does make us help us. It does make it easier for us to reach out to those who are much more local and closer to us geographically. That is some of the strategies that we have in terms of how we want to be commercializing the data that we capture.
Where are you actually located? Sorry, Dave, I'll give it back to you.
Oh, no
Where
worries.
are you actually located?
We're based in Melbourne, Australia.
And then in terms of these data analytic companies, what does that universe look like? How many of those firms are out there and so forth?
So the market with the value-added services or the analytics services that comes with this imagery data is actually much bigger than the market for the imagery itself. Like in some of our estimations, as I've shown, our TAM gives us around 4.12 billion, but some estimates show for the value-added services to be around 14 billion. Now, this is obviously along with all the other trends as space becomes the data from space becomes a lot more accessible. There's a lot of these analytics companies, whether they be startups or much more established SMEs as they're coming up. The market around that is expanding. Right now, we can see it's somewhat smaller, and it's easier for us to go out and reach out to these customers because they are comparatively new in the market. But because this market is also growing, and pretty much a lot of the firms, whether it be a lot of the agricultural firms, are now trying to have this type of analytic services in-house as well. They're turning themselves into these type of companies. It's becoming a lot more viable for us to position ourselves as a data producer and then be selling to these companies, just because the market around that is much bigger and is also fastly growing and is also quickly growing.
Okay, I'd like to get Amaresh in here now.
Thank you, Tom, and thank you, Shoaib, for the presentation. I do have several questions. I used to work very, very closely in this sector, and so this is a wonderful, I think more companies should jump into this space. I think there's definitely promise in it. My question is actually similar, as an extension of what Dave just asked, with respect to the analyst companies that you're selling to. There are quite a few out there. A lot of them are organized by sector, as you know, because they have specialties in each individual sector. My question is, how much of the 78 million in commitments is from these companies, and how much is actually the end customer themselves? And then I'm sure you're familiar with Orbital Insight. Would they be a potential customer as well?
The entirety of the 78 million is from these analytics companies themselves. The entire majority is from the ones who are actually going to be analyzing that data and then reselling the intelligence to the final stakeholder, which is the farmer. And when it comes to Orbital Insights, definitely, as they are all marketing themselves as an analyst company who utilizes space data instead of having their own assets in space, they are also a potential customer for us. And you mentioned the 4.1 billion TAM and how that is actually much larger when you look at the actual end product, the analyzed intelligence, if you will, that goes to the end customer. So that 4.1 is based purely on imagery sales, just square kilometer of imagery sales. Okay. That's correct. And who is the dominant player right now in that space, just selling raw imagery? In terms of selling raw imagery, are you asking about our direct competitors or an analytics company? Your right. Direct competitors, yeah. Yep. So our niche, as our niche, we're specifically looking at hyperspectral imagery data. Some of the competitors that are being mentioned as Satellogic and Orbital Sidekick, Those are the two that we do know of, and the ones who are in orbit and are selling that imagery data. Of course, there are quite a few hyperspectral satellites that are operated by government-owned entities. We know that we know of Prisma. While most of it is only for non-civilian use, there are quite a few competitors within China as well. We know of Zhuhai Orbiter, who currently has a hyperspectral constellation or currently operating. They are some of the ones who are selling this imagery data right now. But if you're looking at this specific niche, if you're looking at someone who's selling, millions of dollars of imagery data annually, currently we do not have someone like that in this specific niche. Of course, we are competing with other data types depending on the application use case. Most of our customers currently use free data sets such as the ones from Sentinel, and some are depending on their applications, they're buying imagery data from Airbus and for their specific applications. But we are trying to market ourselves at this specific niche. So we are looking at some very specific problems to these customers. So while they might be somewhat competing with us, right now there is not a huge dominant player who currently has hyperspectral satellites out there.
Okay, we need to move on now, but Shoaib, thank you so much.
Thank you very much. Very interesting.
Thank you.
Yeah. Okay, thanks for that great kickoff to our program today. Next up, I'm not seeing him. I hope he's here. Johans from Celestial Space Technologies. There he is.
Yes, hello, I'm here. Can everybody hear me?
Oh yeah, you're fine.
Perfect.
So you can share your screen anytime, and when you start talking, I'll start timing.
Perfect. Can you see my screen?
Sure can.
Okay, great. Yeah, thank you, Thomas, for the introduction. Then I would like to start now. So, hello, everybody. My name is Johannes. I'm one of the founders of Celestial, and at Celestial, we want to redefine satellite communication. Because the problem we see in the space industry at the moment is that small satellites have limitations in available power, available volume, and also regarding the lifetime. And then we consider the high mission failure rates, up to 50% for the industry and 30% for academia, and also high deorbiting rates. There's a total of lost assets of 150 million euros from these failed and deorbited satellites. So we're looking to tackle these issues from the telecommunication side. We're looking to offer remotely reconfigurable communication systems and high performance and still low cost custom antennas, and also highly integrated multifunctional systems. What that actually means, we will get to in the following slides. But overall, the value we provide is customized systems, and we're optimizing both the power and the volume on satellites. And by that, effectively, we extend the satellite lifetime, also mission range, and eventually also performance capabilities. So in the two images below, you see two of our products. On the right side is an SDR-based communication system, and on the left side is a patch antenna, which is also on the market as we speak. So, and we also did a comparison with our competition, of course, which is summarized in this diagram. So the blue circle is our antenna. Gray circles are competing antennas. Size of the circle is the cost of the system, and vertical axis actually is performance. And when you can see is what you can see is our antenna is about 3 times as performant as the general baseline of the industry. And that's really the conclusion that we draw from this comparison. Our performance over size and over price ratio is very high, which is also our main competitive advantage. And the value chain in the satellite industry, we are fairly high upstream focused. We provide components and subsystems for satellites. And the way we deliver this is the circle in the center. So at first, we talk to our customers about the emission requirements, but then Celestial actually is a design and engineering company, which means we design antennas, we select material and components, and everything that follows after that, manufacturing, testing, post-processing, that is outsourced. Now, eventually, we also potentially talk to customers about integration and help them, but we focus on design and engineering, and that also helps us for scalability. Because when we consider that there's 10,000 satellites planned to be launched this decade, and 1/3 of them is operating also in S and X-band, which is what we have antennas for on the market. We can serve them because multiple antennas typically require multiple antennas for redundancy, and also when we look at upcoming mega constellations, they require similar antennas or the same antennas. So these antennas we have to design once, and we can manufacture multiple of them. So that helps us in scaling our business model because we focus on development, and we can scale anyway because despite being hardware heavy. Looking at our upcoming R&D, and this is now where we get to the interesting part of the multifunctional systems. We are looking to develop a solar panel integrated antenna, which is, as you can see in the images, it is an integrated solar panel and antenna, which means it acts as it generates electricity and makes power available, and still also operates as an antenna. That's both payloads are integrated into a single system. They're no longer separate, and this is something new on the market. We are not aware of anything similar. And in the next step, next year, we want to make this system also deployable, which is a very interesting system, especially when we consider this is relevant for the upcoming mega constellations because they rely heavily on inter-satellite communication links. And specifically for this use case, our antenna is very interesting because when we combine multiple payloads, which are usually separate, and we make one of them, we free up space, which means the individual satellites can take up multiple antennas, communicate in more directions, and that's exactly what they need when they want to communicate to satellites all around them and not only to the ground. So the main application is obviously in satellite communication, but this is also relevant for deep space and lunar missions, and even for drone applications. We talked to the industry about this idea and this concept, and they like this a lot. We also have 3 letters of intent from our user segment. And the overall benefit we provide with this system is really high volume availability and an improvement of the overall link and power budget on the satellite. Who are our customers and where are they? So in general, you can say that our customers are all organizations who develop, launch, and operate satellites. This can be startups, universities, agencies, bigger companies, and 3/4 of them actually are in US and Asia. But we want to be global. Our customers are also global, and we want to go to all of the big geographical markets. And we also have ideas and strategies prepared on how to enter those markets. But looking at the market overall, globally, when we look at the satellite antenna market for ground and space segment, that totals to a 30 billion euro market. And off of that, when we look at satellite antenna for space only in our frequency range that we have developed already, this is still 600 million euros market left. And off of that, we estimate that we can obtain 80 million euros. And the drone market is only on top of that. But these estimations of what we can obtain, our financial forecast, our sales forecast is in the diagram on the left side. We expect to be, after we develop actually multiple products, to be cash flow positive already next year in July. And then the year after that, we expect to have a break even. And at the end of the projection timeline, which is end of 2026, we expect to have a revenue of 12 million euros and 3 million euro in profits. And we expect to have sold over 600 units. So where's this revenue coming from? This is summarized on the right side, the stick graph. And you can see the base of our products. That's the blue, that's the patch antenna, which is on the market already. But the biggest revenue drivers will be next year, the solar panel antenna in orange, and the year after that, especially the deployable solar panel integrated antenna, those will be the main revenue drivers for our financial forecast. So who is Celestial and the team? Celestial was founded by my colleague Mayank. He's a space engineer. He's also in this call. And myself, an industrial engineer by background. We are actually around for a while, 3.5 years, and we've won a few awards and competitions, most notably 3rd place in the NewSpace Masters Challenge. We were part of the Lunar 2020 analog mission. We won the Space Award there. We completed ESA BIC, and also Celestial offered engineering workshop at ETH Zurich. And Celestial really is a company that's developing innovative ICT solutions for data-driven industries. And we, of course, focus on satellite communication and space applications in general. Our headquarters is in Germany, and we have a subsidiary also in Luxembourg. And most notably, we have an upcoming technology demonstration mission for end of this year. So on the right side, top right, you see our antenna being integrated into the satellites already now and waiting for launch at the end of this year. Right now, we are looking for actually distribution partners. As I mentioned, we have antenna products on the market that we can serve and deliver right now. So we're looking for companies who have small satellite subsystem catalogs and who would like to have also more antennas in their catalogs. We can provide a very high performance antenna right now for this catalog, and we would like to sign this partnership. And we're also looking for private funding, roughly €1 million in equity funding to develop products that are outlined and to aid our R&D. The exit prospects that we can offer to investors is most likely acquisition by a large space company who's also developing satellites. And this can happen as soon as our revenue is going up, so actually within 5 years. And of course, we're also looking for pilot projects, in-orbit demonstration missions for the solar panel integrated antennas and deployable versions and starting next year already. And the main use of our funds will be actually in delivering our serving customers. And a big part of that will go to salaries, which for us is also R&D, because we do development and engineering. So thank you for your attention up until this point, and I'm happy to answer questions. Thank you.
Johannes, that was great. You just hit just under the mark. It was absolutely perfect. I loved it.
Thank you.
Okay, yeah, that was great. Keep the slides up. Amaresh, I want to lead off with you this time.
Thank you, Tom, and thank you, Johannes. Great presentation. My first question is around competitors. Can you talk a bit more on who else currently does this and who your what the competitive landscape looks like?
Yeah, sure. I'm going back to the slides. Our comparison. So notable competitors are, for example, Anywaves. It's a French-based company. We have IQ Wireless. They're based in Germany. There's Endurosat. I'm not quite sure where they are based. I think it's somewhere in Europe. And there is ISI Space. So these are companies who are all developing patch antennas, satellite patch antennas. We looked at them. Actually, we got data sheets and the data specs of their antennas or of their patch antenna, which is similar to the S-band patch antenna that we have right now. And we did this benchmarking, comparing the performance, which, to explain this diagram, what performance is. It is antenna gain, which is the antenna capability to increase the signal strength over the antenna size, so volume, multiplied by weight. And the size of the bubble is the price. So then we factor all of this in, we get to this, this performance indicator, where we rank very high because we have a great ratio of gain over size. So our antenna is really, let's say, the antenna model that we have designed and tested, and which is on the satellite and being in space end of this year. This is for high gain. This is a high gain antenna. So that's for companies who want to have, for example, high data rates. But this is a very specific antenna. We are aware that most missions actually will need a customized solution. And this may be even low gain, and they require maybe higher bandwidth. So while we have this antenna design ready, what we actually also provide is our capabilities to design for any mission characteristic. And this would be a new antenna design, which will be different and will be tailored. And then you would have to have a different benchmarking. But this is now for this example case for the antenna that we have tested, and where we think we rank very high and very good.
And so I know that you're producing additional product lines as we go forward over the next few years, like solar arrays and the like. But let's focus on the antenna specifically. What type of satellite is the optimal satellite as a customer for you? Mass-wise, use case-wise, and maybe you could list some potential customers by name.
So right now, our antenna, our S-band antenna is 1U. It is just short of 10 by 10 centimeters. It's a flat patch. And we have an X-band antenna, which is 34 by 34 millimeters. So also fits to 1U satellites. That would be ideal, 1U or few U satellites, because then we don't have to customize this antenna or the size of this antenna by a lot. So these small satellite and small satellite missions, those are our ideal customers. But what we develop, as I said, customized antennas, and we can make this antenna bigger. It's not a problem. We have the capabilities to basically design antennas, and this can be almost any size. So it doesn't really matter how big the satellite is. What we would like to see is a customer who is launching a constellation of multiple satellites, of course, just for economics, because this will be a bigger order for us, and we will make more revenue, of course. It's better commercially speaking. Specific companies that we are looking to serve, Satellogic was mentioned before, which is a satellite developer. Planet would be a big one, for example. Then there's companies like OneWeb who are developing big constellations. But then there's also many companies who are small, or let's say small teams who are younger, who are launching individual satellites. This can even be satellite agencies, and those are most notably from countries which have which don't have decades of space experience. This could be an agency somewhere in South America, for example, or the Arabic countries, and also universities who are launching student projects. So it's very, very broad.
I'll save my last question if we have time, but over to Dave and Eva.
Eva, why don't you go? What do you got?
Thank you very much. So when at the beginning, you talked about the problems that the small satellite issues face. And I got to say, I am a little confused because I'm not sure how this actually solves any of those particular problems. I mean, it may solve problems in terms of the antenna market specifically, but I didn't see how it solved any of the other problems you had.
Yeah, I understand the confusion. There's simply not enough time to tell the entire story. So thanks for the question. I can get into that right now. When we talk about mission failures, there's a study, and there's up to 30% of mission failures is due to the communication system, including antennas. They're simply not reliable enough. We want to make them more reliable. And then when we talk about the lost assets, this is satellites who are being deorbited. And those are satellites who fulfilled their mission objectives. And after that happened, they will be deorbited. They will not be used for follow-up missions, typically. We want to offer reconfigurable communication systems. That's another project which we have in the pipeline. And also our antenna, which are basically capable to work across a bigger spectrum of bigger frequency spectrum, and actually on multiple central frequencies, so that when your satellite finished its objective of the primary mission, it can be recommissioned maybe to a different orbit under different communication characteristics, and in that sense reused. So you don't have to send another satellite for another mission. So we're looking to tackle this from this perspective, really extending the communication capabilities of these satellites and making it more reliable. So actually less satellites are required and they can be increasingly reused.
And how about vertical? And like a lot, it seems to me a lot of the constellations in particular have a high degree of vertical integration from the perspective that they're made inside. There's not a lot of outsourcing that goes on, some more than others. Any comment on that? Because that obviously, if they're going to build it themselves, you don't have a customer.
Sure. Yeah, that's correct. And the number for that is probably 88. So there was a study that says if you do a 3U CubeSat constellation and it's bigger than 88 satellites, then it makes economically sense for you to manufacture yourself. Absolutely. So this is also why we are targeting smaller missions, small constellations, because for them it makes economically sense to still outsource all of that. But these bigger missions are still a target for us because, as I mentioned, we develop, we do engineering, we don't do manufacturing. So even if the constellation is doing the manufacturing themselves, we can still provide antenna design, antenna engineering. This is basically our core competency. That we can still sell antenna designs to them, and still they do the manufacturing themselves, but that's okay because we don't do manufacturing anyway. But then also this gets back to our solar panel integrated antenna. So this is an antenna which is specifically interesting for large constellations. As I mentioned, integrating multiple payloads into one, so you can have additional antennas, you can communicate into multiple directions. I'm not aware of any other company who is working on that or who was even offering that. So that's really a product that right now I think we are the only one out there working on. And this is specifically of interest to bigger constellations. And this is also a system. And there's no set up production line for this because it's new, basically.
Okay, David,
Yeah.
get you in here real quick. We have time for maybe one or two really quick questions because we're on so sorry.
So given that this is a new type of antenna, to talk about the time frame and the engineering for the satellite companies to engineer that, and might that impact your ability to sell these antennas going forward?
So our development stage for this is we have the design ready. You see on the image, this is actually a screenshot of the designing software. Right now, we are mainly raising funds to prototype this, to manufacture this, to test this. And we want to get this done basically by the end of this year. So by the end of the year, we want to have all of this ready and tested, both from communication testing, but also solar panel testing. And then we're looking for in-orbit demonstration. So as soon as this is basically tested, it is also qualified for space. So starting next year, we want to have this on the market, maybe even before we do the IOD, but it's still nonetheless on the market, maybe without flight heritage, but it is still nonetheless qualified. The production line for all of that is actually already set up. We did the entire research, and we also identified R&D partners and suppliers for every subsystem. Basically, we're looking for that funding, and this will be then ready next year already. In terms of supplying any customers, as I mentioned, we do design and engineering, and we also notice that our antennas will not be supplied off the shelf. Instead, every antenna to a certain degree has to be tailored. So we expect that we have to find customers early in satellite development to really align their mission requirements with our design. So they have to provide that. And this can, I mean, maybe we have to be in contact with them as much as 1 year before they actually manufacture a satellite. That also depends on who we are talking to. But there is a long development, a long fulfillment cycle, I would say. So we have to contact them very early in their development stage, and this is currently actually our challenge to find them in an early stage.
All right, we have to cut it off there. I'm sorry, but you need to move on. Thank you, Johan. You can give back your screen.
Thank you.
Yep, absolutely. Okay, next up is Egbert Edelbroek from Spaceborne United. They're going to find this very interesting.
Yes, can you see my screen?
Sure can.
Thank you.
Be a little louder, otherwise you're fine.
Yeah, perfect. I'll just talk a little bit louder. We've had
there
this,
you go. That's good.
Issue. Perfect.
Yep.
Thank you for your introduction, Thomas. So I am Egbert, founder and CEO of Spaceborne United. And let me invite you on a brief journey through space and time. So imagine, for the first time in history, our babies can be conceived in space. Imagine a few years later when they can also be born in space. Imagine these next steps in our evolution becoming a reality. Is this science fiction? No, this is science fact, and we are making it possible. In doing so, we provide the missing link in becoming a multiplanetary species. NASA, ESA, SpaceX, and others are preparing for human settlements on Mars, and they want them to become independent. That means that also requires learning how to reproduce beyond Earth in different gravity environments. A challenge very difficult to address by large agencies and corporations. Fortunately, they explicitly encourage focused biotech companies to address this crucial challenge. So we are this focused biotech company addressing exactly this challenge. We research the conditions for human reproduction in space. We use research that was done by others and extend it. We translate the outcomes into missions and a missions program to enable the different stages of human reproduction. Our space life science work especially focuses on developing the biomedical equipment required for the missions we develop. This is a large part of our work. We start with the first stages of reproduction, conception, and early embryo development. Meanwhile, we are also working on longer-term missions that, for example, enable childbirth in space. We have world-class support from various research and industry partners. But who is paying for this, and why would they? We explored several business opportunities. We identified and validated a short list of possible profitable business cases, short-term, mid-term, and long-term. We also reached out to these customer segments and got really good responses. We still have some homework in fine-tuning the validation, but we get a lot of support with that from experts from the space industry. More about the business in a minute. Let me first introduce you to our team. So the core founding team consists of, well, myself, obviously, and then there is Dave Cullen. He has been supervising most of our research projects for the last 4 years, and he is a professor and space biotechnology expert at Cranfield University. And there is Dr. Nancy Berham, an obstetrician and gynecologist with over 20 years of experience. She knows all we need to know about reproductive challenges. She specializes in high-risk situations and also researches options for childbirth in microgravity. Then we have Brian, our main business expert, a very successful serial entrepreneur and space tech startup mentor. Dr. Westphal is a very experienced embryologist and former IVF clinic manager, providing all we need to know about IVF technology and embryo development. And finally, Professor Svenne, our IP expert and experienced top lawyer. On the background, On the background, by the way, you see the UFO-shaped building in the Netherlands where we rent office space for our headquarters. We are very happy to work with our other team members and our growing group of international experts and advisors, addressing the various matters from biomedical, space technological, ethical, legal, and business development angles. For this slide, I selected the most important people, but there are many others as well with valuable contributions. The same gratitude we have for the research and industry support on several essential areas regarding mission architecture and payload development. And it's not just technology, it also includes business case validation. Time to move on to the how question. So let me explain how our technology works and how it enables and supports our missions. So we are extending existing assisted reproductive technology like IVF, and we make that work in space as well. So for our first mission, we enable conception and early embryo development in low Earth orbit. We are developing these biocassettes that you see that function as a life support system during 5-day missions. We combine the key technologies that are mentioned to develop and align the different layers and functionalities in these biocassettes. We also provide artificial gravity to ensure healthy embryo development. So we combine multiple of these discs, biocassettes, together in a pressurized casing, which goes on board the recoverable biosatellite and into the rocket. One of the best options for our launch provider is Virgin Orbit's Launcher One system. We aligned our requirements with them, and the Launcher One is flexible in terms of launch locations. It has proven technology, and it allows for very late access to our payload, which we need. So we use a dedicated flight and no ride sharing. We do not depend on this launch system, and we also have other options. So we have developed a mission profile and payload protocol that addresses all the biological steps and is aligned with the payload requirements and the participants throughout all the mission stages. I'm not going to explain all these details now, but this shows the general mission architecture. Of course, there's a whole process behind the scenes prior to preparing missions like these. When we started some 5 years ago, we had to work on several milestones first. Our concept needed to add serious value for both science and business, and also needed to succeed in feasibility studies. So we redesigned the concept several times to achieve this. And it also enabled us to find execution partners and align with internationally supported research roadmaps. So from around 2019, we could focus on our biomedical device, our embryo incubator with the biocassettes I just showed, and continue to raise the technical readiness level. On the side, we also continue to prepare other missions, enabling, for example, childbirth in space in the long run. But it's time for the business perspective. From the different business cases we explored, the most profitable and feasible turns out to be the participating very wealthy people. They are willing to pay a large amount of money to be able to let their children become part of history. More specifically, we mean the ultra high net worth individuals. Worldwide, a group of almost 300,000 people. With the mission costs of around $10 to $12 million, we expect to make a $30 to $40 million profit per mission. On the longer term, our missions program provides additional revenue streams. We have the upcoming space nations, like the United Arab Emirates, that show serious interest in our projects. We are actually invited to present our projects in front of the royal family. They want to be able to claim unique achievements in the new space race. And there's other customer segments. Our science output and technological innovations appear to have significant value as well for space research centers and for the IVF sector, As we figure out the way to safely reproduce in space, we end up with a crucial and valuable proposition for agencies and companies that aim for human settlements. And our last slide, for finalizing the preparation of our first missions, we aim to raise $3 million, which will be allocated to these budgets. Thank you for your time. We'll be happy to answer your questions.
Okay, thank you. Great presentation, as everybody. Dave, I cut you short this last time. I'd like to lead off with you.
Yes, have you experienced working with the ultra rich in the past?
Yeah, we have people in the team that have worked for shipyards and were responsible for organizing extremely expensive presents that cost over 100K per piece. So we have a few other people that have worked with them, indeed.
So is there any kind of competition set up to be conceived or to be born in space? Is that a thing? If you follow what I'm saying?
Well, for humanity in general, it's a must. It's inevitable. We have to do this. It's a long roadmap. We have to start as soon as possible. But for customer segments, it is there is competition. Of course, I'm sure you have witnessed Blue Origin and Virgin Galactic sending space tourists into space. That's also a life-changing event for the high net worth individuals or the ultra high net worth. But yes, it is a thing. It's inevitable. We have to do this. There is upcoming space nations that want to support and fund our projects, that seem to be willing to. And there is, well, I'm sure you also remember the Mars One project some 6 years ago. Hundreds of thousands of people were willing to go on a crazy mission like this, which was, well, we only need a few people who want to do this, and we expect from those 300,000 people that at least 300 will be showing very serious interest, and we only need 10 or 30.
Okay, Amaresh, how about you?
Sure. Egbert, thank you for the presentation. To say that you have a unique company is selling it short. This is quite a novel concept. So a couple of questions. What is an IVF chip?
An IVF chip, in vitro fertilization, like IVF clinics use.
Well, yes.
And they're making these processes smaller and more effective. With making it so as small as possible to even make it fit on a chip, and to automate processes that are at this moment mainly been done by expensive analysts with manual labor. They're trying to automate it and make it smaller and more effective and efficient.
Sure, but you're not talking about a silicon chip, not a computer chip.
No.
Got it. Okay, I didn't quite grasp that, but what are the primary issues that are foreseen right now for conceiving in space? Like what problem are you addressing with this new approach or technology?
Yeah, the scientific added value is filling the many data gaps in the partial gravity area. So we know practically everything about normal Earth gravity. We know quite a bit about microgravity, but we know hardly anything about everything in between, the partial gravity area. So with our research platform, we can learn if, for example, the Mars gravity environment will provide sufficient gravity for healthy embryo development, for humans, for mammalians, for terraforming in the long term, and selecting the right mammals that can thrive in a Mars environment.
Sure. So the main variables obviously would be gravity variation, partial gravity, like you mentioned, or changes in gravity over time.
Yes.
And possibly radiation. as well,
Yes.
and pressure variances. Can any of that be simulated here on Earth?
Yes, they can. We work with the Belgium Nuclear Research Center. They're also working on pharmaceuticals that enhance radiation resistance. But we don't have to apply that yet because we stay well under the norms for radiation for embryo development, because it's only a 5 to 6 day mission in a certain chosen altitude and inclination.
Okay. And last question quickly, how is Paragon involved?
They're, of course, world leaders in life support systems, both human size, but also on the small size. And they're helping with the thermal controls. That's another of their expertise. So they will be involved they are involved in the stage where we go to prototype.
Oh, and by the way, who are you flying at the end of the year on Virgin Orbit? So which IVS samples are you flying?
We will, of course, start with animal cell samples, with validation missions to comply with all the ethical committees. And we are not worried that we will find participants that will provide the cell samples. So we don't have those customers yet, but we are 1000% confident that we will find 1,000-fold more than we can work with.
Okay.
Similar to the Mars One.
Similar to Mars One. Yeah.
Yeah, there will be a lot of people that want to be in the history books or supporting space life science research, etc.
Right. But for this upcoming mission, it's animal cells.
Yes.
Okay.
Yes.
Wonderful. Eva, over to you.
Thanks. It's definitely unique. I agree. It still strikes me as less of a business and more of a experiment that government funding might be more appropriate for. That's my initial reaction, but it's fascinating. And obviously long term, it's an issue, but I've got to say, one of my observations is if I were to have a child who was conceived in space, I'd want to do it the old-fashioned way. You know?
I appreciate that.
So sending up, and unless I couldn't get pregnant anyhow, sending up an IVF sample to and then having it implanted just doesn't seem to have the cachet of, you know, the old-fashioned way.
It requires a very innovative mindset, but fortunately, there seem to be a lot of those people as well. But I understand most people will think this is a little bit, special.
Yeah, I mean, there's going to be lots of problems, and obviously before anybody can be born in space, or there's lots of things that can go wrong. So it's a great experiment to be doing. Is there any terrestrial applications from this? Like, is there anything that you can use your technology that you're developing on Earth to make early sales until the longer term kicks in?
Yeah, I can imagine that's I saw that question coming, obviously. We haven't pinpointed those spin-offs yet, but all of our experts, they're pretty much convinced that there will be spin-off for the IVF sector as we are automating the steps in that process that will be beneficial for the IVF sector, but we haven't pinpointed it specifically yet. And the same goes for the long-term missions as well. And also, so that's really a terrestrial application.
And are you thinking?
Yeah.
So here's an idea. Are you thinking, first of all, what might be an idea is to have a pet IV, you know, instead of having a mouse as your first sample, you know, a cat or a dog who is conceived in space, to me is more of something that somebody may, you know, considering how much people pay for pets these days, and COVID has made the prices even more higher, a pet conceived in space could be really an attractive idea.
You are actually not even the first with this idea. And we are open for those ideas. We think that could be a feasible business case, but we haven't explored it in much detail because we also wanted to keep our scientific focus as pure as possible. But that shouldn't have to conflict. And it's certainly, I think it will be feasible. We believe it is, and it's worthwhile exploring further. And one last thing about government funding, it's practically impossible for large agencies because they are working with taxpayer money, and they see it as a potential PR disaster to spend taxpayer money on delicate matters like space life science, especially reproduction in space. So they are explicitly encouraging companies to do it.
Okay, interesting. Thanks. Very interesting.
Okay, I guess we're going to be moving on then. Egbert, thank you so much. Great presentation. All right, and finally, let me reset my trusty timer. We have Melissa Roth from Off Planet Research. Good morning. You need to unmute yourself.
Okay. It wasn't giving me that as an option a minute ago. Perfect. One moment while we get the slides pulled up. Let me know when you see it in presentation mode and we'll get going.
All right, whenever you're ready, I'll push the button.
Perfect. So hello, we are Melissa Roth and Vince Rue, the co-founders and lead researchers at Off Planet Research based in Washington State. Off Planet Research is developing a self-cleaning, dust and regolith tolerant connector that can be used for either gas or fluid transfer on the surface of the Moon, Mars, or other worlds. The connector does not rely on soft seals that will quickly become brittle due to intense temperatures or volatile depletion in the vacuum of space. It will be well suited for use in the ultra-cold, permanently shadowed regions of the Moon and is adaptable for quick operation by a robot or suited astronaut.
The return to the Moon and the Moon to Mars strategy requires the ability for missions to support themselves with in situ resources and support each other through forward and lateral compatibility. One critical part is the capacity to repeatedly connect various vital systems and transfer gases and fluids with a high degree of reliability. This will require connectors and other hardware that are able to function in the dusty and extreme environments of other worlds. More rugged connectors are needed for construction, volatile transfer and processing, and life support systems, including the transfer of air, water, carbon dioxide, and waste.
In order to achieve that vision of long-term robotic and human presence in space, there are several issues that need to be overcome. These include commodity loss due to seal failures, limited EVAs from these leakage rates and the risk to human life, the slow process of designing and qualifying one-off connectors for every mission, and the long lead time and limited supply of qualified connectors.
The prolonged lifespan of our connectors will increase payload and production efficiency, as well as the mission return from those valuable EVAs. We are focusing on their interoperability with a standardized design to help meet the expanded cadence of missions. By establishing a consistent manufacturing process, we will be able to be a reliable supplier for the space industry.
Apollo surface operations showed the aggressiveness of the regolith and how it affects technology. Our connector employs several layers of innovation to achieve the goal of reliable, long-term, and repeated use while transferring gases and fluids in the dusty environments off Earth. The connectors are self-cleaning with no soft materials to degrade in the vacuum and temperature extremes of space. This may enable their use for cryogenic fluid transfer and within the PSRs at lunar poles. The special geometry of the sealing surfaces makes the connectors more robust against regolith particles and thermal expansion or contraction. The connectors can be scaled to a range of sizes, and the metal can be used that is used can vary according to the application needs.
The space market for these connectors includes commercial and government operators on the surface of the Moon and other worlds who will need to transfer fluids or gases between systems, landers, or rovers. The terrestrial markets are mining, aerospace, industrial, agriculture, and medical operations where contamination in transferred fluids or gases is a concern. Off-Planet Research participated in a market research program in the fall of 2020, utilizing a broad scan approach to identify the customer segments, their overlapping needs, and projected timelines. The interviews provided valuable information on some of the minimum viable products our potential customers are looking for, as well as a range of practical metrics. We believe that ISRU demonstrators who are proving their high TRL processes work in relevant environments will be our innovators, and spacesuit and life support system developers will be our early adopters. These are segments which are being forced to the front by the requirements of the current space program, and they are receiving grant funding or supply awards.
The development timeline for bringing these prototype connectors to the space market is about 2 to 3 years based on the progress made during our NASA SBIR. Engineering articles are expected to be available in Q3 to Q4 of 2023. We anticipate production of flight-ready connectors by Q3 to Q4 of 2024 to help support upcoming HLS and ISRU missions. Our flight-ready connectors can be produced by existing aerospace machine shops and finishing companies. We are developing relationships with several machine shops to ensure that we have redundancies in place in case of production issues, to maintain quality control, and to sustain competitive pricing. We plan to produce connectors based on orders to limit production overhead, and Off-Planet Research will focus on the design and integration into the client system.
The most likely competitors during this time include Apollo-era connectors which are still in use, the dust-tolerant automated umbilical from NASA, and IBOS from the German Aerospace Center. Electrical or orbital connectors are peripheral competitors and include connectors from Honeybee Robotics, TE Connectivity, Space Industries, and Amtech.
Breaking into terrestrial markets will be more difficult due to the number of established companies. However, this presents the opportunity to license our IP to larger terrestrial connector manufacturers rather than compete with them. This will allow us to maintain our focus on space while benefiting from the great potential for terrestrial sales by leveraging the larger market share of more established companies. As more dangerous industries like mining transition away from human workers and towards robotics and automation, long-lasting connectors will become even more valuable here on Earth.
With 6 years as a company and almost $600,000 in revenue, we have gone through the R&D process many times to create new simulants. Having been awarded 2 Phase 1 SBIRs, we are familiar with the process of moving from concept to design to testing and reviewing prototypes.
Our team of researchers and engineers has a broad base of knowledge and experience working with lunar regolith simulants and understanding their qualities as well as component testing in an active regolith environment. We have 2 knowledgeable and actively involved industry mentors, which include a retired commercial space executive, an experienced DoD contractor, and business owner.
The total addressable market in the near term is composed mostly of space applications where the connector performance is critical. Given the largely unsatisfied need for these connectors, it's reasonable that our share of the TAM for the space market would be about 50%. Within a 2 to 3 year sales window, it is likely that the market size for these space-rated connectors is at least 100 units. This market includes actual launched missions, prototype system development, testing, and sales for future use. We use the cost of production of the latest connector design to estimate the ROM production cost of the final connector. For a connector set, which includes additional features of a clamshell dust cover and a dust removal cup, we anticipate a total sale price of $24,000 with a 25% profit margin. Based on estimated 2 to 3 year sales of 50 connectors, we expect total sales of $1.2 million within that initial window. With the increased frequency and longer duration of missions, as well as developing lunar infrastructure, we expect future sales to greatly increase and the profit margin to go up. The terrestrial market is much higher volume, even for specialty connectors. One of the biggest players, Parker Hannifin, is a $14 billion business. We believe the connector portion of the global companies like Parker is approximately $60 billion. From licensing, our goal is $6 million in this window.
Under a Phase 1 SBIR, our previous connector efforts have focused on developing the geometry and features of the threads, mating structures, and gas purging system, as well as verifying the general design will clear dust. We have also designed and tested a developmental prototype clamshell dust cover and dust removal cup as additional layers of dust protection. We are looking for additional funding to develop fully functioning engineering articles to undergo flight qualification and certification. These technologies include our self-cleaning, dust-tolerant connector with valves and filters for transferring fluids and gases, the clamshell dust cover, and the dust removal cup. The budget for moving from developmental prototypes to engineering articles that have undergone flight qualification and certification is approximately $800,000. We anticipate the first exit opportunity for investors in year 3. Thank you for your time, and we welcome any questions.
Okay, great. You came in under time. Good for you. Great job. Eva Jane, let's start with you.
So hang on a second. Oh, whatever. Sorry, I was having a little technical problem there, unmuting. So was it Parker Hannafin is that you referred to?
That is one of the large terrestrial manufacturers of connectors, yes.
So first of all, very interesting, and for sure, you know, especially the moon is not going to be anything like on Earth, and dust is a real issue. So definitely it needs solutions. But what would prevent somebody, and this isn't so much about you as it is with so many new space companies, I find, is that a lot of new space companies, you know, they're targeting the space market, but then there's these huge terrestrial competitors who do primarily the same thing, but haven't looked at space at all. And at some point in time, they might come in and say, I can do that. I got these guys, put my little team on it and done in a, you know, space of, you know, a day or something ridiculous like that. But they just have never thought that there was a market worth addressing, so they never got to that standpoint. So what if they did, is I guess my biggest concern for a company like yours is that you may have this huge competitor that comes in that you're not thinking of as a competitor, except for terrestrial, because they have shown no interest in the area yet.
Yeah, and I think what that is going to boil down to essentially is experience and timeline. So, you know, they may have the resources, whether they decide to look into it now, a year from now, 5 years from now, when they see the market potential, they will have some catch up to play to get from terrestrial or even aerospace qualification to space qualification, specifically related to the dusty environment. And so that is what we're trying to focus on with this connector, is operating in extremely harsh environments geared towards the moon, but also here on Earth, where traditional connectors just don't stand up. And we have tested some traditional terrestrial and aerospace connectors this regolith is so angular and so abrasive, it just demolishes them, and they can't hold a seal. And so that is what we're trying to address with our connector, and ideally beat the curve. We hope we have an aggressive enough timeline that we're going to be ahead of companies that are going to need to gain experience and knowledge in the lunar and space environments prior to being able to adapt and design their current product line.
This also plays into our strategy of involving some of the primary players rather than trying to exclude them.
So setting up the relationships for later, because if you were going to be acquired, they would be the likely acquirer.
Exactly. So establishing those partnerships and establishing, turning a potential competition into a alliance.
Which raises the idea of a lot of the time one type of investor that a lot of startups ignore or don't realize as a potential is a strategic corporate investor who may want to have the technology or buy you later, and they may want to make an investment in you now so that you can do this effectively for them.
Perfectly sound business plan.
Okay, Dave, you're up. What do you have?
Yes, it appears I met you at the NewSpace conference, I believe, in 2018 in Kent, Washington. So, and
Lovely to see you again.
yeah,
It's been a little while.
yes. It appears as though you've pivoted from your simulated moon soil and things like that, or can you tell us a little bit about your pivot?
Yeah, so what we look at it is expanding our product line and services. So we still have been producing lunar regolith simulants for going on 6 years now. And we have a range of different materials and can customize those simulants as well. How that comes into play with this is that we've been handling simulants for quite a while now and have really learned a lot of the nuances and bad behavior of them when it comes to interacting with mechanical systems and components. We've had our own equipment seize up where we can't open, glass jars anymore because those regolith particles have gotten into the lid. And so trying to incorporate that knowledge that we have gained into the design of our connectors was really important to us, and we believe gives us a leg up on the competition. Now, our background is engineering, so we look at this as also expanding back into what we originally wanted to do, which was designing hardware and technology for space. It's just we also have the testing pedigree and experience in-house as well.
Great, thank you.
Yeah, you should put that in your presentation, by the way, because that experience with regolith is something that makes you much more unique. And it's definitely something that I think other companies would have to hire out effectively. So I think that's, I didn't hear you mention it. I knew your name from somewhere, but I couldn't place it. And that, Dave, bringing that up, it really is something about you that's a real strength that other people don't have.
Yeah, that's been our objective since day one, is to have a complete and deep knowledge of the issues and environments to produce better solutions for the needs of the market. That's our goal.
Okay, I'd like Amarish to come in and finish off this session.
Sure. Thank you very much, Melissa and Vince. Great presentation. So the slide that you put up that showed your 6-year history. So you've, and as Eva and Dave were asking as well around your prior areas. I would imagine then, starting in year 4 and 5, it looks like you then started your connector research and started looking into connectors and won the SBIR for phase 1. We didn't see any pictures of your connector in this presentation. That's the bulk of your pitch. And so I'm wondering, is there anything you can show us? I'm a little confused on why we didn't see anything on what your core product is.
Yeah, and that's due to IP concerns. We actually did have some photos in here of the exterior geometries that didn't show the good stuff. But unfortunately, then it's just a lot of shiny metal. So that is something, though, that if someone would like to continue a conversation offline, we can see what we can do without affecting our IP.
Got it. Okay. But you do have designs and have mock-ups and have prototypes already built that you're testing now. Okay.
Yeah, that was part of the SBIR. You have to commit to providing NASA with certain physical proof of what you've developed. So we do have our prototypes, and we can't show them, but we would need to have an NDA in place in order to go into that kind of detail, as Melissa said.
Got it. Okay. No, that's definitely very critical. Would definitely like to learn more. We can chat about that.
Yeah.
How big is the market? And so how many missions do you envision that would be going to the lunar surface, like over the next 10 years or whatever your time horizon is? And of those lunar missions, how many connectors can you possibly sell?
Yeah, so for the purposes of this pitch, we estimated based off kind of what's currently announced and currently planned in terms of missions, that as anyone in the space industry knows, it's a very volatile number and can change, push forward, push back, have new missions added, have missions deleted. And so what we're really looking at is long-term, the longevity of those missions, specifically geared around ISRU developers, since there's a large focus on them right now. And where the money is often where the missions go. And so focusing on them, focusing on life support systems. When you have humans, you're going to need to have redundancies just to reduce the risks to human life. It is so important. And if you're looking especially at long-term missions, you're going to have to essentially refuel or defuel those EMU suits in order to keep going with the EVAs. And so that's really kind of what we're looking at, is who's currently planning to launch, who may be planning to launch, and kind of where can we insert ourselves into that picture. So right now, it's a little limited in terms of the numbers available, but we expect that once that first mission launches, there'll be a lot more defined data and groups committing to going as well.
A lot of our numbers for these estimates came from our I-Core interviews that we did. So we conducted a fairly extensive set of I-Core interviews, talking to end users, people that are actually making the decisions about what connectors they're going to need and how many. So when we come up with numbers, we try to be conservative. We don't like to promise too much.
Got it. So then do you view yourself then as a component supplier to some of these contractors for NASA and for large agencies and for the private operators of missions like Blue Origin? So it'd be folks like Paragon or others of that level, exactly, if you will. Okay. Mm-hmm. So who could you name a couple of customers that you envisioned?
Yeah, so specifically if we're going for space, government agencies like NASA and ESA, particularly those that are looking into an ISRU or human life support systems. We also have private industry ISRU developers like Lunar Resources. You have mining and robotics industry organizations like Off-World. Folks that are going to essentially be getting down and dirty or looking for long-term solutions in space.
Another possibility, NASA just announced an award competition for universities to demonstrate end-to-end ISRU, and they will need connectors of this type for that. So,
okay, very good. Thank you. That's all I had as far as questions. Thanks for the presentation.
Thank you.
Thank you.
Okay, everyone. I want to say thank you once again to all our great presenters today at ESPR, Celestial, Spaceborne, and Off-Planet Research for some really, really great presentations. And again, thank our judges, Eva, Amaresh, and Dave, for being a part of this. Now, any second now, I expect and here we go. I guess we're getting from Lee's giving us a Google invite where the judges and I have a special kind of digital breakout room that we're going to go to caucus, and the judges will decide who wins the grand prize of $5,000, so generously sponsored by Foundation for the Future. So judges, we'll see you there. I will be back here at 3:30 to announce the winners and make a couple other announcements for future sessions as well. Thank you, everyone.
Thank you so much, Tom. That was great. Really enjoyed seeing that. And yeah, I had seen Melissa Roth's other company in a presentation at ISU. And so it was neat to see her back as well. All right. Well, thank you very much to Tom Olson and our distinguished judges and the formidable competitors in the NewSpace Business Plan Competition. I can't wait to hear who the winner is this afternoon. Next, we're going to hear a bit more from Tim Chrisman for about 15-20 minutes. And Tim, that interview with John Weathersby this morning was really good. I really like that format.
Yeah, agreed. And he's just delightful to talk to. So that made it easy.
Yeah, well, when you do a good job at something, you know what that does, right?
That's what I'm told. That's what I'm told. That one day I aspire to be like John.
No, it means that you earn yourself more work.
Oh yeah, there's that.
So I will be giving you more assignments to do interviews like that in the future.
Sounds good.
All right, so I will be back at about 12:29 to announce our sponsor and get started with Saturday Space.
Cool. Thanks, Lee.
Yep.
Yes, I wanted to take a few minutes here and chat about the Foundation's Workforce for the Future pipeline that we're developing. So this is one of the initiatives that we have running. We often talk about our efforts on Capitol Hill around space finance and new financial tools for space. And the workforce component is just as active alongside that, and is every bit as critical, because as we've talked about on the last couple of days, the challenge of developing the next generation of workers often starts very early and has a very long lead time. And so just unlocking money to pour into new space companies, new capabilities is not enough. We also need the workforce to actually handle all of those new jobs. And so that's where this program comes in, and yeah, excited to give you guys an overview and an update of where we are with it. So I often talk about where we're at, the sort of you are here. I'm former Army, and so I'm always told to orient people to where we are on the map. And so depending on which marketing philosophy you buy into most, the important part that I'm trying to convey here is space is cool again. Space is being hyped up. There's a lot of awesomeness being talked about around space. And so I don't think we're at the peak of these expectations, nor do I think we are actually at the point where we've exhausted all the early adopter enthusiasm and have truly reached that chasm that G.A. Moore talks about. But we're close. And that in and of itself gives us here at the Foundation motivation to push forward and push faster, because we've seen, especially those of you who've been in the community a long time, seen this ebb and flow where after Apollo, after the space shuttle, there has been tons of excitement, a lot of hype and expectation around what's next. And that often comes crashing down when everything meets the reality buzzsaw that is government contracting and government appropriations. And so on the workforce side, we've seen over the past few decades that the space workforce development system is really geared towards creating the people NASA needs. Not necessarily a problem. NASA has been the space organization in the minds of the public and in actual fact for quite a while now. And so it does tend to look like a one-size-fits-all pipeline. NASA has its Space Grant Consortium, which administers about $100 million of grants every year for STEM education. This is a fantastic model. If you don't know much about it or don't know what your state school is doing with that money, I encourage you to just do a quick search of NASA Space Grant Consortium in your state, because every state has a lead school. Every state is getting money through this, and it's doing great work. The issue is that it lacks the breadth of what is needed. This program doesn't train national security professionals because it shouldn't. And so as Space Force has been standing up, a lot of work has gone into creating pipelines for service members who are going to populate the Space Force and those organizations supplying critical pieces of equipment. And so whether it's the Air Force Academy or ROTC programs, there is a emerging workforce pipeline for them. But for the rest of the economy, there is nothing that can produce at scale the career and technical education workers that are needed to actually make the satellites and rockets. And I like to say it's for the rest of us. I'm not good at math. I'm a policy guy who has spent 15 years stealing secrets from people who don't like America. And so I should not be designing a rocket or handling life support or dealing with the connectors that we just heard about. But there are millions of workers across the country who are doing the work of creating almost identical pieces of hardware for cars, for airplanes, for trains, and for most of them, they have no idea that the space community needs them. And so that is a huge problem for us, because what they don't know, they won't do. And so what we're trying to create is a kindergarten to space workforce development pathway for the rest of us. And we say kindergarten to space, not as in we're going to groom someone from kindergarten until we can throw them into space on a giant slingshot, but rather that we are trying to create a pathway that has opportunities starting at the kindergarten level and progressing all the way through employment, of employment opportunities, educational certification, and more. Ultimately, though, we at the foundation don't need to be creating any of this content or certifications. They exist. There's 41 schools across the country that have some variation on space policy or space law or other space sort of white collar workforce certification programs, and another 21 community colleges that already have aerospace and specifically space focused technician programs that look to educate and train the pipe fitters, welders, and electricians that are creating SLS, New Glenn, and Starship. And what we're looking to do is build a platform where the friction between finding those opportunities and executing on them is gone. And so a one-stop shop where if there is space-related content and curriculum, we point people to it. And so that way there's no hunting for what opportunities are and where. Instead, it's a single portal where all of that lives. Ultimately, we want to build that out to include, as I mentioned, opportunities from space camps all the way through advanced degree opportunities. And how this would work is essentially building off of the work of other trade associations and nonprofits who have done this in similar sectors. So the advanced robotics industry has the Advanced Robotics for Manufacturing Institute, and they have their robotics career program that has created a nationwide network where they highlight what opportunities are available and then have a system to go into the schools and evaluate their programs. Those that meet the criteria that have been created by industry, government, and academia as in terms of what is needed for going forward, get essentially a good housekeeping seal of approval and badge on this portal. We see that as a natural thing to adopt for the space community, to go out and show what schools are space ready and then take that to communities that are on the edge of the space economy and are looking to build themselves in. And now we have an established network of trainers that know how to do this. And we can then leverage state and federal grants to bring those trainers to these new communities and help the community colleges and technical schools create the programs through a peer-to-peer mentoring equivalent. So normally this is a little bit longer of a presentation, so I'm just going to kind of blow through this pretty fast. The important thing to take away from this is over the next 5 years, there's quite a few different developmental gates for this program that essentially starts at the community and technical college level and builds down. And when I say builds down, I mean we start there and then we start building into high schools and expanding the network and linking up what programs exist down to middle and on to elementary school. Alongside that is partnering with Space Force Association and National Security Space Association to ensure that what is being developed at the career and technical education level is useful and beneficial to the national security space. To that end, we had language inserted in this year's Defense Appropriations Bill to create a task force that will assess, evaluate, and then plan for a dedicated Defense Department pathway and mechanisms for funding said pathway for this blue-collar workforce. We're really excited about this. This is the first time the Defense Department has ever done anything or been mandated to do anything related to blue-collar and skilled labor. And so a pretty exciting start to this program. But yeah, so essentially starting at the career technical education level, building down and leveraging the work we've done with this first Defense Appropriations Bill to lay the foundation to build a nationwide system with a dedicated source of federal grant money so that we can replicate the space consortium model of issuing out grants to state or on a state-by-state basis and strengthening the existing programs and allowing emerging states to build up their program with the help of federal grant money. So here's some financial tools or projections rather. The important thing to note here is that for the most part, this is a fairly low cost system. As I mentioned, the NASA consortium is utilized about 100 million in grant money, not to mention easily equaling that in state grants. And based on some fairly conservative estimates, we see that this roughly 1/3 to 1/4 of that amount can reach the same or more students than the Space Grant Consortium, just because of the efficiencies you get from essentially commoditizing a lot of this training. Why do we need that? Part of it is right now, there is not enough workers for the space economy. We continually hear from companies that they cannot find the workers they need where they're at. And they can't even find places to relocate to that will have the workers. And so as we're going about advocating for the Space Corporation's creation, we've recognized that the need for this workforce development starts now and ramps up significantly when we have success with the Space Corporation. If you're not familiar with the Space Corporation and what we're doing with that, essentially this is an infrastructure development corporation dedicated to space. So it would be a public-private partnership created by Congress, but requiring no new federal money. Instead, it would be authorized to issue bonds and give loan guarantees, very similar to how Fannie Mae or Freddie Mac do for the housing market, but this would be on the more commercial lending side. And so its mandate would be as a public benefit corporation to create those long-term basic building blocks of infrastructure that are needed to support a vibrant space economy. And now when I say its mandate is to create, that's a little bit of a misnomer. It's mainly to fund the creation. Space Corporation itself, it would look more like an investment fund than it would a Lockheed or Boeing. And that's on purpose. By keeping the overhead low and making it a essentially financial engine of growth, it's able to do more with far less money and also partner with the private sector in order to ensure that the money is going where it would be most profitable instead of relying on historical appropriations and contracting processes. Just to give you a scale of what this corporation could do with its relatively small amount of money that it could raise. We recently had an economic analysis done and a portfolio analysis done. We kept this as conservative as possible to avoid the sort of inside the DC Beltway hype machine. But still, you can see that whether it's by bonds or sale of shares, a fair bit of money can be expected in terms of its capitalization. And the actual portfolio that it can deploy, if it's done using the loan guarantee model, it can dramatically scale up the amount of loans and investments that can be made by assuming the first loss position and partnering with large institutional investors to supply the rest of the capital. Based on that analysis of the portfolio, we could expect to see about $150 billion in new economic activity by the end of the first decade of the Space Corporation. To put this in a sense of scale, based on what we have now, the current space economy is estimated by the Department of Commerce is just south of 300 billion and expected to grow anywhere from 50 to 100 billion over the next 10 years. So this would essentially double, if not more, the existing estimates for growth of the space economy and adding millions of new jobs across the country to the existing space workforce. The majority of these jobs being high-paying, skilled tradespeople jobs, as opposed to the current makeup of the space economy being largely engineer and scientist heavy. I'll wrap it up here. We get asked a lot, how can people get involved? How can they help? The first is we are a member-supported nonprofit, and we need more companies who share our vision and who are looking to make a difference in the space economy to join us as formal members. We need people like you, viewers like you, to put it in the PBS parlance, to help us as constituent pathfinders in your districts. You may be jaded on the state of Congress, but I can tell you, and Lee will attest to this, they pay attention when their constituents reach out to them. We have had great success using constituent pathfinders from you all and getting the attention of Congress people to take action. And then finally, as Lee mentioned, we're always looking for referrals, whether it's for sponsorships of conversations for the future of the foundation itself, or just helping us create more programs like this NewSpace Business Competition. All right, I think I have used all of my time, and so that probably forecloses the ability to do questions. My apologies, Lee.
Thank you so much, Tim. That was great. I always enjoy hearing you talk about that sort of thing. Welcome to Saturday Space, the feature where we talk about things we might enjoy on Saturday in space: arts, sport, recreation, and entertainment. Today's Saturday Space is sponsored by the Thunderbird School of Management's Executive Master of Global Management in Space Leadership, Business, and Policy. Thank you for your generous sponsorship. Our special guest today is Damian Kulash Jr. He's an artist, musician, filmmaker, and the frontman for the polymath rock group OK Go. He's directed the band's long string of boundary-pushing music videos, racking up more than 300 million views online. They've danced in zero gravity and on treadmills. They've built a warehouse-sized Rube Goldberg machine to run in sync with a song. And they've choreographed hundreds of explosions filmed in just a few seconds. And don't forget the umbrella scooters. Damian has received the Smithsonian American Ingenuity Award for Visual Art, a Grammy, 3 MTV VMAs, 21 Cannes Lions, 3 Webby Awards, and has had his work presented at the Guggenheim, MoCA, LACMA, the Hirshhorn, the Hammer Museum, and Seattle's Museum of Pop Culture. He graduated magna cum laude from Brown University in 1998, and he's written for the New York Times, the Wall Street Journal, the Washington Post, and Rolling Stone. He's also testified before U.S. Congress in support of net neutrality. He serenaded Barack Obama at his 50th birthday party, appeared on The Simpsons, and Animal from the Muppets, whom we all know and love, once played the drums in his garage. Damian lives and works in Los Angeles, and thank you so much, Damian, for taking the time out of your very busy schedule to talk with us today.
Thanks for having me. It's nice to be here.
All right, well, we invited you here because you made a spectacular music video in simulated microgravity on a parabolic plane. We've put a link in the chat for our audience a few comments ago, and this venue has had an ongoing conversation about art, sport, recreation, and entertainment in space. And your video puts some of the things we've talked about into action. For this particular song, you could have chosen a freight train video or focused on that lyric, "Gravity's just a habit." Did you know when you wrote those lyrics what your plans were for this video, or did that idea come later?
That idea definitely came later. As soon as I learned about parabolic flight, I'm guessing early aughts, I was like, that is something we have to do for video. But the economics of making music videos in microgravity aren't such that you can just plan on that happening. You know, you can't be like, yeah, I'll write a song about that. We had to. I pitched that idea to, I can't tell you how many sponsors. Every time a brand would come to us and say, we love your videos. Do you want to make a video for our brand? And say, yeah. You know, Pepsi really won't look like the real thing you want until you see it in zero gravity. And they go, yeah, I don't think so. But like just by sheer luck, after I think 7 years of those pitches or something, an airline came to us and said, we'd love to collaborate with you. How do you work? And I said, well, the best version of a collaboration for us is for you to tell us that what you have that you'd like us to make art with, and then give us a moment to do it. Yeah. And they were like, well, just what would you do with an airplane? And I was like, I know exactly what I do with an airplane. And they had the good humor and flexibility and sort of creative bravery to try to pull something like that off. It's not, it's very different than what marketing budgets are normally spent on, and it's the type of thing that I didn't know what it was going to look like going into it. It's just sort of like you have to really extend a lot of faith in the process and just sort of go like, we're gonna do something. And I think it would have been very hard to do with we did that with a Russian airline called S7, and I think it would have been very, very hard to do with a big American airline where there's a much more sort of careful machinery for their marketing, and it was an amazing experience. Like what they said, if we were to do this idea, what would you do? And I was like, well, our process is basically, there's sort of 3 main steps. One is building a vocabulary of things we think are really awesome within whatever sandbox we've chosen. And this sandbox is, of course, an incredibly exciting one, but one that's also very hard to guess about in advance. You don't know what's going to look good. You certainly don't know how it's going to feel and how things are going to act. But our assumptions about what will have emotional impact in that space are very hard to check. You know, we can all guess pretty accurately about how physics is going to work and how and what sorts of things we can plan on happening from a scientific perspective, but from an emotional perspective, it's very hard to guess. So it's like we'll need to spend a bunch of time just trying stuff. Once we have that big sort of set of cool tricks, we have to figure out the sentence we are saying with that vocabulary we now have, and that, you know, choreograph and practice, and then finally we have to shoot the thing. And they said, well, how many parabolic flights would you need? And we're like, 20. And so it was. We wound up having to do 21 so we could get one last take. And we flew from the Roscosmos base about an hour and a half east of Moscow, and it was a spectacularly strange and wonderful experience.
Well, you brought up Sandbox as a place where you play and design ideas for your creative arts. Talk about the educational platform. You know, this conference is on workforce development for space and industrial base. Talk about the Sandbox platform, how you came up with that idea, and why you decided to use your videos educationally.
I should say that I feel like teachers came up with this idea. The thing we're discussing here is okgosandbox.org, which is our sort of our educational side project, we call it. It is a collaboration between the band and the Playful Learning Lab at the University of St. Thomas, which is confusingly in St. Paul. And the Playful Learning Lab is this amazing group of students, and Dr. Anne-Marie Thomas, their leader, who study playful learning, as their name implies. And she and I met at a conference, and I told her that we had been hearing from teachers for decades now that they use our videos in their classrooms, and it's always such a big honor. And it's a little bit, it's almost a little embarrassing in the sense that we are, you know, as you might expect of artists or rock musicians, a little bit, you know, short-sighted and self-centered. Like we want to make these cool things, and the best we can hope for with a piece of music or a video, we thought, was that it would go out in the world, maybe make somebody feel a little bit of human connection, maybe make somebody's day less lonely, maybe help somebody get at that thing in their soul that they were trying to, that it's scratched deep in your brain that you're always trying to itch and can't quite get to. But you definitely don't think your videos are going to come back to you going like, hey, I've been out in the world teaching basic physics to a bunch of underprivileged kids. Like it's, the things, the selfless and amazing things that teachers do are so much more noble than what we do, that to learn that our videos are being used for engineering classes and physics classes and systems thinking and just, you know, in music classes and art classes has always been very thrilling. But we also didn't really know how to support it. Like, what do you do other than, we can't make, you know, our videos can be very expensive and very time consuming to make. How do we make them any faster? We can't. But so I asked her, like, what do we do to help teachers? And she was like, well, you just ask teachers what they want. So we did. And she helped us put out a survey for educators, and we got an incredible response about what tools teachers would like from the band. And so we with her help, we've been making them. And we call it OK Go Sandbox because that is the metaphor we most often use. I could talk about it specific to space, or I could talk about it specific to ones and zeros, or I could talk about it specific to music. It's I think what we most often are trying to do is figure out the right balance between respecting categories and blowing right through them. And so defining what our sandbox is at any given time, whether that's the sounds we're going to use for the guitar solo, or that is what type of idea this video is going to have, or whether or not aerospace should be considered a scientific endeavor or an artistic one. It's all sort of the same. It's all the same balance all the time. You need categories to parse something, but you also need to have a healthy disrespect for those categories.
Yeah, yeah, wonderful. We're excited to see more from Sandbox. Can you take a snippet from that? You have a great video on how you made this production, so logistics of the parabolic timing and all. Can you just do a brief little snippet to give us an example of what's on Sandbox?
As you can see, brief is not my strong suit, but I will do my best. Usually when I'm asked questions about this video, I have to explain what parabolic flight is, and luckily this is one group I assume I don't need to do that with.
You're on top of it.
Yeah. So this, as you know, the maximum safe microgravity period that most people use is roughly 29 seconds, somewhere between 25 and 30 seconds. If you're going between, I guess, 15,000 and 40,000 feet. And our song could be broken down into 8 segments that were the same length and roughly and fit in within that period. Or I should say, our song could be broken down into 8 21-second periods, and that wound up helping us very slightly, because things after that long discovery period. See, I'm already not being brief. After that long discovery period, we realized that one problem with emotions in zero gravity is that everything looks like it's in slow motion a little bit, because it's basically the same. The signifiers our brain uses for saying, "Oh, this is slow motion," like something isn't falling at the rate you'd expect, are all happening in front of you in zero gravity. So getting things to look sharp and dancey and exciting and somehow having a kind of wow factor, it helps to speed things up a little bit. It also, we needed to cut the music up in a way where let's start again. We knew that our eventual video, we wanted to be floating the whole time, but we couldn't do that for 3+ minutes. So we also wanted it to be a single take, so that you weren't doing it, so that it wasn't sort of a greatest hits of what we were doing up there, but you actually knew this was a real event. And that's often the trick we use in our videos, is just make sure there's as little filmmaking as possible, that it really is just sort of the most transparent window you can use into seeing this real event. So we had to do a series of parabolas in a row and somehow deal with all the time that the plane would be catching us in double gravity, reclimbing, and throwing us in double gravity. For each of those, each period is about 5 minutes of recovery time and about 30 seconds of weightless time, or microgravity time. And so what we did was we strung those together and sped up those 5 minutes so fast that their effect, it's almost like an edit. It's basically, we stayed perfectly still in our chairs for 5 minutes and then restarted. The effect of that in the video is that you see us floating, and then every once in a while we have to land for a second and pop back up. We're actually landing, waiting there for 5 minutes, and then popping back up. But we wanted those landings to be on musical beats. So instead of just cutting it up every 28 seconds, we figured out where the segments of 4 or 8 that we could land on so that it would feel musical. Once we had that, we now knew that we'll have 8 segments of choreography. We had to learn them independent of each other, then string them together, and then basically by trial and error, figure out how you start the music and the dance just in time to achieve the maximum amount of weightlessness, but also not, we couldn't end too early or too late, because if gravity appears right in the middle of the song, we'll be plopping out of the video. If we can't get down to our seats in time for the sort of jump in time, we also will be popping out of the video. So it was a lot of delicate math and trial and error. that was not brief and probably very confusing.
But it was fascinating. And anyone who have some questions in the chat about the name, the Vomit Comet, and how you all fared, but they can go watch the video. You cover that in the sandbox.
We were all on scopolamine. Sorry, all the Americans were on scopolamine. No, not all. All of the band members were on scopolamine. Scopolamine, as it turns out, is illegal in Russia, or at least is a tightly controlled substance and not something that we were allowed to bring for our compatriots. And so our Russian friends were on other anti-nausea drugs, and some of them did not work as well as ours.
Too bad.
Just leave it at that.
Darn
you get to know what a liquid looks like floating past when the hardest thing to do, of course, in that circumstances is focus on a tiny little thing. The best thing to do is just look out the window. But our playback guy had a little MP3 player, and as you know from the last answer, if he didn't hit it exactly the right time on exactly the right song, the right segment of the song, everything would go up the creek. And the poor guy was just standing there like this the whole time, and he puked twice per flight, that poor guy, because but what a hero.
So a quick question from a dancer's perspective. Did you audition the dancers in the plane or make selections on the ground? And were they experienced already in parabolic flight?
We had to guess at what type of dancers would make sense for this. And we could not waste a flight auditioning people. So we were trying to think about who would have the right skills for something. Traditional dancers rely so much on gravity that they were sort of perfectly wrong for this. And synchronized swimmers rely so much on being able to push off the water around them that they would be wrong for this. And the best we could come up with was aerialist acrobats.
Mm-hmm.
Those are both circus performers who do a lot of spinning on it. The people who do silks or spinning in a big hoop. Our thinking was they'll have great body control and they will be less likely to get motion sick. Let's see. We were figuring that what they most needed to be able to do was control their body using internal forces rather than external ones. The thing that I knew from having done test flights prior to this was everybody's first instinct is to dog battle. Everybody wants to push off, and everybody thinks that you have some control over your body because we're all used to having either a surface to push off of, or if you feel weightless, presumably it's because you're floating in water, and so you do the thing you learned from that. We made a good choice, I think, in the end. Those women were vastly more talented in that space than we were, and could control themselves much more than we could.
That actually, they were spectacular, and they settled a bit of a debate here, but you may be able to bring it back to life. We talk in this crowd about how people can do things in weightlessness that they can't do on Earth. And that's brought about a debate as to whether that means it's a level playing field. Does it level the playing field, or is it just a new playing field? And I think looking at the difference between your movements and the dancers' movements supports the argument that it's just a new playing field and people are going to develop their advantages and disadvantages. But what thoughts do you have about that?
It's absolutely just a different playing field. There's nothing level about it. It is the farthest thing from level. It is. There are so many ways to cut that. One is the different types of physicality that are useful, but also at least for our generation and presumably several to come, it is the novelty of that experience is going to come infrequently and later in life. So it's not going to be something you learned when your body was learning. I mean, I have 3-year-old twins right now. In fact, I almost was late to this because we were having a meltdown upstairs about how I didn't let one of them watch me make coffee. but I watched them all day long doing, their bodies immediately learned physical equilibrium things that our bodies would take months or years now of training to do. And they're incredible machines for learning. Our bodies will never have, we won't ever have the chance to do that with zero gravity. So our generation won't. Who knows about future generations? But it means that there was a stark difference I saw among the adults, which is all of us, in learning curve and how people approach that sort of steep cliff. I really enjoyed that experience and really had fun sort of with the disorientation of it. At least one member of our band really hated it. And by the 21st flight, finally got the courage to try some things that he then found really fun. But it is just, some of that is personality type, some of that is personal history, some of that is physicality, but there's, I could even get more into, it'd be boring here, but that it's not a linear curve for everybody either. There's people who will try things right away. It's like, there's so much to learn and so many ways to learn it that, that it is, again, the farthest thing from a level playing field, but it's many, many new playing fields that cut different ways,
Yeah, yeah. You talked a little bit about the timeline to doing more. Where do you see the future of arts in space, and would you expand your body of work as space tourism develops if those opportunities were to arise?
The second one's easier to answer. Yes, we would. But our criteria is different than for what makes a good project is different than people often assume, because they so often are land on people as sort of novelty or as like using a novel idea. Those are equated in their minds, and to us, it's often very hard to find a good idea with something that's purely novel. Like, what would we shoot in if I could go up for 8 minutes with one of the billionaires who's doing that these days? What would I shoot? It would. I couldn't think of anything better than what we've already made. And in fact, it would be much worse because I could only go up once instead of 20 times. So in terms of, that'll actually lead me to the other answer. Where do I think art in space is going? I would like to invert that sort of back to the sort of category question before. I think it's important to have these categories. I think it's very important that people study physics and engineering and various specificities within specific concerns within the aerospace industries. We would never have gotten here without it. But it's also important to look. I will use a personal experience. I remember going to the vehicle assembly building in where they were in the process of dismantling the final the last space shuttle. I guess not fully dismantling it, but restoring it about 10 years ago, whenever that was, and feeling a sense of awe in that building that was more like a cathedral than any cathedral I've ever been in. I went to school in the shadow of a cathedral at a boys' school in Washington, D.C., and I spent a lot of time in that cathedral, and it was amazing. But the essence of those spaces was very similar because they're basically the same project. Like a person in 1950 saying we need to start going to space is just as crazy as somebody saying we should build this massive, house of God in a few centuries prior. Like that, doing something so purely based on curiosity and wonder that's like where these categories merge at the very top. It's sort of like, we just care. It's just too fascinating and too wonderful and too weird. And you have to start breaking that down very, below that. Is this a scientific concern or a mathematical concern or a theological concern? But they're all, at the end, it all is really the same impulse that we're dealing with. And there is nothing about space that is more scientific than life on Earth. You know, there's nothing about art that needs to stay in this atmosphere. It's like those are just convenient categories we use. And so as access to space becomes something that doesn't need to be so tightly controlled because it's so expensive and because utilitarian concerns and scientific concerns are trumping all other concerns, there will be more and more opportunity for those categories to start to destabilize a little bit, I think. And I'm trying to think if there are good corollaries. You can think of really anything that we think of as art was one time long before that purely practical and pragmatic. You know, even paint. You know, even language. It's like there's once we get past the pure necessity of something, is how do we get out into space? How do we survive on the surface of Mars, or how do our bodies react to long periods of weightlessness? Once we've dealt with those pure necessities, our immediate instinct will be like, how do we connect with one another? How do we make this more powerful than the single experience that I'm having? How do we communicate this to the rest of the world? And I mean, the things we will all think about on our deathbed will not be equations, presumably. They will be human experiences, and that most of our lives are spent trying to deal with those human experiences with the people we love, or the people we're scared of, or the people it's like that's our whole life. So that will be all of space eventually too. We're just in the phase where we are barely chipping away at it, and sooner than I think we can imagine, that the more human concerns of the humanities will be all over space too.
That's wonderful. Your comparison of cathedrals to space-related things is a comparison drawn by the author Frank White and space scholar Frank White in his book, The Overview Effect. In more ways than just the feeling that it gives you, although that as well. So you might enjoy reading that book. You've advocated for net neutrality before Congress, and it sounds like you're kind of into space, which I wasn't sure when I set this up. Do you see yourself as a possible advocate for making space one of the critical infrastructures for the United States, especially as satellite constellations are bringing the internet to underserved communities?
Absolutely. Unquestionably.
Wonderful. Okay, well, we'll spread the word on that.
Yeah.
So everyone knows your wonderful videos. Tell us about, just for fun, a failure that you've had.
Oh boy.
In designing something that just didn't work.
They aren't as binary as that. It's not work or don't work. It is the things that haven't worked yet are many. You know, there are. If I could do 20 more of those flights and knew it, this would be a totally different video.
Yeah.
You know, so this video, which did work, failed to do some things that it would have done if I had 40 flights instead of 20. And there are many, there are a handful of ideas I'm really excited about artistically right now, all of which are more expensive than I can personally afford. And so all of them have failed so far. And the way I'm imagining them in my mind is not how they will wind up coming out if I ever find the funding for them. And then look, so that's sort of like, how it's not digital, you know, how it's not binary from one angle. From the other angle, it's looking back on things that have happened and whether or not there were failures. It's more like you learn from things what you expected to happen and didn't. And there is a video we made where it's an animation, and each frame of that animation is is toasted into a piece of bread. So we used a laser cutter to very lightly toast things in very specific patterns. And there's 3,000 something slices of bread, all of which were past the sell-by date and were donated by I did not realize how many people would be very upset that we had wasted all of
and fed to wild ducks, right? After
exactly. No, they're even more shocking. There's several of them are still in my basement and not moldy at all, which makes me think of how I'm not going to tell you what brand it is because that's how much preservative is in it, and we would like to be nice to them. Anyhow, the issue, I learned a lot from that video because I thought that doing something this very physical way, where you could feel the sense of animation and you could sort of like, you never lost touch with the fact that these were real objects, would have a, I expected it to feel one way that it didn't. It does feel that way, but only for the first 15 seconds, 20 seconds, 30 seconds, maybe. You quickly lose, for me at least, or most people I've sort of like watch it, quickly are watching the animation. It's just a story, and that's beautiful, that's wonderful, but it also means that video, after the first 30 seconds, never sort of has a new sense of wow. Our projects are often about trying to choreograph surprise more than they are anything else, to sort of like build a crescendo of wonder or of curiosity that matches the song. And that one we couldn't. You have this big hit of it right in the beginning, and then you're watching an animation, and it's a beautiful animation, and the animator who made it, I think I'm totally think is amazing. His name is Jeff McFetridge, but it taught me that taught me a lot about novelty. That this was that this idea was it was a novel place to go, but that it wasn't a place that had an arc in it. It was just a place that had a one point. It was sort of like, here's your point. And that was it. And so when we were doing the zero gravity video, for instance, it was very important not to repeat that. To go, there's one great trick about this is that you're at your wait list. We had to figure out within that, and it was actually very hard to, like, we had to make the wowest moment we could find wasn't a huge shocker. It was sort of what we've all seen before. It was like, liquids look amazing, and so we had to build up to it really slowly. And we actually had to, it was the hardest part about that choreography was trying to figure out a way to do something interesting in the beginning that was also still kind of boring, because we needed to like have a lot of space to keep going. So we did this like laptop, we did this dance with laptops on our that like suddenly we're able to spin these laptops, and you're sort of like, what's happening? But it's confusing enough to catch your interest, but it's not so exciting that we don't have room to still keep
do the spiral of dancers.
Right. And it's a very, so that failure in the earlier animated video taught us a lot about process, which is that like, it's not that it becomes really important for us to figure out what our whole bag of tricks is, and then use those, place those in a satisfying arc. So you can't just go, what's the coolest thing about this, and then play with it. You have to sort of go, what's the coolest thing about this? Can I find something more? If that's the best that I can do, then are there 4 steps leading up to it? Because if not, you just sort of have one statement, and that's not a song. That's just a beat. That's a
right. Awesome. Great. Well, Damien, we're about out of time. I wanted to share that I think one of the things that endears OK Go to the dance community, beside the relationship to Trish Z, is that you don't use the pedestrian nature of your own movements as an excuse not to polish and commit to the performance. The attention to detail and cleanliness in the execution of your work complements the world-class creativity and design. Dance is an art form and not a sport. And your performance.
That is a beautiful way of saying we are in fact terrible dancers, and we have no shame. We still do it anyways.
Yes, and now you've made a work that endears you to the space community as well by making beautiful, fun, and inspirational imagery available to a broader audience. Thank you so much for being here today.
It was a lot of fun. Thank you.
All right.
Bye, guys.
Bye. All right, and thank you to the Thunderbird School of Management's new program for that generous sponsorship. And our next speaker is the incomparable Shelley Brunswick. Shelley Brunswick, COO of Space Foundation, brings a broad perspective and deep vision of the global space ecosystem. From a distinguished career as a space acquisition and program management leader and congressional liaison for the U.S. Air Force to her current role, including overseeing the Center of Innovation and Education, Symposium 365, and Global Alliance. And I do want to highlight that Air Force experience. Really grateful for your service, Shelley, and advocating for space technology innovation, entrepreneurship, diversity, and inclusion. Shelley collaborates with organizations around the world to connect commercial, government, and educational sectors. She actively participates with Women in Aerospace Foundation, Women's Global Gathering, United Nations Space for Women, Women Tech Network, Islamic World Educational, Scientific, and Cultural Organization, World Business Angels Investment Forum, Global Women Leaders Committee, New York University, Women in Global Policy Insights, and the fellowship program there, the USA for Global Policy Insights, the Quad Forum, Space Tourism Society in Africa, where she'll be part of a speaker at the first African Space Week in September, Todayers, Lifeboat Foundation, Manufacturers Edge, and the Colorado Springs Chamber and Economic Development Council. Shelley, we're so grateful you could join us today. Thank you for being here.
Well, thank you so much, Lee. It's an honor to be joining you and your esteemed audience. And I love participating in Foundation for the Future events. They're so enlightening. And your last guest was just exciting and really illustrated the opportunities that are available. So I always enjoy tuning in as well. So thank you for inviting me. And I'm looking forward to having a great discussion. I did only bring 1,000 PowerPoint slides that I can share. And I'm happy to talk about those, or if you want to just ask questions, I'm happy with that too. So I'm very flexible, and we want to do what's best for your audience and what will make it most entertaining and enjoyable for them.
Yeah, why don't you start with a brief introduction to Space Foundation and the Center for Innovation and Education, and then we can talk from there.
That sounds perfect. So I'm bringing up my slides. So I want to say, can you all see them? Can you see the slides, Lee?
Yes, that looks great.
Perfect. So I'll just kind of walk through a few slides that talk about Space Foundation. What is the space ecosystem? What are space-related technologies? And then what are the career fields? Because many times there's not a baseline for what that means. And so the Space Foundation is very passionate about highlighting what the baseline and how do you get into the space ecosystem. So we believe advocating for innovation is about bettering life here on Earth. And as Lee said in that very long introduction that we're going to cut down before the next time, Lee, there are 3 main divisions at Space Foundation. We have our Symposium 365, which is the premier source for information. And that is, if you know anything about Space Foundation, most people know about our annual Space Symposium that will be taking place in 2 weeks here in Colorado Springs, all COVID safety procedures in place. But we also have a virtual platform called 365 because the space ecosystem runs more than 4 days a year in person. It runs throughout the year. We also have our annual space report and our quarterly space report. You'll be hearing a presentation about that shortly, so I look forward to hearing more on that. So that's really that Symposium 365, your trusted source for information. And then Global Alliance, that's something I was doing this morning. I was on an interview with individuals from the United Arab Emirates. And what we're doing with our Global Alliance is we are your trusted partner, both US as well as internationally, for all space activities. So we put out thought leadership articles about various regions of the world. We're doing webinar series on emerging trends. As Lee was kind enough to highlight, I was invited to speak at the first African Space Week next month. In October, I'll be traveling to Dubai for the Dubai Expo for their Space Week. So the Space Foundation is out there building the partnerships and collaborations, because space is really a global entity and it brings all of us together. And then the division I'm mainly going to talk to you about today is our Center for Innovation and Education. And this is a lifelong learning platform for workforce development and economic opportunity. And again, today's Foundation for the Future theme is workforce development. So this fits squarely into what is not only the workforce of today, but what is going to be the workforce of the future and how do we get there? So I don't want to steal too much thunder because I know you're going to hear a lot more about the space report coming up. But let me just share a few numbers that whet your appetite why space is so exciting. In 2020, the Space Foundation, through our space report, said the global space ecosystem was $447 billion. 80% of that is commercial, meaning products and services, jobs, opportunity, workforce development. And why that number is so important is where it's projected to go. Again, Foundation for the Future. And the future look from Bank of America is that by 2030, the global space ecosystem will be about 1.4 trillion. And then by 2040, it'll be over 3 trillion. So we are seeing exponential growth. And more than 85 countries operate in space, but there are 3 types of countries that are part of the space ecosystem. There are those countries that operate in space. There are those countries that are emerging space countries that are going to operate in space. And then there are countries that are going to take advantage of space technology. So basically what I'm saying is every country and every citizen uses space technology and is part of the space ecosystem. These are some of those technologies we talk about. Obviously, satellite servicing and repair and debris monitoring, removal are probably things you've heard about, but so is virtual reality and manufacturing and healthcare and pharmaceuticals and energy storage solutions. So when you think about space and emerging technologies, they're all interlaid upon each other. They're all part of that space ecosystem. So an example is for data analytics, there's so much information coming off satellites today that we need virtual reality and artificial intelligence to help us process that information coming off satellites quickly and then coordinate and collaborate with the human being that's in the decision-making loop, because a human being cannot process the amount of information. And the information that is going to be coming from sensors, not only in space, but on Earth, is going to grow exponentially. Think about electric vehicles. All of those electric vehicles are a multitude of sensors that are going to be sending their information to help provide real-time data awareness. Is that accidents on the road? Is it your positioning? Is it road conditions? And where is that information going? Is it going to the Department of Transportation so they can fill that pothole? Is it going to the police department because you passed an accident? So as we continue to move in this emerging technology that is perpetually going forward, we are going to have an abundance of data analytics that needs to be done. And again, human beings are not going to be able to process this in a timely manner, and that's where artificial intelligence steps in. Energy and energy storage solutions. I don't want to steal too much from Lee because I know you've had so many great speakers, but we know to go to Mars and the moon, we're not going to be able to use the same solar panels we have now. We need different storage solutions. We need those storage solutions on Earth now. You know, we need to become more sustainable. We need to become carbon neutral, removing carbon as a matter of fact. And there are technologies that we can get by going to the moon that can benefit us here on Earth. One of them is helium-3, which can help with nuclear energy. That is a solution for carbon reducing emissions and actually getting us to net zero, stopping climate change, and hopefully reversing it. So we need that technology to go to space, but we really need that technology on Earth. And healthcare, as we think about space, we have to slow the aging process because we are leaving Earth's gravity and the atmosphere, the very thin, tiny atmosphere that protects us from radiation. And when we've seen from astronauts that go to space, the aging process increases. One, we suffer from not having a gravity environment with the fluid doesn't know where it's going. It's hard to tell what's up and down because your ears operate on gravity and fluid. Men have a lot of eye trouble because the fluid is all pooling up in the head. Women develop osteoporosis faster because there's no gravity, so our bones become weaker. And there's a myriad of other challenges. So as we think about going to space, we're going to solve those technology challenges and healthcare solutions on Earth. And of course, I could go into 1,000 other items, but for those of you that are watching and are interested in what are some of these technologies, you could go to the NASA Technology Transfer Office, and they have thousands of patents that are waiting to be commercialized in healthcare and energy and agriculture and telecommunications and transportation and more. So if you're interested in being an entrepreneur or know somebody that is, this is a great resource. And I shared some of the technology that has already come from the space program that we utilize every day. One would be the platform we're talking on today. Not possible without space technology and cybersecurity. But we also love our cell phones and can't live without them. And they have 3 different types of space technology: cordless power tools, weather detection. You know, as we're watching climate change, being able to Earth observe what's happening on the planet, preparing individuals so they can prepare for hurricanes or cloud patterns, or as we're getting on airplanes, we want pilots to have the best weather prediction so that they can navigate around turbulence, save fuel, and reduce the time of our travel. Firefighters are greatly appreciative of the fire retardant clothing that came from the space era. And again, we look at formulated food and so many others. So as you think about space technology, you can think about how it's helping us every day. So again, I'm not going to steal too much thunder because you're going to get a great talk about the space report coming up. But the space report is put out by the Space Foundation's R&A team, research and analysis team, and it compiles both an online database as well as quarterly products that highlight different areas of the space ecosystem. And this year, we're actually putting out 2 special editions. So this month in August, we're putting out a special edition before Symposium, and then we're going to put out another special edition in the spring before Symposium in April. But what this shares with you is when you look at the blue and the red, what we're highlighting is 80% of the space ecosystem is commercial, which again is jobs and services and entrepreneurship. And that's not saying the smaller slice of the pie, the government spending, is not contributing to jobs or GDP, but it's a smaller amount. As we commercialize and the government pays for less of this, that means entrepreneurs and the commercialization take over. So we as taxpayers, our money is then spent on other activities that benefit us. So we also talked about what are those career paths. And many times we think about astronauts and launch vehicles, but today, I'm going to say everyone can be part of the space industry. We need astronauts and rocket scientists, but we need project managers and trades workers and manufacturing and artists and entrepreneurs. So the opportunity for everyone to find a career path has never been greater. We also have to look at being lifelong learners because technology is continuing to advance rapidly. Some jobs are going to change and embrace more technology in them. Some jobs may go away and new jobs are going to come online. So we need to make sure that we're going to continue to retool and upskill and tweak our workforce as new jobs come online. And the other area about the space industry is 40 years ago, it was primarily white male, US, primarily government, maybe Russia, China, and a few other countries. Now it is every country. And so in the US, we particularly, as well as globally, want to look at how do we reach underrepresented groups. So we could call them minorities and women, but we'll say underrepresented, because that can include inner cities or rural communities, as well as regions of the world. You know, Lee highlighted, I'll be speaking at a conference in Africa. Well, Africa has 54 countries. Some of them are already operating in space. Some of them want to use space technology. And there's some other groups we partner with. Lee mentioned ISESCO, the Islamic World Educational, Scientific, and Cultural Organization. They have named this the Year of the Woman. So getting more women and diversity into the space ecosystem. So the Space Foundation, we're really passionate about democratization of space and providing pathways for all citizens. In the US, as well as some other countries that have an aging workforce, such as Europe or Japan, China to an extent, we do see a workforce shortage. We have a large baby boomer crowd that is getting ready to retire. And COVID has accelerated this. What we're seeing is where some people thought maybe they're going to work till 60 or 65 or 70, COVID has caused them to reevaluate their priorities. And I'm seeing a lot of friends, so that might tell you how old I am. I see a lot of friends saying, I'm going to get an RV and we're going to travel for a year. Or I have two friends who are colonels in the Air Force that are retiring and they're going to move to West Virginia and they want to spend time with their kids while they're still young. So we're also seeing individuals that are reprioritizing what's most important to them. What that's causing is a workforce shortage. We're seeing that everywhere in the country, but we were seeing this even during COVID. The space industry was still hiring. We also have that skills deficit. As I shared, I have job openings, but I may have individuals that are transitioning out of the hospitality or the entertainment or the cruise industry. And so they're going to need to be reskilled and upskilled to come in and take these jobs. And then again, we have an innovation gap. It's not just thousands of patents at NASA that are waiting to be commercialized. So is the European Space Agency. They have a technology transfer office, as does the Air Force Research Lab and the Department of Energy. So these patents are waiting for entrepreneurs to bring them to market. Many times you can apply for grants to help you do this. That's why the Space Foundation has launched our Center for Innovation and Education. It's all about creating workforce development, because when you're an entrepreneur, you create a job not just for you, but for others, and then you create an ecosystem. So it's workforce development and economic opportunity. So creating that economic growth and then creating the career fields that are directly part of the space ecosystem, but then that also support the space ecosystem. I have numerous teachers here at the Space Foundation. I'm not necessarily sure they're in the space industry proper, like you'd say, are they at SpaceX? But they are certainly part of the space ecosystem in creating that future workforce. So again, students, teachers, entrepreneurs, and professionals have a pathway to be part of the growing space ecosystem. This is how the Space Foundation operates. We look for partnerships with that Global Alliance division. We look for sponsorships and grants. We do fundraising, look for donations and endowments. So we are a 501c3 for education, and we are a US nonprofit that does business internationally. So what I want to really highlight is how do we look at creating that future workforce? And we believe we have a workforce development roadmap that's very successful and tried and tested. And it has 5 steps: awareness, access, training, connecting, and mentoring. The first step is people have to understand that the space industry is for them. That's why these programs today, Foundation for the Futures program, is so important, because it's helping to get the message out that everyone has a way into the space ecosystem. 2 is, what is that access point now? How do you break down the barriers of the perception that space is not for me? And those of us in the space ecosystem, how do we extend a hand to help individuals come into it? And that could be through several of our programs at Space Foundation, whether it's symposium or our space commerce entrepreneurship and leadership programs, our New Gen Young Mentoring, or other programs that are available. I'm going to talk about those in a minute. So we have to create an access point into the space ecosystem. Then it's about training. So although an individual who is transitioning out of the tourism sector wants to come into the space industry, they may need to get some training. Is that formal or informal training? So both are valuable. Formal training is, do you go to International Space University? Or I heard earlier, Lee, with my good friend Greg from Arizona State University and the new master's program that is just fabulous. Or is it informal education? Do you take a program with Space Foundation? Or do you watch some great webinars like Foundation for the Future? So there's a multitude of ways to get educated and informed, formal and informal. There's also entrepreneurs, internship programs, and others. Then you have to build those connections. You participate in events like this, and you look at, I'm looking at all your pictures over here on the side, and I say, Alice, you know, I want to get to know Alice more, and I'm going to reach out to her. So I'm going to start building those connections with people that are like-minded in the space industry. It's also partnering with Foundation for the Future and Space Foundation and the UN Office of Outer Space Affairs and Space Generation Advisory Council and Toad Air and all those other organizations that Lee shared that I participate in, because they all create an access point for people to come into the space industry. And last, and many times this is first, is mentorship. Finding a good mentor can help you overcome those other hurdles in that space industry. And there are great mentoring opportunities with Women Tech Network, which, don't let the name fool you, it's open to women and men, as well as the UN Office of Outer Space Affairs Space for Women program, again, open to men and women, Space Generation Advisory Council. And the other thing I share with you, all of you would be great mentors too. So think of it that not only do you want to have a mentor or be a protege, you should be a mentor because you have so much to offer other individuals. So consider being a mentor. This is a little bit how the Space Foundation does business. So you're on the gray dot that says Space Foundation. And the next step is, who is the target audience we want to reach? Is it K through 12 students or entrepreneurs or small businesses or professionals? So we really want to hone in on who is the target audience we're trying to help. Then the next step is, what is the goal? What is the goal or measure of success with that help? Is it networking? Is it career upskilling, immersive experiences? And then once we understand the target audience and the goals and objectives, then we look around the sphere of Space Foundation programs to determine, can we deliver and meet all those goals and objectives as the Space Foundation singularly alone? Or do we want to partner with another university like Greg at ASU or ISU, or we're partnering with CSU Pueblo or other organizations like Foundation for the Future to deliver a comprehensive program that meets all the goals and objectives. The biggest takeaway probably on the slide for you though is, on the sides are the 16 different sectors that the Space Foundation considers to be part of the space ecosystem. So you're definitely seeing space. But again, there's agriculture and energy and healthcare and pharmaceuticals and the Internet of Things and transportation. So whether you knew it or not, you're already part of the space ecosystem. The question is, where do you want to go from today to build your foundation for the future? I'm just going to cover 2 quick programs we offer so you can kind of understand how that workforce development roadmap works. We do have an entrepreneur and leadership program. And this was initially started with the Minority Business Development Agency to create more access and opportunity to underrepresented groups and create a pathway so individuals could come into the space ecosystem. Remember, breaking down that barrier, extending a hand to create that access point. We did also create it so that anyone can take our programs online virtually with free webinars. We also did in-person workshops. This was pre-COVID, but now we're coming out of COVID with in-person workshops as well as virtual workshops. And you can see how we did that workforce development roadmap, partnering with the Minority Business Development Agency, partnering with universities, creating training programs with videos and workshops, connecting. Some of those individuals received scholarships to our space symposium so they could connect into the space ecosystem. And several of them came out with letters of intent for their business, and then helping them have mentors and coaches throughout this journey. We take this entrepreneurial theme into the high school as well, because we need to create more innovative and entrepreneurial future leaders. And so this is our junior space entrepreneurship program, and it's 2-phase. One, kids are part of a team. And the team is, you could say it's like a SpaceX or a NASA team. They're doing all the math and science to go to Mars and safely return. But then all the kids get a new hat, because once they've returned from Mars, they now have to think, what is one item they learned on their journey that they could commercialize. And now they're a company, and now they all wear different hats. One is the finance officer, one is the technology officer, one is the marketing officer. So they learn about going to Mars with the math and the science and the excitement, and then they learn what it's like to be an entrepreneur. And again, we did this through our 5-step workforce development roadmap. I wanted to share again some of those networking and mentoring opportunities that are out there, both for you to find a mentor, but also be a mentor and join like-minded individuals that want to be part of the space ecosystem. I also highlighted our Symposium 365 that goes on 365 days a year, so we hope you'll join us, as well as continue to follow Foundation for the Future. And this is how you can reach me. I did put my LinkedIn in the chat, and you can follow me there as well. And so what I'm going to do, Lee, is I'm going to, now that we've done just a little bit of the overview, and I hope individuals have a much better understanding of the Space Foundation, our partnership with Foundation for the Future, and how we operate. And I know there are some questions coming into the chat. I'm happy to stay and answer questions and be respectful of time as well.
Okay, great. I do have a couple of questions. I love how Space Foundation takes the whole mantra of think globally, act locally, and just balls it up and throws us in the garbage, because we think globally and act globally and even beyond, right? So, you know, not just awareness. You've done amazing work, especially I think during the pandemic, to build awareness through all the speaking that you're doing, both here and at all kinds of events around the world. But those specifics about the programs are really exciting. I think we've received at Space Foundation a couple of grant awards in the last few days even. And why don't you tell us a little bit about those programs?
Sure. So one of the things we do is with our programs, again, who are we partnering with? What are the objectives? So we did recently, and it's not public yet, is we have received a grant, and I'm not going to name the agency yet because it's not formally announced, to do our junior space entrepreneurship program with partner schools in the local Colorado Springs area. So we can go out into the schools and start to build those pathways with high school students. So that's one. Our JSEP program received a grant. We've also received a grant for our museum. We have our Space Foundation Discovery Center located in Colorado Springs, and that's where it's open to the public, but we also are open to school groups, especially disadvantaged communities that maybe can't attend Space Foundation Discovery Center, or they don't have the bus stipend to bus students to our facility. So we have a museum grant, and the program we're going to offer is called Small Steps, Giant Leaps, where we can start working with kids to learn about the space ecosystem, so eventually they become the future leaders. And a third grant we've received is for our space commerce entrepreneur and leadership program, to do a program in Paraguay. So we have 3 grants, and then we're also partnering on another grant coming up for our space commerce program. And again, it's I kind of balled it all together. It's under our heading, and Leah's laughing. So I like to say we have the house, right? The development, and then, you know, Center for Innovation and Education is like the HOA. And then it has 3 main subdivisions, right? Those big subdivisions. So one is our Space Foundation Discovery Center. The next one is education, and that's really K through 12 and teaching teachers. And then the third subdivision is our Space Foundation University. And those are more adult facilitation. You get a certificate, you go through our program. We have informal courses where you learn about space commerce. We do boot camps for entrepreneurship and innovation. We include leadership training as well, being a space leader and entrepreneur, and there's mentoring and coaching along the way. And all of these programs can both be delivered here in Colorado Springs. So we are open. Before COVID, we were open to have individuals come through our programs here. We put a stop. We're now reevaluating, can we reopen that pipeline for individuals to come to Colorado Springs and go through our programs, hopefully starting next summer again. We also do them virtually, and then we will do them in person. So like the one in Paraguay. So I shared with you, Lee, that, you know, Center for Innovation and Education, that housing development with its 3 subdivisions is very robust. And again, we're looking at the current workforce, those adults that are wanting to reskill and upskill, as well as creating the future workforce, K through 12, and teaching teachers, and I don't want to say teaching teachers, I'm going to say sharing with teachers the importance that space is not about history and it's not about memorizing the planets. It's about creating career path and job opportunities for all citizens, for all kids. Kids who have a high school diploma can go into fantastic opportunities in manufacturing, advanced manufacturing, which is lab coats and 3D printing, all the way to rocket scientists. And so there are intern programs for kids in high school that can come right out of high school and go right into a job in manufacturing with an outstanding benefits, help their families. And there are intern programs like that all throughout the United States. There are other countries looking to create it, as well as, Arizona State University and Greg's wonderful program. So the Space Foundation really wants to help individuals find the right career path. And that's part of what we do with our teacher professional development, is many times teachers are the individuals who help students find career pathways. And so we have to help them understand that the space ecosystem has so many wonderful career pathways.
That's great. And I love how you highlighted technology transfer as well in your program, and wonder if, just to close us out, you could give one quick example of an entrepreneur who has benefited from the Tech Transfer Office and from Space Foundation's efforts as well.
Great question. So I'm going to give you a couple. One, there's a fabulous former NFL player who used the NASA Technology Transfer Office, took a healthcare application and commercialized it and brought it to market. And again, NASA helped him. He was able to get grants and funding. So you, as an entrepreneur, you can go to the NASA Technology Transfer Office. There are NASA people who can help you. There are grants you can apply for. The Space Foundation has individuals that can also, help you. The Space Foundation, I have to pay those consultants a fee, but you do have Small Business Administration, P-Tax, your Manufacturers Extension Partnership Program. There's one in every state to include Puerto Rico. So there are organizations in addition to Space Foundation that can help you. When we look at who has successfully gone through the Space Foundation Entrepreneurship Program, when we initially launched it, we had 275 plus small and medium-sized minority-owned businesses go through it. And some of them were very successful. They came to symposium and walked out with several letters of intent, both with the government as well as commercial viability. And we do have a space commerce entrepreneurship program going on at symposium this year that a company has sponsored to create more diversity in their supply chain. So they specifically said, Space Foundation, we want you to help us create a special track. We want you to help us find these underrepresented minority businesses. And then we want to bring them to symposium. We want you to create a special program for them. And we want them to meet our company representatives to see how they can do business with us. Now, of course, those companies will also be free to walk the exhibit hall and meet with all the other space companies and potentially grow their business. And that's what it's all about. Can we help those companies take it to the next step? So we have a lot of excitement. And again, we just received that grant to do a program in Paraguay with some great entrepreneurs as well. So a little bit there, Lee, about our past, our current, and our future plans for our space entrepreneurship efforts.
Thank you so much, Shelley. It's been a delight, as always, to have you on. It's such a privilege to work with you. And just for some of those resources, spacefoundation.org has a menu that includes the Center for Innovation and Education, and you can click on entrepreneurs there and find lots of information, free webinars that help guide entrepreneurs on how to build their businesses. So thank you so much, Shelley.
And if we could, I don't know if everybody is ready, but I would really be grateful if you would all take your beautiful pictures down, because this is the selfie of the future right now. And I would like to do a couple selfies, and I'm going to have to do two groups because there's 2 pages. This is how I like to do all my events. And then you're going to, so if you really don't want me to post you on Facebook or something, then don't take your picture down. But if you take your picture down, I would love to be able to post about what a wonderful event today was and the great job that Tim and Lee and the Foundation for the Future are doing. And Mike, I see you too. It's good to see you. So, all right, I'm going to do page 1 right now. So 1, 2, 3. And you probably don't even know who's on page 1 or page 2. And now I'm going to page 2. 1, 2, 3. All right. Well, thank you, Lee, for indulging me. I hope you all have an exciting time. And Muriel's here to now talk about the Space Foundation, our research and analysis team, and our great product called the Space Report. So thank you so much for hosting us and inviting Space Foundation to join
Hi,
you.
Shelley. Thanks for joining us. And Muriel, good to see you.
And thank you, Michael. We're grateful for all you do, and we continue to look forward to collaborate and continue to create more access and opportunity for all in the new global space ecosystem. Thank you.
Thank you, Shelley. All right. The always inspirational Shelley. Mariel, I'm sorry that we're running just a little bit late. Thank you for your patience. Mariel Borowitz is an associate professor in the Sam Nunn School of International Affairs at Georgia Tech. Her research deals with international space policy issues, including international cooperation in Earth observing satellites and space security challenges. She contributes to the Space Foundation's annual report, the Space Report, also a product of Space Foundation, and analyzing global workforce trends. Mariel, thank you for joining us today.
Great, thank you so much for having me. And I will share my screen here. Let's see. Let's try to find the right presentation. Let's do desktop and see if that'll work for me. Okay, are you able to see the presentation now?
We can see that. It's a little bit small if you can.
Yeah, let me put it in presentation mode.
There you go. We can
Perfect.
See
Always so nice when technology works. So thank you to Lee and to Conversations in the Future for having me here. I'm very happy to speak to this group. And as Shelley mentioned, I am going to talk about some material that's in the Space Report. So the Space Report has been around for more than a decade, and the document, the report basically looks at the global space industry and tries to look especially at different trends. And so there are sections on the economy, looking at government spending, looking at commercial revenue. So I also work on writing the commercial revenue section. There's a section on infrastructure and what's happening in terms of, the development of new space infrastructure. And there's a section on the global space workforce. And that's a section that I have worked on for over a decade. So I originally was a researcher in the research and analysis group at the Space Foundation before I left and got my PhD and became a professor. But even in my new role, I can't get enough of this. And so I have continued on as a kind of independent consultant working with the Space Foundation and particularly writing this workforce section for them for many years. And so you can see here kind of just the cover page over the years. I actually leave some out. There's so many of them just of this workforce section. And so what I want to talk about in my talk today is some of the trends that we're seeing and especially focusing on this previous year. I'll talk about the United States space workforce in a little bit more detail and give you some of the metrics and things that we're tracking there, some of the trends that we're seeing, and then I'll talk about the space workforce in other parts of the world. Feel free to stop me if you have questions along the way, and otherwise I believe I will have time for questions at the end of the presentation. Okay, so I first wanted to address, why is it interesting to look at the space workforce in this sort of quantitative way that I'm going to talk about today? Why do we want to look at these trends? So first, as I'm sure has been conveyed many times already in this session, the space workforce is incredibly important to the sector, right? It's the core of everything we do, everything that's possible in the industry, the advancements we're able to make. That's all because we have this workforce, right? And particularly a workforce that has very specialized skills or advanced education that is enabling us to do this cutting edge work, to do something that is very unique for our industry. Also, it's important to look at these trends because a healthy workforce contributes to broader economic benefits. So, when you have a group of space workers, say the clusters of space companies we have out in LA, for example, that has huge ramifications for that entire area. So even people that are not working directly for those companies really see the benefits of that in terms of the high-tech workforce, in terms of their engagement in the community, the economic impact for that region. And so understanding how large is this workforce? Where is this workforce? What kind of skills they have? What kind of companies are out there is really important for even people who aren't otherwise interested in space. And then also understanding the trends that are happening in the space workforce can give us insight into other industry trends. So just like we watch the economy, right? The space economy and what's happening with government funding, what's happening with commercial revenue from space, and we want to know what those trends are so we can see what's coming. Workforce plays that same role, right? So we want to know if the workforce is going up, going down, staying steady, where those changes are taking place, how it compares to other countries. And so that's the type of information that I'm going to present to you here. And once again, these are almost every chart I'm going to show you is from the most recent release of the space report. And so I highly recommend, if you're interested in this type of material, go out and take a look at that, pick up a copy. Obviously I'm a bit biased, but I think it's a really great publication that the Space Foundation puts out each year. Okay, so as I mentioned, I want to start with what's happening in the United States. And I put up this chart because it gives you, at the bottom, you can see here what's happening overall with the totals. And so we are relatively constant, going down a little bit over kind of the 10-year period, but over the last 5 years, going up quite a bit. And so if you were to zoom out, what you would see is a little bit of decrease in the space industry, particularly after the dot-com boom, kind of in the early 2000s. But that kind of leveled out probably around 2006, and now has been really increasing since then. And so you see that growth pretty significantly over the 5-year. And as Shelley mentioned, just thinking about this past year, even with COVID and a global pandemic and all of the challenges that come with that, which I'll speak to in a minute, we still saw growth in the United States in terms of the space industry. Another point I want to make, and the reason I use this chart, even though I know it's hard to read in this format, is to talk a little bit about how we measure the space sector in the United States. And so the best source of data that we have at this moment is from the Bureau of Labor Statistics, and that's where this data comes from. So the US Bureau of Labor Statistics collects information from every single employer in the United States on a regular basis. They have a very consistent method for doing that. And so it's great in terms of a reliable, consistent source that we can use year after year. But as you may be noticing from these categories on the side, it isn't a perfect one-for-one match with the space community, right? So we're getting broadcast and wireless communications equipment and manufacturing, guided missile and space vehicle manufacturing, for example. So they're not just space companies. We're catching a little bit of other stuff as well, although we do think that these categories are primarily space. We know there are space workers that we are not including in this analysis, right? So for example, there's a category that has to do with physical research, right? So physics and mathematics and engineering and some of these workers. And it's a huge number of workers that fit within that category because it's very broad. And so we know there are space workers captured in there. But if we were to include the whole category, it's not very accurate in terms of representing space because there's too much other stuff in there. So this is one of the challenges that we do have in terms of tracking what's happening in space. I think we have a pretty good number here and a pretty good sense of what the trends are. But that is one, I think, kind of interesting and useful gap to be aware of. That'd be great if we really had very space-specific numbers in the United States. Okay, so I mentioned that in this last year, we wanted to look at what happened in the pandemic in particular. And you saw overall, if you look at all the space, those space codes together, we see growth. And And here you can see that as well. So in particular, these three, which are sort of the manufacturing, space manufacturing related employment areas, they all saw growth even in the second half of the year. So after the pandemic had started in March, compared to, if you just look at overall US employment, clearly we had that huge drop because of the pandemic that's kind of slowly was coming back in the couple months after that. There are a couple of areas where we did see slight drops. So in satellite telecommunications, for example, but relatively small, especially compared to what we saw for the rest of the economy. Part of the reason for that is that space entities were able to continue work either remotely, so even kind of operating satellites and things that always had been done in person, a lot of entities found ways to allow that work to be done remotely. Where they did have to do work in person, so manufacturing of satellites, for example, they were actually relatively well suited to do that within with coronavirus limitations in place. So if you're working in a giant clean room, for example, you are already going to be wearing a mask, being pretty distant from other people, being in a large, well-ventilated space. So, so that allowed some of that work to continue going on. Some of the companies that were more hard hit are kind of the small suppliers, some of the entrepreneurial companies. So maybe people have heard about OneWeb went into bankruptcy and blamed that at least partially on the effects of the pandemic. Bigelow Aerospace as well laid off, I think, all of their workforce at the beginning of the pandemic, partly because of these impacts. And so, there were some effects. Now, the US government did step in to try to help with this. So they, for example, provided funding to a number of small launch companies. They also tried to support some of those small suppliers that are really critical in the space supply chain. But, when things slow down, they don't have as much runway to keep going. So the US government was pretty proactive in addressing those issues. One of the things we see within the US space community, and particularly on the commercial or private side, is that there still is a lot of demand for these space employees. So we see pretty high salaries. You can see almost all of those sectors are above $100,000 a year in terms of their average salary. And almost all of them are seeing salaries continue to increase over the last 5-year period. And so typically when you see increasing salaries, it means, there's a high demand. They're trying to attract more workers. And that kind of goes along with Shelley mentioned that, we're seeing companies are not always able to find all the people they want. This is another metric that makes that visible for us. One of the things that we're really interested in the space workforce are the demographics. What's happening in terms of equity and diversity in our sector. This is something, again, that's pretty hard to measure. So the United States government collects some data on this from the Equal Employment Opportunity Commission, but they do it at an even higher level than the workforce data, the employment data that I just showed you. So for example, while I can track employment for satellite telecommunications, I can only look at demographic data and diversity data at the telecommunications level. So that includes satellite telecommunications, but includes all of the other types of telecommunications as well. But still, I think it's useful to look at that area. So for example, within that sector, 36% of the workforce is female. 18% of the workforce is made up by Black individuals. Although it's important to note when you look at where those individuals are employed, it's a smaller proportion among the category that's called professionals within this data collection. And among executives and senior level managers, it's only 2.8%. So certainly a lot more work that can be done. Aviation Week also collects some data on this for the aerospace and defense sector. So again, it includes space, but it's broader than space. In that sector, they see only about 24.3% female and a little under 6% are Black individuals. Most space companies do not release this data publicly for their own company. So almost every company has some statement about the importance of diversity and the importance of looking at these trends. but they don't necessarily kind of tell you exactly what's happening within their company. Northrop Grumman, I think, is an interesting and important exception to that. They do put out all of their data publicly, so everything that they release to Equal Employment Opportunity Commission, they have up and available on their website, which I think is spectacular and so important for understanding what's happening in the sector. So they are pretty close and maybe slightly better than what we're seeing in overall aerospace and defense. So about 25% female, but close to 8% of their employees are Black, and at least higher than in telecommunications, 6.8% among executives and senior level managers. And then at the bottom, even though we've been talking about commercial sector up until now, I will put NASA as we're going to transition to there. NASA has about 34% of its population, of its employees that are female, and about 11% that are Black individuals. So that kind of transitions me over to talking about NASA. NASA is wonderful about providing workforce information. They have all sorts of data readily available online, which is it's great to work with. So you can see the kind of the trends overall in the NASA civil servant workforce. It's gone down fairly significantly in the first kind of half of this decade, but now is kind of slowly increasing. So there's a big emphasis the last number of years on trying to either decrease the size of the federal government or at least keep it level. And so that's something NASA has been dealing with. How do they keep the expertise they need without having a lot of ability to hire new people? And so you can kind of see that in the broad trends on the left. And then on the right, you can see this is kind of showing the age profile of that NASA workforce. And so each of these colors of a line is a particular time. So if you look at back in 1996, you really had a pretty well distributed workforce where, the majority, the largest part under here is kind of in this middle 30 to 50 kind of age range. But over the years, that has been shifting more and more to the right, meaning that NASA's workforce as a whole is getting older and older. And so you can see this, the most recent one in 2021 is this green one with a peak of workers in that kind of 55 to 59-year-old range. There's, I think, about 10% of NASA's workforce that's eligible to retire. If they chose, could leave tomorrow. So that's certainly something that NASA is taking a look at and making sure that they have a clear transition to keep that knowledge as people leave. And then lastly, for the US, we also try to look at the national security workforce. Space Force is a tricky one since they're very much in transition right now. But they started 2020 with about 2,400 military individuals working there and about 6,000 civilians. And they're going to ramp that up eventually to have about 16,000 Guardians in the Space Force. Pretty much all of those people came from the Space Force. And so Space Force now, as of 2021, no longer has any what they call organic space specialties, people who are very, entirely focused on space. They've all been moved to the Space Force, but they do have some things that overlap. So cybersecurity, geospatial intelligence, people working in these areas sometimes deal with space. And so you'll have some of them in the Air Force, some in the Space Force. And you can see the other numbers here, 28 people in the military, in the Army that work at the Army Space and Missile Center, about 409 who are active duty space operations, so very specifically working on space. Again, a little over 400 in the Navy that are considered part of their core space cadre. And then there's also a number of people in the intelligence community that are working on space issues. So close to 10,000 in combination between the National Reconnaissance Office, does our spy satellites, and the National Geospatial Intelligence Agency that's analyzing that data and turning it into intelligence. And I realize when I'm in presentation mode, I can't see my clock. So Lee, feel free to jump in if I'm getting close to the end of my time. The last few slides here I have are on global.
About 5 minutes.
Oh, perfect. Okay, yeah. I think I'm just on time then. The last few slides I have here are on global space employment. Now, I mentioned to you the challenges of studying what's happening in the US space employment, right? That we have some very good, very consistent measures, but not perfectly measuring space. And we have similar problems in looking at other countries as well. Europe, Japan, and India all have some pretty reliable, consistent data. And the reason we don't include data from other countries, Russia and China, being some of the ones that, of course, we'd love to know what the trends are there in terms of their space workforce, it's really because of the lack of data availability. So you might see a number pop up here or there every once in a while, comes up in a speech or something like that. But there's really no consistent way to see how they're measuring it and how it's changing over time. So we look at these entities as a taste of what's happening globally. Excuse me. So this is showing the European space industry employment. As you can tell, they're really steadily increasing over time. Europe continues to invest in space. And we see that with the European Union kind of engaging in this area and trying to build up their programs with Copernicus, with their Earth observation system. So a lot going on there, and you see that in the workforce as well. In Japan, similar trends. So they're relatively stable over time, but a little bit of growth at least there, especially on the private side, on the industry side. JAXA really has been impressively steady, I would say, over this time, within about 10 employees, one way or the other. And you can see here kind of the distribution of that workforce within Japan as well on the commercial side. Really increasing the number of people they have in terms of space vehicles and building ground facilities. And then on the software side, seeing a little bit more change over time. So some decreases on the 5-year span, but potentially going back up again. And then in India, so it's important to note here, we're looking at, instead of commercial workforce, this is the government workforce. But in India, almost all space activity is done in-house by the government. There's some indications that might be starting to change. Maybe they're getting some kind of entrepreneurial commercial activity separate from the government. But for now, this is pretty representative of the space community as a whole for them. And you can see here kind of ups and downs as well, but coming up again in the recent years. We are able to do a little bit of demographic comparisons across these different areas that we look at. And you can see here, and now we're focusing on the space agencies. So it's there isn't demographic data available for the most part when you're looking at the industry as a whole, the private industry in these other regions of the world. But we can look at their space agencies. That information is available. And so you can see in terms of gender breakdown, relatively similar, between 20 and 34%. NASA is actually doing pretty well compared to others in that area. And then also the age breakdown. So ESA is kind of the European Space Agency is the outlier there. And it's, I think this is a policy decision about how they do hiring, that they don't tend to hire people until they already have some experience in the industry. And so that's why you see such a small number of young professionals within the European Space Agency. And I won't talk about this one in detail, but just to mention that we do try to go out and see, well, what are some of the other countries? Is there anybody else who's posting about how many people they're employing, at least in their space agency, in a given year? And so we try to report on that as well. And I think it's an interesting, just kind of a sense of what's out there, who has space employees, about how many people are coming in and working on these issues from the government side. But you do have to take it with a grain of salt in the sense that, like India, like I mentioned, does almost everything in-house, whereas Russia, who's not on the list this year, but sometimes is included, their government agency, Roscosmos, tends to be just those who are overseeing the activity. And almost everything is done outside Roscosmos in national industries and commercial entities. So the meaning of these numbers varies. And with that, I think I'm finished with the prepared slides and happy to take questions if there are any.
Great. I actually am curious about, you mentioned several things that aren't measured, right? Or that you can't rely on. What is possibly the single most frustrating piece of data that you can't get your hands on in your work?
Yeah. Oh, so many to choose from. So I would I wish we had a better measure of the U.S. space industry. I think it's such an important and growing piece of the U.S. economy, and there's so much interest in it. And yet, at least on an official level, we don't collect data on, a fine grain enough scale that we can really tell what's happening with the space industry, separate from defense, separate from aerospace, or aviation. And so I'd really love to see that happen. And then I think the follow-up to that would be other major spacefaring countries. So like I mentioned, Russia and China, I would love if they would put out, even if not something every year, at least maybe a major report about what's happening with their workforce. There's a little bit of a black box there, and I think it'd be really interesting to understand what they're doing as well.
That's great. Yeah, we had a speaker from the Department of Commerce. She was an economist back in January or February, maybe, whose name is Tina Highfill. So you might chat with her about your dreams. She said that they take feedback on how they're designing their measurements, and it might be a good opportunity for you to put your 2 cents in and push some evolution there in their work.
Absolutely.
Great. And you did get some comments during your talk. Terry Trevino, we have a segment called What's Going On? And Terry Trevino says, hey, Russia, hey, China, what's going on? And Darsh says, NASA is doing much better, even though we need all agencies to be at 50 or more % when it comes to female workforce.
Yeah, and I would, so I want to say too, when I present, especially the information on demographics, and I kind of made this point with putting Northrop Grumman out there, there's a lot of work to do, but I really want to give credit to the agencies and to the companies that are putting their information out, because I think it's hard to make progress and to know if we're making progress without having those numbers. And so I really wish more companies and even more agencies would put that information out there and show what they're doing.
Right, because as Dave Huntsman is pointing out, you can't just magically hire a woman for a job that maybe there aren't as many women in the talent pool to hire, right? They didn't get that degree, right? And so getting the data within the companies means that you learn where you need to provide opportunity farther forward in the workforce pipeline that Shelley talked about, right? You need to, is it elementary school? Is it 8th grade where we're losing all the girls? What do we need to do? And are we seeing gaps as a result of not having a balance of women and men in that job?
Yeah, absolutely. So looking at, a piece that we used to do many years ago is looking at the educational pipeline as well. And what is the breakdown, or what are the numbers and the trends in the different majors that are most relevant to the space industry? And so, it's a really interesting question.
So thank you also to Dave for bringing that up. Well, I think it's been wonderful having you on. I really appreciate you sharing some of those numbers and your work. Really appreciate the collaboration with Space Foundation on the space report. It's sort of critical infrastructure for the space industry, and really appreciate your dedication to that.
Absolutely. Thank you so much for having me here.
All right, our next speaker is Paul Jurison. He is the director of Cal Poly Digital Transformation Hub, leading the deployment of public sector-focused innovation programs. Most recently, he was the director of enterprise systems at Cal Poly, and then he was IT chief at the United States Geological Survey's National Geospatial Technical Operations Center. Paul, it's great to have you back as a speaker. You've been a loyal attendee for many months, and it's always nice to see you and great to have you as a speaker.
Thanks, Lee. Appreciate it. I think you're right. I think I've been at every one of these events from the start, so I kind of feel at home here. So
steadfast and true.
Again, thanks for having me, and I have a tough act to follow. That was some great data Muriel had, and Shelley had some great information there as well. One of the things that I'm going to talk about, which is going to be different, I think, than the last two speakers, is a little bit about how we try at Cal Poly, at the Digital Transformation Hub, how we try to get our students experiential education, so they can look at what they really want to do in the future, and then apply that. So I've got some slides, but one thing you get when you get me is you get a couple of our students too, who are on the screen there. So Charles de Villiers is one of our our students who's doing some research on workforce development and working some with the Foundation for the Future. And Lily Turkstra is a project manager at the Digital Transformation Hub. There she is. And she gets the opportunity to work with me a lot and is doing project management on a lot of our new projects we're working on. So in a little bit, I'll have Charles talk a little bit about the work he's doing as well. But I've got a few slides to go through, and let's see if I can share my screen in the right way. Let's see here.
There they are.
Do this. Does that look all right?
Yes.
Okay. Okay. So just a little bit of a background on what the Cal Poly Digital Transformation Hub is, and you'll see on the screen there it says powered by AWS. AWS is Amazon Web Services is our strategic partner at the Cal Poly Digital Transformation Hub, and what that means for us is that we work pretty closely with AWS on innovation methodologies, design thinking kinds of methodologies. Their tools to do our project. So they've been a great partner for us, and they allow us to do some things that we wouldn't be able to do without a private partner. So we do a lot of that. I'll just do a quick background on Cal Poly in case people don't know about us. So Cal Poly is in San Luis Obispo, California. Our motto is learn by doing. As you can see, ready day one. This looks like a marketing slide, and it kind of is. But some of the information about Cal Poly is that we really focus on hands-on learning, experiential research, real-world experiences. All of our students have that opportunity to get real hands-on experience in lots of different areas. The university's got about 21,000 students. Physically, we're big. We have 9,000 acres. I think it's the second largest by land mass in California. And that makes sense because we're a big agricultural school as well. So we have a lot of agricultural activity going on around campus. Let's see, U.S. News and World Report has ranked us as the best master's level university in the West for 28 straight years. What that means is we don't do PhD programs. So we go up through the master's level, but not PhD. Okay. We have 6 colleges. You can see those on the screen. They're kind of what you might expect. And our engineering school is probably the most well-known. We have a big aeronautical engineering program, I believe the largest in California. And lots of the students from our engineering programs go to work in the space industry with, SpaceX and Vandenberg Air Force Base and all of the big space companies. In fact, Tori Bruno, the CEO of United Launch Alliance, is a Cal Poly alumni. But what I want to talk about today, which is going to be a little different than this, is that we have lots of students that come from other parts of the university who are great options for the space industry as well. It's not only the engineering and astronautics folks as well. So I'm going to talk some more about that. The picture you see on the screen, however, is our CubeSat lab. So we have a lab on campus that develops and builds satellites and launches them. So that is actually a CubeSat that we've developed on the screen there. One of our professors with the cowboy hat is the guy that leads that organization. So taking the next step, the Cal Poly Digital Transformation Hub and our sister organization, which is the California Cybersecurity Institute, we both fall under the same organization at Cal Poly, work a lot with getting experiential education out to our constituents. And our constituents are our students, our faculty, high school students, and other folks who are looking at either upskilling or reskilling their skills. So the Digital Transformation Hub is focused primarily on coming up with innovative solutions to public sector problems and challenges. So we work with nonprofits, government, and education primarily. Every once in a while, we have a commercial company in there as well. But the interesting thing is that we have 7 or 8 full-time people on our staff, and they're, solutions architects and technology folks and public policy folks. But then we have lots of students that work on these problems and challenges with us. And those students, when they work on these challenges, are gaining real world experience, working with real customers, using the latest innovation methods and emerging technologies to help solve many problems out there. Just a few examples. We work with World Bank is one of our largest customers. We do a lot of different work all around the world on that. We have Vandenberg Air Force Base is another big customer of ours, and we work with trying to shorten the time between launches there. We've got a prototype we've been working on there for a while. And we cover a large range of projects. Gender equity in Kenya is an issue we've worked on. So what we're finding is that we have students from, you saw that list of those 6 colleges. We have students from all of those 6 colleges working on the challenges we work on. So some of them are looking at software development, some are working on project management like Lily, some are working on doing policy analysis, some are doing research, but what they get to do is work on lots of different projects in different ways. And what that does is really gives the students a view of what it might be like to work in different industries. One of the things we find working with government industries or government organizations like Vandenberg Space Force Base, I should have said, by the way, they just changed their name, the Vandenberg Space Force Base, or working with city governments, is that we find that students don't think about going to work for a government agency when they're in school. They want to go work for Google, or they want to go work for AWS or somebody like that, until they go and actually look at what some of these government organizations are doing, the NASAs of the world, and they say, wow, look at the really cool things that these organizations are doing. They're launching rockets, they're doing meteorological analysis on launch ranges, they're doing all kinds of really cool things that people don't really think about or know about. So that's what we try to really get the experience into the students' hands, and looking at what it really takes to work in these organizations. So what we try to do then is to instill a variety of things with our students, but and with our customers, right? So on the left side of the screen you'll see in that green box 3 things: innovation, digital transformation, and digital literacy. When we put the Digital Transformation Hub together, the thing we said was, let's go into these public sector organizations who don't tend to be all that innovative, and really talk to them about how they can become more innovative, how they can look at digital transformation across their organizations, and how they can instill digital literacy into their employees so they can move forward into basically the art of the possible, to understand what's possible out there. That didn't work. We walked into these organizations and said those 3 things, and they looked at us like a deer in the headlights. So we had to kind of regroup. We came back out and we said, okay, here's what we really want the organizations to think about. We want them to be able to think differently about their problems, think about who their customers are, who they're solving a problem for, what the benefit is if they can solve this problem, and what is that solution going to look like. We also want them to look at what is possible. What is the art of the possible? If you're using artificial intelligence, or you're using computer vision, what can you do that you didn't know you could do before, right? So a lot of people, and we saw that chart Muriel had, a lot of people have been working in the industry that they've been in for a long time, and they haven't necessarily followed the new emerging technologies and what those things can do. Becoming more digitally literate and understanding what those technologies can do can allow them to think about what might be possible. They don't all have to be AI specialists, but if they have that digital literacy behind them, they can imagine what could happen in the future and how they can make their jobs more efficient. All that comes down to changing the culture in organizations. And again, what we're trying to do here is really look at how we can change, how we can develop the next workforce, the space workforce, but also get people to think differently about how to do their jobs. So when we think about space workforce training, we want to think about who we're trying to train, right? So existing workers in lots of different industries can transition to the space workforce relatively easily because there's similar positions in the space workforce as there is in the traditional workforce. We want to look at K through 12 students and get them interested and excited in working in the space workforce and understanding what's going to happen there and what could be done there before they get too far into their educational career, so that they might look into what it takes to work in the space workforce in the future. And then college students, people who are in college, and the engineering folks, the aerospace engineering folks, kind of already know what's available in the space workforce. But people who are working in areas like psychology and landscape architecture and architectural engineering and communications, there's room for all of those folks in the space industry as well. And what we want to be able to do is instill that knowledge so they know what's available and how they might be able to get into that industry if that's what they want to do. So what are we training the space workforce for? What areas? I think it's almost anything. If we look into the future, if we start looking at lunar structures, if we start looking at Martian structures, if we start looking at living in space, this covers almost everything, right? Engineers, farmers, carpenters, welders, manufacturing folks. We need all of them in the space industry, and we want to make sure people know that they can do that and look at how we can do that. So how are we going to do that? I think getting the core knowledge of what the space industry actually is and what the possibilities are is very important. I talked about digital literacy and getting folks to understand the digital parts of what happens in society today and understanding what the art of the possible is there. We're a cloud innovation center, and one of the things that you can do as a cloud innovation center is become a certified cloud practitioner, which gives you kind of a core basis for what cloud technology can do for you and how it can benefit the work you're doing. One of the things I think about is, what if we had a space practitioner program that gave people, students, K through 12 folks, existing workers, a good baseline on what the components of the space industry are. What do we need to know? What about low gravity? What about radiation? What about the core things that appear in the space industry? So I think that's important to look at as well. And you'll see on the bottom of the screen here, experiential learning, flexibility, adaptability, agility, and learn by doing are all really important things to keep in mind at almost all times, because those things are going to be necessary as we move forward and the space economy grows. There's jobs that are going to be out there that we don't even know about today. So we need to have those characteristics to be able to adjust to much of this as well. Charles, could I get you to say a few words about the work you've been doing so far? Maybe.
So we'll have to make him a co-host so he can unmute himself. Sorry about that.
Oh,
no worries. There we go.
There we go. Okay. Thank you.
Yeah, I think Shelley had said earlier that everyone can be part of the space industry, and I'm a student of landscape architecture, and this was the last place that I expected to be working this summer, but happened to see a job listing, and it has been such a fun experience, and really it's only just recently begun. So I'm having a blast learning about all of this, the space endeavors that we're all involved with. And it was kind of actually interesting. I just came back from South Africa to celebrate my grandma's 100th birthday, and my niece just turned 1 who was there. And my grandma, she was born just a few years after the first commercial airplane flight. And now my niece, she turned 1 just a few weeks after the first commercial space flight. So it was kind of interesting seeing those 2 generations so close to each other. Just quite a difference 100 years has made. But yeah, I've been working with Foundations for the Future and the DX Hub at Cal Poly, working primarily with looking at the workforce that's going to be needed and just compiling that information. And these conversations have been enormously helpful actually in that. And so the first few weeks, really, I was just kind of researching and podcasts and YouTube videos and anything that was relevant. And yeah, I guess as a landscape architect, I'm kind of we actually had somebody who did their senior project at the end of this last year on a Mars colony, and definitely as a profession, it may seem like it is quite far removed from space, but it's actually quite interesting to see just some of the practical applications that people in the program have, like with this Mars colony, been able to have, and yeah, just also I think as a profession, it's kind of at the intersection of a lot of other professions with dealing with engineering and culture and urban planning and a lot of research and adaptability and such like that, that I think is kind of a natural flow into this space workforce. So yeah, it's been so fun to look at things, especially looking at like the arts and things that aren't traditionally thought of. Things like we've looked at with sports entertainment. The last conversation, we were looking at things like horticulture and culinary expertise and even brewing, and there's been some really interesting research that I've been looking at as well on just artwork and cultural centers and how when we look at the moon and the Mars, instead of just looking at it at this kind of destination, this place for conquest, looking at it at this opportunity to update norms and customs and laws and technologies. And yeah, I think the Outer Space Treaty of 1967 was looking at the free access to all areas of the celestial body and kind of this global work that we're all doing to explore and to kind of look at these resources that we all share. So yeah, it's been super fun to be part of the team, and I'm not sure if there's anything more specific you wanted me to talk about, Paul, but that might give you guys just a little bit of a insight in terms of what students in untraditional backgrounds as far as space goes, are actually doing as part of this whole.
Yeah. Thanks, Charles. I appreciate that. Yeah, I think it's always good to get the perspective of the students that we're actually working with, and I think we get some really good feedback from our students on, all of the insights they gain from working in different industries across, lots of different organizations around the world. So, on the screen there today, right now, you see just a listing basically of lots of different areas that can apply to the space industry. And there's way more than than those on the screen there as well. But what we try to do is make sure that those areas that are not necessarily engineering oriented can be focused on as well as far to meet the needs of the space industry. One of the other things that we think is really important is to be able to get information to students who are still in K through 12, in middle school, high school, areas like that. So I wanted to show a couple of areas where I know things like this are happening today. We work with a group in Argentina called Open Space, and Open Space really tries to get their students involved in the space industry early. And they do this through a challenge sort of process where they're developing CubeSats that are going to be launched into space. They work on lots of different things like ground stations and those sorts of things. And they really try to immerse their students in the space industry to get them interested in moving forward into the future. At Cal Poly, we have another program that's called the Space Grand Challenge, which is an international program it's actually a competition related to cybersecurity in space, where we'll do a competition between students from Argentina, this organization here called Open Space, Australia, and and the United States. So we'll have roughly 8,000 or 10,000 students competing in a virtual reality sort of activity where they look at an incident where a satellite has been hacked and data has been compromised on that satellite. And what they need to do is understand how satellites work, how ground stations work, how telecommunications work, and how to do the forensics around cybersecurity to be able to uncover who hacked the satellite, what data they got from that hacking, and what they might do with it. And then they need to present their findings to a group of judges, so they also learn communications techniques and those sorts of things as well. So that's a really exciting thing that we're doing, and we think that will get students, younger students, involved in the industry as well. There's also, and I talked a little bit about this before, but these are some of the projects that we work on at the Digital Transformation Hub, and we're working with Vandenberg Space Force Base on how to make their systems more efficient for commercial companies trying to launch there. Basically, creating a system or a prototype to be able to reduce the time to launch from something like 18 months to 3 months is what we think we can do there. So that's all in work today. We've created some cybersecurity encryption devices for small sats. That's actually going through an STTR project right now, which is also kind of exciting. The other thing that we have at Cal Poly is the CubeSat team. And the CubeSat team, as you saw that picture on that first slide, they basically have an internal Cal Poly company, which is a club, and they're basically a space company. They develop satellites for industry. They have marketing. So in this screen, this is the club. They have marketing folks, they have manufacturing people, they have engineering people, they have e-commerce people. It's basically a company within the university where students who think they might be interested in the space industry can join this club and truly participate in what it's like to be working in the space industry before they graduate. And this is great because not everybody wants to work in the space industry, but you get a feel for what it might be like to do that. And you can come from multiple disciplines to be able to do that as well. Just another example of what might be able to be done there. And then lastly, I wanted to talk a little bit about where some of the space workforce might come from. And these are folks who traditionally wouldn't think about working in the space industry, but due to some recent developments, like horizontal launch, these are a couple of headlines I pulled out of the news in the last couple of days. So Paso Robles, California is looking at developing a spaceport at the municipal airport. And Lily is actually leading a project on that. So that's an interesting development. There's a company called Agile Space Industries in Durango, Colorado, small town in southwest Colorado, that's bringing space-related jobs to Durango. We've been working with an organization called the Rural Innovation Network, they're a nonprofit who's looking at how to bring technology-based jobs to small cities around the country of under 50,000 people. So they have about 20 cities they work with today. And we're working with them from the Digital Transformation Hub as well to try to bring some technology to them.
Paul, if you'd like to give Lily just a moment to speak, though she'll have about 2 minutes.
All right. Lily, why don't you tell us a little bit about your background and the work you've done so far at the Digital Transformation Hub?
Yeah, absolutely. So I'm coming in as a fourth-year psychology major at Cal Poly, and I'm looking to going into human factors engineering and sort of human-centric design. And through the work at the DX Hub, I've really come to learn and see how influential that is in the space infrastructure and that workforce area. And especially through this conference today, I've come to learn so much about all of these different intersections and people and jobs where not just engineers and the typical aerospace centric people going into those fields can get into space and that sort of thing. So it's been very helpful and interesting to be involved in this. With the DX Hub specifically, I'm helping to work with the city of Paso Robles to develop a spaceport and go through their FAA spaceport application for their license. And so that's been a very interesting experience as well, and helped me gain some experience and interest in that realm as well.
Thanks, Lee.
That's great. Really excited to see more from your group. Paul, we'll have to have you come back and give an update and bring more students. Thank you, Lily.
Absolutely.
Thank you, Charles. Thank you, Paul.
Love to do that.
Our next speaker is Dr. Greg Autry. He is the recipient of the 2021 Space Advocate of the Year Award. He is launching the Thunderbird School of Management's Executive Master of Global Management in Space Leadership, Business, and Policy, which was our generous sponsor for our Saturday Space segment today. He previously taught technology entrepreneurship at the University of Southern California, strategy, macroeconomics at the University of California at Irvine, and space entrepreneurship in an International Space University program at the Florida Institute of Technology. Dr. Autry served on the 2016 NASA Agency Review Team and as the White House liaison at NASA. He was also nominated to serve as the Chief Financial Officer at NASA in 2020. Dr. Autry currently serves as chair of the Safety Working Group on the Commercial Space Transportation Advisory Committee at the FAA and as vice president for space development at the National Space Society. He writes for and appears on major media and newspapers on a regular basis. Thank you so much for joining us today, Greg.
Thank you very much. I'm glad to be here. And I want to give a shout out to my Cal Poly friends. I was a Cal Poly Pomona undergrad, great organization. I'm going to, if I could, share some slides to get started here.
I'll let you know when we can see them.
Is my share up?
Yes, we can see them, and they're fun.
Okay, fantastic. So I entitled this talk, Take Me to Your Leader, Fixing the Future Leadership Gap in Space. And I think this is a perfect opportunity to talk about that in the context of our national infrastructure needs and in just the boom that's going on in the space industry, which is an exciting time to live. I actually started studying the commercial space industry back in 2003 when I began adjunct teaching at the University of California, Irvine. And at that time, I got the attitude from a lot of my peers in the business school that this wasn't really a thing, that space was a government domain, that it would stay that way. And there would be a continual conglomeration of large companies coming together until we ended up with two, and that would be the space business. And, you know, I remember saying, there's this Elon fellow, and you're going to hear about him someday. I'm happy to say that they have. And, you know, if you look at the market today, the Space Foundation tells us that we've got a $423 billion market. The folks at the business schools that I taught at for a long time did not understand what that meant. I tried to explain this to my good friends at the Marshall School at USC, where I taught for 7 years. And tried to get them to launch a specific space program. But, you know, they were all into blockchain and crypto, what have you, and whatever the latest Silicon Valley, you know, idea was. They invested a lot of time in nanotech and things like that. And I said, the space is already bigger than those things. Space is 5 or 6 times bigger than the mobile app industry. If you look at the revenues actually generated from the apps, and that's just today. The projections, of course, you got Bank of America saying we're going to go to about $3 trillion. To put that in perspective, that is the size of the entire UK economy, or about twice the size of the Russian economy. So it's a serious thing. We need people to do this, okay? And there's a small percentage of people in our society who have realized seriously that they could work in the space industry. There's excitement about the space industry like there's never been before. And we have a whole generation raised on science fiction. I think if I did a poll and I asked, I think about 15% of the American public probably believes there are people living on other planets or in space stations. It would be interesting to see, but they're used to that idea of a bold future. And I'm excited that we can take them there. So what have we been missing? There's all these news stories, and they've been going on for a decade, right? About the aerospace engineering shortage, and companies are fighting over this, and Congress is going to do something about it, right? So what do we do about that? Well, the obvious thing has been that we need a bigger focus on STEM, and we've been pushing that in K through 12. And we've been working hard, in particular, to diversify our engineering workforce. And I'm excited to see that. I know the Viterbi School at USC, where I taught, made a commitment to make their admittance 50% female, for instance. And there's been a big sea change. When I was at USC, I taught almost entirely engineers in entrepreneurship. So I had an entrepreneurship course for technology commercialization, and they were almost all from the engineering school. And seeing the improvement in diversity coming in from that program just over 7 years was really fantastic. But what are we missing, right? So this focus has been all about STEM, and what we haven't had is space qualified leadership. There's been no official pipeline for managers and executives. And I've even watched people being drained out of NASA into the commercial space sector, which is paying really, really, really good salaries. I did a survey before I helped ASU launch a new program, and the amount of money being offered to these folks is, twice what they were making, even if they were, senior executive service folks making $189,000. All of a sudden, the commercial sector is offering them 2x that. But there's no dedicated business school solution, and there hasn't been. You're going to say to me, but wait, we already have great leaders, right? And yeah, this is a super industry to be in. And I love all the people you see on the screen, and some others I couldn't fit in there. But in some ways, each of these people are a bit unique. And in many cases, they had to take the school of hard knocks to get to where they are. There wasn't a clear path to becoming a space leader necessarily. Perhaps you became a software engineer writing video games, which is how I started my career when I was 18 or even before that. Well, that's one way to become a space executive. Another way is maybe to be an astronaut, right? But there's not a clear normal path to space executive. So what do we do about that? And let us realize that we've had great leaders in other industries in the past, and we need to think about that, because when I talk to people in the space world today about what's going on with commercial space, and they see the disruption that's being brought in by companies like SpaceX and what you see going down there in Brownsville, which is amazing. And then they look at some of the existing companies, and they're perhaps disdainful of the risk-taking or innovation of the management there. And I say, let's think about that, right? Does anybody know who these people are? I've got 3 people on the screen here. Anybody want to type into the chat session and tell me who we're looking at? Tick, 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 crickets. All right. Hughes, okay, so thank you, Goncalo. It's great to hear from you. And Kevin, fantastic. The center person is indeed Howard Hughes, who in between making movies and flying giant airplanes and doing adventurous things, he founded airlines, and he founded a leading aerospace company that has been acquired and is now part of Boeing. Good guess on Glenn Curtis, but no, actually we're looking at Bill Boeing on the left, and we're looking at Alan Lockheed on the right. And the reason I put them up here is these were really disruptive, troublemaking individuals at their time who did wild and crazy things, right? And what happens is that individuals like this generally don't recruit other people who are the same sort of intuitive, natural leaders that they are. It's like there can be only one in an organization. And what happens then is, when they're gone, their organizations are taken over by finance minions and JDs, lawyers, and these people are a lot less risk tolerant, and their job is to deliver value from the company these folks created with great risk taking and iterative development and innovation and crashing airplanes and stuff, and turn that into a continual and dependable cash flow that doesn't have any surprises. All right. We need, for the commercial space sector coming up, to kind of retain what we have in the disruption and keep that innovation going, for the day when, God forbid, we don't have a Richard Branson or an Elon Musk leading us. I hope they live forever, but the reality is we need to have that next generation there. And we need to help the existing traditional companies learn how to dance again. There's a great book by Lou Gerstner called Elephants Can Dance, where he talks about turning IBM into a more responsive organization when it faced disruption from Apple and Microsoft back in the 80s and 90s. And that can be done, but how do we do that? How do we bring the right talent in? So there are some new companies that are interesting. One that is near and dear to my heart was founded out of the Viterbi School at USC, and I had the real honor to follow Tim Ellis and Jordan Noon through their careers since they were students there in the Rocket Propulsion Lab, which has been a great incubator for startups. And Relativity Space is now worth $4.2 billion, and it was just astounding to watch that. But again, Tim is frankly a natural leader, another one of these Elon Musk, Peter Beck sort of characters that is going to figure it out through the School of Hard Knocks. That isn't everybody, that is a great engineer. And so a lot of folks who could take their brilliant ideas forward and turn them into companies, they really need this more formalized training. We can't count on all these unicorns being organically growing. There are other exciting companies. Eternal Light was a group that came out of my program with Andy Aldrin at Florida Tech and ISU that we teach every summer, normally at Kennedy Space Center. We were online last year, but that team's actually going to land a payload on the moon. I'm really excited. And so I wanted to talk that there are some programs coming together to address this management problem, right? At Florida Tech ISU, Andy and I have been doing this program for 3 years now. We just wrapped up a couple of weeks ago, and I see that one of our guests online, Goncalo Estevez, is here. Was one of our fantastic students. It's a really good way if you're interested in getting a commercial space context, and for somebody that already perhaps has a graduate degree, getting this additional certificate is a really good way to apply yourself. And the other thing is the networking is just incredible in this class. We went to OneWeb, we went out to Redwire Maiden Space. We had Vice President of Boeing's Defense and Space Division, Mr. Chilton, come in as a guest speaker. I had Doug Lavaro and a number of other fantastic people, Jordan Noon from Relativity Space, talk to these classes, and it's just a great place to be. So that's one option. Andy and I helped Embry-Riddle Worldwide kind of put together an outline for a program, and he's going to go off and lead that program, and it's a Master of Space Operations, which will include some of this business sort of stuff that we're talking about. It's a fully online program. And knowing what a good job Andy does, I strongly recommend people consider that if they're looking for a full online program. Other schools that are doing this, I have been honored to work with Oxford University on a couple of different series that they've been doing, and there's going to be a whole series of about a dozen videos coming out where I get to interview Oxford academics who are brilliant geniuses in AI, robotics, and other areas, and connect them with people in the space industry and talk about what's going there. And I expect you'll see some educational opportunities come out of that direction. But what I'm most personally excited about is the program I'm getting to launch at the Thunderbird School of Global Management, which is now part of Arizona State University. For those of you that don't know, Thunderbird has been training global leaders since the late 1940s, when it was founded by a group of Army Air Corps officers who realized that after World War II, we were going to be in a new globalized business environment, and that we needed to have leaders that could handle that. So they specifically put together a school, which originally started at Thunderbird Airfield, which is a training field outside of Phoenix, and was run by Air Force officers to educate people in languages, cultures, and the business standards around the world, and help them make that connection. I am excited that the school continues to be visionary and has had the good sense to launch the first real master's program in business designed specifically for space leadership. So the program's called the Executive Global Masters in Space Leadership, Policy, and Business, and will launch this January. It will be a hybrid program in downtown Los Angeles with alternating online weekends. So you do one weekend in downtown LA at our brand new exciting building, the former Herald Examiner building in 11th and Broadway, and then you'll do one weekend online. So it's designed for the busy global executives. You'll need to come into LA once a month. We'll also have a 1 week stint at the Kennedy Space Center, which we're going to be doing in concert with what Andy Aldrin and I have been doing out there. And that'll be an exciting opportunity to get hands-on with the Space Coast ecosystem as well as the California system. So we chose, interestingly, to be in LA, and Arizona State University has a real commitment to LA because that is the hub of so many great things, including the commercial space industry. Faculty, wow, I am just amazed. And this is one of the reasons that although I had a number of offers made to me when I ended up on the job market earlier this year after the Senate failed to get its act together on my CFO nomination and hold a vote, I chose Arizona State University because of what I call the broader space enterprise there. The cross-disciplinary interest that has support from all the way at the top. Michael Crow, the president of ASU, loves what's happening in space now. And they're really interested in bringing together engineering, science, business, and policy and law in a coordinated effort to address this domain. So you've got myself, and I won't introduce myself again, but Lindy Elkin-Tanton, she is an amazing educator, first of all. But the thing that's most exciting right now is she's the PI on the Psyche program, which will launch on a Falcon Heavy this August. So she's really busy putting together one of the most exciting NASA exploration programs in a long time. We're going to go look at a real metal asteroid, one of those things that companies want to mine and turn into the first trillionaire creators. Zahir Ali works for USRA up at NASA Ames and has helped lead a number of NASA efforts there for them, including the SOFIA telescope, which flies on a 747. Jim Bell works at Caltech as the PI on the mass cams on the Mars 2020 Perseverance rover. So when you see those great photos from Mars, Jim did that. He's going to be one of the instructors in your class if you join us. He's also formerly the president of the Planetary Society, the nonprofit organization that I probably admire most in the space area for executing everything professionally and well. Tambi Aganaba, who goes by Timmy, is an incredibly well-respected international expert on space law and space policy. And she brings a really, I think, amazing perception of how did we take these economic opportunities, these physical opportunities, and make sure that there is equity and diversity, and that we get a space domain that works for everybody. And again, harking back to Thunderbird's goal of being a global organization, that's going to be key to what we do. So we're going to have a very globalized cohort, and Timmy will be fantastic in helping us address that. I'm looking forward to teaching the space policy and law course with her. Our dean, Sanjeev Kagram, is, wow, I don't even know where to start. He's one of the most inspiring and passionate individuals that I have ever worked with, an expert in the fourth industrial revolution. And he actually identified that space was probably the most exciting and least properly addressed area for IR, and brought me and Zahir in and launched this program. And, it was just amazing to watch, because at the other schools I've been with, I tried to get them to do this. Sanjeev saw it, Thunderbird saw it. We had cover from the very top at ASU, and the thing came off in record time and with record quality. And I'm just so totally excited. I also want to say industry is on board. They love this idea of getting a new pipeline of space leaders, particularly a more diverse pipeline of space leaders. I had my Thunderbird students out at Virgin Orbit just last week, where Will Pomerantz took us around and showed us what they were doing and really inspired us with their vision. The Florida Tech ISU group with Andy and I, we were just out at ULA's facility at the Cape, and Space Force was kind enough to give us a really nice tour of their whole launch facilities as well. Took students to Rocket Lab last week as well, and I can just tell you, just about every company is like, yes, please. How can we move forward with this? It's an exciting time to be in this industry. So, with that said, have I stopped sharing?
Yeah.
Yeah, great. Okay. Let me see if there are any questions. Can you stump me on something, Michael?
I don't think I can stump you, but I'm happy to ask the questions. How are you, Greg? Good?
I'm excellent. I love talking about this stuff. So thank you for giving me a forum, and always good to talk to you and Lee.
You've been involved with the Foundation for the Futures events, I think 4 times now, if I'm counting right. So we really appreciate you being a regular contributor and being involved here. So I want to ask, who's going to this school, right? Who do you want to show up, and what's the skill that they're going to walk away with?
Right. So what you got is, we need leaders. And by leaders, I mean we need vice presidents, directors of these companies, people who will move up into the C-suite, right? And there's pretty much 2 paths I see coming in here. One is engineers within the existing companies that would like to move up into leadership or get forced into leadership. And this happens a lot in government programs. And I want to be clear, we're training leaders for those too. But it's why Jim Bell and Lindy are excited to talk to us, because all of a sudden you go from being a researcher and you fill out this NASA, application, and suddenly you're a manager and you're managing a giant program with a budget and hundreds or maybe thousands of people working on it. And you're like, oh my God. So there's those folks, right? The folks that have the engineering skill set, understand the domain, need to be given finance, leadership, accounting, and the normal business skills that you get from a business master's degree, but in the context that's appropriate in the space context. The other group is, we've got a lot of people coming in from Silicon Valley or from Wall Street or wherever, saying, I want to be part of this commercial space boom. They've gotten it, right? In the last 18 months, suddenly it's the new religion, and they're throwing money in, and it's like, oh, we're going to do another space launch company. And I kind of want to help them see that there's a much broader picture here than yet another space launch company. Not that there aren't a bunch of great ones, but we all know that there's more to do, and you might be better off putting your money somewhere else. So these folks, investors from Silicon Valley and Wall Street, need education in this, right? Second or thirdly, we've got folks from the tech sector who have been managers. They've worked at Google, they've worked at Apple, they've worked at Samsung or whatever, and they're shifting into the space industry because the jobs are hot and they pay really well and the excitement is there, right? Yeah, the tech industry is kind of getting old now. It's not as exciting as it was when they were young, but you go to the space industry and it's like you have that same feeling. People are doing crazy, wild things, and I want to be part of that. So those folks are going to learn the space context while they hone their management skills. And, frankly, anybody else, people coming out of the military, out of the Air Force or Space Force that want to go into the commercial sector and need the business school are great opportunities. People from around the world that are working for their government that now has an interest in doing something in space. We're getting a lot of excitement from Dubai and the UAE, where Thunderbird has offices. And Thunderbird has offices in DC, Seoul, Tokyo, London, Geneva, Moscow, Dubai, and I'm probably forgetting some. I know we're opening in Australia soon. But anyway, those folks from all over that just want to be part of the ecosystem and like, how do I catch up, right? So we're going to teach you the space context, what's an orbital inclination, how does the rocket equation work without calculus, right? But so that these business leaders have the grounding to make intelligent decisions and don't base their judgments from what they saw in a sci-fi movie.
I've been seeing people, I refer to them as armchair physicists for the last 20 years, right? The people that try to tell professionals how space works. And it always, I enjoy their enthusiasm, but they're just wrong, and it's hard to get that across. I know
we want to teach them when to know what they don't know.
Exactly right. Exactly. So I know you have a really hard stop here in just a moment, literally a minute, but can you do a quick compare contrast between your program and ISU's? I'm thinking the master's program, not the summer session or the Florida program that you run.
Yeah, so we're really the only program that's running a full management, essentially MBA equivalent program that is both global and oriented at the space industry. It's the only one where you're going to get leading faculty that are working, in the space industry. Otherwise, you can get a certificate on top of a degree. But right now, we're the only one. I expect the rest of the country to catch up, and I know there's excitement in other locations as well. I just posted the link there.
School of Mines is going to do a specialty in resource extraction, things like that. There are specialist programs.
There are UT Permian Basin is looking at something. I know that UT Brownsville too. And but anyway, I think we have the best organized and executed. And if you want to be a space executive in January 2023, we're ready to go. It's a one-year program. Goncalo asked, what does it cost? It costs $67,000. There are scholarships from our school, which will help cut that cost down for you. And we're working with industry to get some full scholarships, particularly for underrepresented folks and veterans.
Terrific. I'm really excited about this. I tried building an MBA program for ISU, I think in 2014, and it was deemed, quote, premature. So
it was exactly on time, Michael.
Many years later, I'm super glad that y'all are doing this because it has been a hole in the market for a long time. So good for you, Dr. Autry. Really excited about your program. Have a great day, sir.
I hope to see you as a guest speaker. Thank you. Thank you, Lee.
Thank you so
Bye-bye.
much. All right, that was a great, exciting update and a great statement of the problem. I think Greg's had a lot of experience explaining to people why there's a need for such a program, and now it's a reality thanks to his efforts and those of many others over the years. Just a reminder, Greg helped us get that sponsorship for our Saturday Space program. So thank you again to that program within ASU, where our next speaker is from. To the rest of our audience, if you'd like to become a sponsor to help cover the cost of this programming, simply add a sponsorship to your order when you register for our next event, and we'll be in touch with you for graphics and your selections of what exactly you wanted to sponsor. Andrew Maynard. Dr. Andrew Maynard is a professor and associate dean in Arizona State University's College of Global Futures, an elected fellow of the American Association of the Advancement of Science, and author of the books Film for the Future and Future Rising. In addition to his academic work, Andrew co-hosts the podcast Mission Interplanetary with former NASA astronaut Katie Coleman. His work focuses on the future and how our actions in the present impact it, including the ethical development and use of new technologies. He's also a delightful conversationalist, so we all get to hear his stories today. Thank you for being here, Andrew.
This is great. Thank you so much, Lee, for that. And I'm assuming I'm coming through loud and clear.
We can hear you just fine.
Excellent. So I guess you get a double dose of Arizona State University, and it's great to follow on from what Thunderbird are doing here. That's just a fantastic program. I was going to start off by saying, and now for something completely different, and yet in some ways it's not, because what I want to talk about really does tie in with the workforce and really sort of moving forwards in the business of space and space business, but from actually probably a different perspective than many of you come across it. And it's from the perspective of looking at what we refer to these days here as orphan risks, the sorts of things that are likely to trip you up, but we tend not to think about. But before I get there, I should say a little bit more about myself, so you know how and where on earth I'm coming from and why I'm talking about what I'm talking about. We talked about armchair scientists. I actually started life as a physicist and spent most of my formative years as an academic as a physicist studying aerosols. But for the last, I guess, 15, 20 years, my focus has been on emerging technologies, Early on, it was nanotechnology and engineered nanomaterials, but these days it covers a plethora of different technologies, but not just from the technology perspective, also from the social perspective and policy perspective. And as part of that, I become increasingly interested in two things. One is, where are the unexpected risks that lie between a great idea and its execution? And secondly, how do we ensure that emerging technologies and innovation more generally truly does serve society? And when I talk about serving society, I mean, how does it help us build a more vibrant future, a future that's more full of promise? And of course, this is what we're doing when we're looking at space exploration and humans in space. But at the same time, there are a lot of things that are potentially going to stop us getting there. The third thing I want to say here is I do wear another hat. And as Lee mentioned, I'm Associate Dean for Student Success in Arizona State University's College of Global Futures. And there are lots of ways of interpreting what student success means, but one of those ways is we want our students to A, get a job, B, have a career, not just a job, and C, change the world through that, which means that I am deeply committed to understanding what those career pathways are and how to actually open them up. And more importantly, how to make sure our students have got the skills that they need to succeed in, especially the commercial world. So with that, let me talk a little bit about risk. And some of this is going to connect with space. Some of it isn't, but it's going to be space relevant. And as Lee mentioned, I do stuff around space, but also I think much more broadly here. So this is a story that actually starts several years ago when I was at the University of Michigan. So I mentioned I've worked a lot with tech innovation. I was part of the formation of University of Michigan Masters in Entrepreneurship, which was a venture between the College of Engineering and the business school. It ran for a few years and then ran into some problems. But I was brought in because somebody in their wisdom thought that I knew something about ethics. I'm not entirely sure I know that much about ethics, but I do ask difficult questions around tech innovation. So in running this course on ethics, I realized a couple of things fairly early on. And this was a course where we had master's level engineering students who wanted to set up their own businesses. I realized that ethics really isn't a great thing to be talking about with these students, but I also recognize that there are things that they needed to know that they just didn't get from either the business environment or the engineering environment. And that is how to succeed in an increasingly complex social environment. And it was very clear from these students, and this is clear through all of my career working with entrepreneurs and startups, pretty much all of them had this vision of making the world a better place. Of course, money played a role here, but money wasn't the driving factor. It was actually achieving something bigger than that. And usually it was in a vision to improve people's lives somehow. And yet it was also very clear that they were very naive in terms of how society worked, which meant that they could have great tech, but they were destined to fail at the first hurdle because they hadn't thought through the broader ramifications. And this got me realizing that there was a deep need here, not for teaching ethics, although ethics are important, but helping people understand a risk landscape that goes beyond the usual stuff that we talk about, which typically involves, are you going to kill people? Are you going to harm the environment? Are you going to lose money? There's a lot more to it. And it includes things like, are you going to threaten people's sense of self-identity? Are you going to run up against perceptions that people hold, which they may be wrong, but they can still create barriers? And so through this, we began to create an approach to things that we call risk innovation. And the innovation here is asking, can we think creatively and innovatively about risk? And the answer is yes, we can. And so for the last several years, a lot of my work has been involved with this idea of asking, what happens if we think about risk as either the protection of value, the protection of what we consider to be incredibly important, or empowering us to build what is of value? And the idea here is that a risk is anything that threatens that value or that value growth. And that value growth may be making a better world. It may be going to Mars. It may be developing a plan B. It may be just respecting other people and giving them the possibility, the opportunity to be the person they want to be. And it turns out that when you begin to think about risk in this way, a lot of avenues open up and a lot of pathways to succeeding that we don't usually see. So I'll tell you just one story here. It's actually a case study that we ran on where things failed. And again, it's not to do with space, but you can see the parallels with space enterprises. And some of you may have heard about this particular case. It was a company called Predictive that launched a few years ago. And this was a company that had a fantastic idea. They recognized there was both a problem and an opportunity in the marketplace. The problem was parents who wanted trustworthy, reliable babysitters. And the opportunity was developing an app using machine learning that would allow them to screen out babysitters and identify the ones that are more trustworthy. And the technology that they used was a technology that just scraped the social media feeds of these potential babysitters and gave them a ranking effectively of who was trustworthy, who wasn't. Great idea. What parent would not want this? Apart from the fact that the Washington Post ran an article on this, and people reading it, they went straight to the invasive side of scraping social media and coming to a conclusion about somebody's character. And there was such a backlash to this invasiveness, this invasion of privacy, that the company had to stop trading and they went under. Now, what interests me here is this was a great company with a great idea to make people's lives better, but they were utterly naive when it came to understanding the social landscape and social risks that they were operating in. Because they didn't understand that, they made serious errors that they could have avoided that ended up with them going under. So the question then is, if you're looking at any other enterprise, how do you identify those things that you maybe aren't thinking about because you've had a business or an engineering training and yet are likely to pull the rug out from under your feet? And this comes to the work we do around risk innovation, and specifically the work we do in ASU's Risk Innovation Nexus. Sorry, I haven't got slides. You just have to watch my face or be distracted by my background rather than looking at pretty ASU designed slides. But if you want to check out the website riskinnovation.org, riskinnovation.org, it has a lot of information there. We actually set out with realizing that this is a major problem with businesses and decision makers to come up with a tool that would help people be able to make smarter decisions around their business, around their technology, with just an hour or so of engagement with this tool. We were very naive. We thought, wouldn't it be great if we had a tool where if we just had 30 minutes with a founder or a CEO, it would just change the way they saw the world and they'd be able to identify these orphan risks and navigate around them. And we came up with a 2-page planner. And then we discovered as we began to road test this that it takes a little bit more than 30 minutes to go through this. However, we do have a system where we've seen time and time again that just going through the process of thinking about what you might do that is likely to raise these orphan risk hurdles, you can change your mindset very, very quickly and see opportunities for doing things differently. And so this has been very exciting, and we've been working with a number of organizations on how to do this. But we have reached a challenge, and the challenge is, how do you get people who are trying to use business approaches and new technologies to make the world a better place understand that there's another dimension they need to see and be aware of as they make those decisions? We can do this to a certain degree through training, but there are a lot of people out there that don't have access to that. And so this ties in with another side of what I do that Lee touched on, which is doing a lot of public communication and a lot of writing. And 2 or 3 years ago, I asked myself the question, if I want to reach as many people as possible to get them to start thinking differently about this really complex social landscape around technology innovation, what's the best way of doing it? The first answer was write a popular book. Forget about those boring academic books that nobody buys. Write a book that somebody actually wants to read. And secondly, and perhaps rather naively, it was find a hook that's going to excite people. And the hook that I came to was science fiction movies. Little did I know that it's actually harder to get people excited about science fiction movies than I thought. I thought everybody would just love this. But I went ahead and wrote the book. I actually have a copy here if you're interested in it. It's Films from the Future, the Technology and Morality of Sci-Fi Movies, which is a really clunky title. It's what my editors thought would sell well. I'm not sure it was the greatest idea. The working title was actually, if you'll forgive the language, The Moviegoer's Guide to Not Effing Up the Future, which I think would have sold much better, but they didn't go for it. But the idea is, you take science fiction movies. First of all, science fiction movies are really, really bad predictors of the future, understandably, because they're about storytelling, they're about entertainment. But if you approach them in the right way and with the right mindset, they are incredibly good ways of understanding the social connections between technology in the future. And they do that because science fiction movies are almost always stories about people and society and what goes wrong when you inject technology there. And if you approach them in the right way, you can use them to gain really deep insights into A, what might go wrong around these orphan risks associated with technology and society, and B, how to actually avoid making serious mistakes and get to where you're going. So I'm just going to give you one example out of the book. The book contains 12 science fiction movies. Some of them are very well known, like Jurassic Park. Some of them are not well known at all, like the anime version of Ghost in the Shell. But all of them have different perspectives to bring to how we innovate effectively. And because this is science fiction, a number of them actually connect with space. So we have Elysium there, which is actually a movie about economic and social disparity. And we have Contact there, which is actually, okay, a side anecdote, Contact is one of my favorite movies in the book because it allows us to explore the nature of science and evidence and belief and wonder when it comes to not only science, but exploration. My editors actually told me, 11 great movies, why have you got Contact? Surely this is just make-believe. And I couldn't believe it because as a scientist, Contact is the scientist's movie. It's the movie that gets the heart of what it is to be a scientist. But the movie I want to talk about very briefly is actually an old British movie from 1951, 1952. I forget the exact date. But it's a movie called The Man in the White Suit, which I would be surprised if any of you have seen it. One or two of you may have done. It's an old Alec Guinness comedy. This is Alec Guinness before his Star Wars fame. And it's a story about a brilliant inventor who was actually a material scientist who had this vision of creating a new textile that was virtually indestructible. It was so strong you couldn't break it, and it was utterly stain resistant. No matter what you did with it, it wouldn't stain. And I love the story because even though this was early 1950s, the story deeply resonates with what we were trying to do with engineered nanomaterials back in the early 2000s, when people were very excited about being able to engineer materials at the atomic scale that were incredibly strong and stain resistant. As it is, the movie isn't about nanotechnology, it's about synthetic chemicals and synthetic textiles. But what I love about this movie, it's about a scientist who is convinced that he has the secret to a better future. And in his mind, the secret to a better future is never having to change your clothes. And he is so committed to this that he finds ways of working on this particular problem. He discovers his new textile. He tries to convince this textile firm to buy into it, and then everything goes wrong. And it goes wrong because people suddenly realize that if you've got clothes that never wear out, the bottom falls out of the market. People lose their jobs, people lose their revenue. So he had management against him, he had the unions against him, even his landlady, who made a bit on the side by washing clothes, was against him, saying, what am I going to do when there are no clothes to wash? And the moral of the story, and this is pulled out in the book, is no matter how good your intentions, if you're just focused on the science, you just focus on the technology, and you forget about people and society and how they work, you're gonna fail. And it's incredibly important that you understand this really complex dynamic in society where social barriers can actually stop you doing the good that you're trying to achieve. And the more you understand that social landscape, the more likely you are to actually achieve your ends. And of course, this comes back to thinking about not only workforce developing the industrial base around going into space and humans in space, but thinking about what sort of people do we need in this workforce? Do we need the Sydney Strattons of the world? This was the Alec Guinness character who is just focused on doing the best possible science. Or do we need those people that also understand the complexities of the social environment we live in and can navigate companies through that? So that was a lot of fun writing the book. I actually use this in a course with students. It's a really popular course, as you would imagine, because we get to sit around and watch movies every semester. But the important thing here is, beyond the movies, the more we think about innovative ways of understanding these orphan risks that we face with any sort of endeavor or any sort of enterprise, the more likely we are to succeed. With that, I've said quite a lot, so we should probably allow a little bit of time just to see whether there are any questions or continue the discussion.
Yeah, I'm thinking about Greg Autry's discussion of risk tolerance, and he showed Howard Hughes and Lockheed, and said that great entrepreneurs have a very high risk tolerance. And you're in the business of bringing them down to earth in a way by pointing out here are all these different kinds of risks beyond just the market or the investor risk. You're bringing in a whole ecosystem of risk understanding.
Right.
Have you seen a phenomenon where they just get so disheartened when you're illuminating this, and how does that affect it?
So actually, no, this is one of the challenges that we face with this whole approach. The first thing I would say is I'm not sure I fully agree with Greg. I think there is an appearance of risk tolerance, but I think successful entrepreneurs are incredibly savvy in terms of the bets that they make on risk. Nobody is stupid enough just to close their eyes and just hope for the best. They have a calculus there. It's just that their calculus may not be the same as our calculus. However, we have found in working with companies that there are so many startups where the C-suite team desperately want to do the right things, but the more they think about it, the more they get bogged down in the problems. And it's really easy to brainstorm and come up with 101 reasons why things won't work. And that just stymies everything. So one of the things that we did with our approach and our technique is to force people to just look at 2 or 3 things. So to give you an example of that, the process we would take people through is, rather than just let them stew in their own fears, is say, once you know, or you've got a good idea of what you want to do and where you want to go, first of all, think about your key stakeholders. Obviously, there's you as the enterprise, but also there's your investors, there are your customers, and there are the communities around you. Secondly, think about just 3 things that are of value to each of those stakeholder groups. No more than 3, because more than 3 gets you really bogged down. And then once you've identified those areas of value, think about the orphan risks, and we've got a list of 18 specific orphan risks which potentially threaten those areas of value. So now you've gone from an open-ended problem which is intractable to a closed problem which is highly tractable, because if you can identify just 3 or 4 areas where you can do better to begin to reduce those risks, you've got a pathway forward. And then the final step of this is just asking people to identify 2 or 3 next steps. Don't go off in the deep end, but just think about the small things you can do to get a little bit further and then reiterate. But yes, if you don't do that, we find people either ignore the risks if they're hard-headed, or if they're, I was going to say, if they're sensitive, I'm not sure that's the right word, but if they really care about these things, it's so easy for them to get so bogged down they can't see the way out of the morass.
Yeah, we have had a saying in the oil and gas industry: any idiot can kill a prospect.
There we are.
Yeah. I'm getting, let's see, a few questions. What do you think about the Silicon Valley use of the word disruption versus transformation?
Oh, interesting. It really depends on who you are and the context, and the trends in language. So I would actually step back and say, whatever language Silicon Valley use, it's the bigger issue is attitudes and process and intent. And I'd say that because disruption versus transformation can just be different words for the same sort of thing. What is really important from both a business success perspective and a social success perspective, and by social success, I mean actually building a better future for people, is your intent. What are you trying to do? What are you seriously trying to do? And what are you seriously willing to do to build a better society? And then we can start talking about the types of words you use and what exactly you mean. But just change for change's sake, whether it's transformation or disruption, doesn't actually get us as a society to where we need to be. There's got to be a bigger vision.
Yeah, there's a lot of wheel spinning.
Yes.
I'm just going to read a comment. I'm not sure if it's a question yet. Man in the white suit sounds a lot like a root of some objections to propellant depots, which we had a panel on yesterday. Don't have to throw away expensive vehicles after one use. So yeah, people are seeing live applications. And then Dave Huntsman, who has good comments throughout the day, he points out that Machiavelli wrote about this problem in The Prince. Established interests and not putting a damper on things.
And actually that's a great connection, because I'm not saying anything new here. We know this. It's just that often we forget it. And sometimes I think we need to be teaching our students to sort of understand the breadth of thinking that's gone before rather than narrowing them down.
Wonderful. Michael in the comments has mentioned nanotech. How did this inform your thoughts on risk? Nanotech ideation and research that Congress assigned to you.
So yes, as Michael knows, I'd spent many years at the forefront of thinking around nanotechnology and risk. And for a number of years, my role was science advisor to what was known as the Project on Emerging Nanotechnologies at the Woodrow Wilson Center in DC, which is a think tank. It's a pseudo-government think tank. And our charge was understanding the environmental, the human health, and the social implications of nanotechnology and how we navigate this. So I was very involved in asking questions about what could possibly go wrong and how we get it to go right. And I'll be very upfront here and say my thinking changed quite dramatically over a space of about 10 years or so. And I'd say that because as nanotech began to become a thing in the early 2000s, late 1990s, there were a lot of concerns around what are the potential risks of creating a material that we've had no previous experience of? Are we going to create the next asbestos, to put it bluntly? And so there are a lot of really important questions to ask about what are the consequences of what we're doing. As time went on, it became very clear that a lot of those questions weren't necessarily the right questions. And we still need to be really careful with what we do with materials, how we put them together in different ways, but we need to be really smart with what is off the table in terms of a new risk versus how we formulate questions around new risks. Sadly, I think the whole question or the whole conversation around risks in nanotechnology got derailed because people got so obsessed with the world being so different below 100 nanometers that they thought that something down there is going to kill us all. The reality is the physics says actually there aren't sharp transitions. There are some really interesting things that happen which give us access to new properties. But when it comes to human health impacts and environmental impacts, things are not so black and white. So yes, what I took away from that was we have to be much smarter in terms of the questions we ask. We may need to be much more willing to change our perspective based on the evidence and not just stick to what we assume is the problem. And we need to be able to recognize what is truly a problem versus what is an assumed problem. Mm-hmm. I really wish those lessons had transferred over to many other areas of tech innovation.
Yeah, it's sort of bringing you, even though that was a specific project, it's getting a little bit more of that macro view of some of the key problems for industry.
That's right. And I would just add, any sort of new technology comes with risks. And I seriously don't want to discount the risks here, but we need to make sure we ask the right questions, because if we go down the rabbit holes of the wrong questions, we're never going to get anywhere.
Old technologies come with risks also.
Yes.
That don't ever really go away.
Right. And actually, I'm sorry, I got to say one thing to that. So on that particular point, and this is actually fairly integral to risk innovation thinking, and it's something I tell my students. So often when we think about risk, we think about how we eliminate risk. But the reality is risk is part and parcel of life. The only way you can be risk-free is to be dead. That's the long and short of it. And we don't want to be that. So we have to learn how to live with risk. It's not a case of getting rid of risk, but it's learning how to live with it and live with it effectively and pragmatically.
That's so true. Yeah. Talk, now that we're sort of on that macro scale, talk space specifically just for a minute, because I do have one final question for you. And what are some of the key things that the space industry you think is missing in recognizing risk? So
I would actually come back to the social risks again. Space industry, just by the very nature of it, is very keyed in with traditional risks around harming the environment, harming people. There is another layer of risks there that we're just beginning to deal with. So space debris is as an obvious one. As space and the muck in space becomes sort of more crowded, how do we navigate around that? But the biggest challenges are going to be the political and policy challenges. How do you navigate sort of moving forward with space in a really complex and convoluted policy environment? And secondly, the social challenges. How do you get public trust and public buy-in for what you're attempting to do? And I think any company that doesn't take the policy question and the social question seriously is really going to flounder.
Yeah, no, that's wonderful advice. Heard a lot from various experts on space traffic management about the challenges of even deciding who's in charge of regulating it. They've built for 10 years just having arguments about, well, you're in charge now, and you're going to regulate this. No, you. And so it's a layer before even being able to make any regulation.
Right.
As a final question, I want to ask you to tell us more about the Mission Impossible podcast and maybe a favorite guest or conversation that you've had.
Oh, yeah. Thank you for that. So yes, Mission Impossible podcast actually comes out of, sorry, did I say Mission Impossible? I always fall into that trap. Mission Interplanetary podcast comes out of ASU's Interplanetary Initiative, which is, I think Greg might have touched on it because it touches on what Thunderbird is doing. It's a big initiative where we're looking at really transforming how we think about humans in space. But the podcast itself was set up as a series of conversations between myself and former astronaut Katie Coleman and our guests to explore different aspects of humans in space that maybe haven't been addressed in the same way before. So interestingly, and you can check it out on any podcast platform, we have far more women than you usually see in these interviews, which was something that I was very excited about, to get that different perspective on what it means to be humans in space. And we had conversations around fairly common things like space debris, but also questions about, should we send an all-women team to Mars, for instance? The conversation that I think I loved the most was one that might be unexpected, and it's one on decolonizing space with Natalie Trevino, who recently just graduated with her PhD. And I love the conversation because Natalie is deeply enthusiastic about space and humans in space, and yet deeply concerned that we don't make the same mistakes of the past where the West has colonized countries and we're still dealing with the legacy of those problems. So it's a conversation about thinking differently about our presence in space. And it was one of those conversations where I learned as much as I sort of gave into the conversation. But I would encourage everybody to check out the Mission Interplanetary podcast. It was a blast making it. And I'm really pleased and really proud, actually, with what we produced there.
That's wonderful. I'm looking forward to following that, and I'm sure our audience will see how easy you are to talk to and look forward to that as well.
Thank you.
Thank you so much for joining us. It's been great to have you, and we'll have to get an update down the road.
Absolutely. This has been a pleasure.
Thank you. All right. Thanks, Michael. He made the introduction for us. Next up, we have the winners of the NewSpace Business Plan Competition. Very excited to hear who the judges have nominated as their winner. Thomas, why don't you come on and let us know what you all talked about, the secret confab on a separate console, and let us know how this turned out.
Okay, I get all my notes out here. It was an interesting conversation, but at the end of it, one team did emerge. All the teams, the judges felt that all the teams were worthy of funding of some kind, worthy of attention in their respective areas, their respective markets. But one company in particular stood out about a head above the rest because they offered just a great example of a really well done investor pitch. They knew their market, they knew where they fit into their ecosystem. They had a good discussion and focus on the conversations with their customers and offered substantial benefits and solutions for their customers. They'd already raised some funds, which gave them a good start and some traction and some experience in raising capital from outside sources. They already had some commitments to customers, and they have a good overall team business experience. They were in fact impressed with the initial outreach and commitments that they've made so far. It's in a very viable market sector. I mean, starting a company like this is difficult, but they all felt that the team for this company is really well positioned to grow maybe exponentially. So having said all that, the winner of this quarter's all virtual NewSpace Business Plan Competition is Esper Satellite Imaging from Melbourne, Australia.
Bravo!
They're here because it's about 5:30 in the morning there now. They're probably getting some much deserved sleep. As I told them in my email to them this morning, it says, given all the time zone differences, you need not be present to win.
That's great. Yeah, I think we've talked several times throughout the day about technology transfer and the value of terrestrial applications to business plans, and that was one where they seem to know their market and how that could benefit life on Earth.
Yeah, so they get the win. They get a few bragging rights, and they get a lovely $5,000 check, courtesy of our sponsors, Foundation for the Future. Thank you, Tim, so much for helping us put this thing on and making it. We're trying to make it better and better every time. And so I'm really enjoying this experience. I hope you are too.
Yeah, no, and definitely a deserving company. Really liked their pitch and excited to see where they go from here.
And this is why this is part of what we want to do too. And in future events, we want to really keep tabs on the people who have been through the program and see how well they're doing and where they're going and what kind of traction they're getting going forward. So yeah, it was a really great time. I'm sorry that one company couldn't join us today. That would have made the judge's job even harder. But maybe if we're lucky, we'll get them to come in November. So
absolutely, yeah.
The only other thing, coming events, we're still working. I can't really formally announce it yet, but we are working on a live BPC event for International Astronautical Congress in Dubai in late October, and we'll see how that goes. And if things come together the way I hope they will, very, very soon now we'll be able to make an announcement, and we'll let you guys know so you can make the announcement to all your followers as well. And you never know what we're going to get out of that one. That's it could be very interesting. And of course, our own event here at Conversations for the Future will take place in November. And I'll be sending up the signups and everything and the information for that probably within the next 2-3 weeks. So stay tuned for that at cscf.space. I will put that in the chat. So everybody has the link. Okay, there you go. Unless you have questions, that's all I got. Congratulations to Esper Satellite Imaging.
Tim,
and for everybody else.
Do you have any celebratory words for Tom and the judges?
Just congratulations to Esper Satellite Images. It's like I said, really a well done presentation. They've got a solid product, and I really like the rotating cast of judges you're bringing, Tom. High caliber people every time, and it's awesome to be able to get different perspectives rotating through. So
Like I say,
thank you so much.
Thank you. This is the 20th BPC that we've done over an 11-year period. So, and we're almost at a milestone. I think we're coming really close. I'm gonna have to do the math again. I think we're getting really close to the $400,000 mark of funds awarded to deserving teams.
You'll have to do an all-star competition where your top winners come back and compete against each other for the major title.
Yeah, I think we're gonna have to add a 0 onto the prize though.
Probably.
Just to give them some incentive. I'm just saying.
Yeah, maybe a where are they now is more of a draw than having them compete again if they're all out there being successful in the world.
That's true too.
Yeah.
I'd rather they be out there and be successful in the world.
Yeah.
I'd rather have maybe a panel discussion sometime where a lot of the winners can come back and sit down and share their war stories.
Yeah.
And,
that'd be awesome.
I think that would be great.
Yeah.
We've done that before in a live conference. And I think it would just be an excellent thing to do. If you guys would consider that, that would be marvelous.
Yeah.
I'll book it for November. That's great.
Okay. Well, even better. Okay.
All right. Well, this ties so well in with so many of the discussions that we had today about entrepreneurship and the workforce pipeline, allowing people to thrive in space business as well as in space. Thank you so much for bringing the NewSpace Business Plan Competition to our venue, Conversations for the Future, and we are looking forward to November already.
Oh, it's my pleasure to do it. It's a joy for me.
Great. Well, this marks the end of Conversations for the Future Workforce and Industrial Base. We had great discussions both on screen and in the chat. It's always lively over there. And on September 8 and 9, which is a Wednesday and Thursday next time rather than a Tuesday and Wednesday because of Labor Day, we'll be back with Conversations for the Future, Space Garbage, Recycling, and Sustainability. Finally, as you bask in the afterglow of these 2 days of engaging and informative conversations, take a cue from the Thunderbird School of Management's Executive Master of Global Management in Space Leadership, Business, and Policy, and consider sponsoring our next event. I am Lee Steinke with Foundation for the Future, and I look forward to seeing you in September.